Okay, today we are going to learn about concept behind solving the points problem. Okay, so we know how to solve the points problem. So there is a concept here. So basically it involves three basic concepts. So based on these three basic concepts, we are going to solve the points problem. Okay, well, now we'll see what are those basic concepts behind solving the problems. So we can take concepts for solving points problem. So here there are three concepts or conditions by which we can solve the points problem. So the problem is very easy. So first concept here is identifying the quadrant. So from the question we need to identify which quadrant it is. Okay, if I say an example, say if a point is lying 30 mm above HP and 20 mm in front of AP, means it is in first quadrant. Okay, like that, first thing is we need to identify which quadrant. Either it is in first quadrant or second or third quadrant. We need to identify. So the first thing is we need to identify the quadrant. Similarly, you can say that if a point P is lying 30 mm behind of AP and 20 mm below of HP, that means in third quadrant. So that is the first concept. That means we need to identify the point is lying in which quadrant. Okay. Now, second concept is writing the conventions for the identified quadrant. Say we have been identified it is in first quadrant. So what is that? The convention for the first quadrant means we need to write it in by means of xy with the VP HP. Okay. So this is the convention for first quadrant. Say we need to write it in terms of orthographic views. Okay, that's what writing the conventions for the identified quadrant. Say we have been identified, say the point A, say 30 mm above HP, 20 mm in front of AP, it lies in first quadrant. Say if it lies in first quadrant means with respect to first quadrant, so what is the convention for it? So that is our second concept. Okay, that is our second concept. So now it comes with the third concept, that is nothing but visualization. So visualization is very important concept. So now we will discuss deeply. So how a visualization will be. Okay. So now you understood, right? There are three basic concepts for solving the points problem. One is identifying the quadrant. That means we need to identify the point. Either it is lying in first quadrant, second, third or fourth. Next, with respect to the quadrant, we need to write down the conventions for it. Okay, that is writing in terms of HP, VP with respect to the XY line. Now the third concept, it is nothing but visualization. Visualization means we will be seeing how we are looking the thing. Okay, how we are looking the thing. So that's what the visualization. So how we are looking the things from it. So we can able to define what is exactly the visualization is. Okay. So now we see what is visualization is. So in the visualization, this is a very important concept. So in the visualization, I will take bit by bit one of the each of the concept. So first take I define now a point is lying above HP or below HP means it is an front view. So what is this? If a point is lying above HP or below HP means it is an front view, means it is based on the visualization. Say if I take this one, so this is our horizontal plane, correct? This is our horizontal plane. Say if any point, say consider this is our pen. If it is lying above HP or below HP means, so this point which is having certain distance from this horizontal plane, okay, say some 50 mm above HP or 30 mm below HP, this distance plus weave can be projected on the vertical plane, correct? So you can say that if any point, if it is lying above HP or below HP means it is an front view, because the distance from that particular HP plane, if it is above HP or it is below HP, it can be seen only from the front view. That's what visualization, how we are looking the things, okay. If the point is lying above HP or below HP means it is an front view, okay, because the point how much farther from this HP plane, say 50 mm, 60 mm above HP, can be seen from the front view. Similarly, a point is below HP, how much below of it, say 100 mm, 50 mm, 20 mm, how much it is farther from it, it can be seen only from the front view. That's why if any point lying above HP or below HP means it is an front view, okay. So understood. So now similarly we can write it for the second one, okay. If any point, okay, any point is lying in front of VP and behind of VP means it's an top view. So how it is? So second concept, say if any point, say this is our front, this is our vertical plane, correct? Vertical plane. If any point it is, say if it is lying in front of VP or behind of VP means this how much it is front or how much it is closer to it, it can be seen only from the top view, correct? Only seen from the top view. Say if any point it is lying in front of VP or behind of VP, it can only be seen from the top view. How much it is for, say 40 mm in front of VP or 50 mm behind of VP, it can be seen only from the top view. That's why it is an top view. You can see that if any point it is lying in front of VP or behind of VP means it is an top view, okay. So that's how we are going to visualize, okay. If any point, here point P, say it is some 50 mm in front of VP or 40 mm behind of VP, it can be seen only from the front view, okay. So now we all understood, right? This is how we can able to visualize, okay. Say I am going to repeat it again. If any point is lying above HP or below HP means it is an front view, because we are able to see the things from the front view. Similarly, if any point is lying in front of VP or behind of VP means it's an top view, because we can able to see the distance, how much it is nearer or farther from this vertical plane can be seen from the top view, okay. Guys, you understood?
Today we are going to learn about basic concepts related to visualization. Okay, so in this we will learn bit by bit. If a point lies above HP and on VP. Okay, so if a point lies above HP and on VP, you will be hearing this word on VP for the first time. So be remember, on HP means it is top view. Okay, so above HP means we know that it is front view. So we need to find out what is front view, where the front view it is lying. Okay, so we know that in quadrant system there are 4 quadrants. Okay, so this is our first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so you can see that if a point lies above HP and on HP, we already got the top view. Now we have to look for the front view. So above HP means, this is our HP plane, correct? HP plane is our vertical plane. So above HP means our point, the front view can lie in either in first quadrant or second quadrant. So that's what. So the front view, can write front view can lie in first and second quadrant. Okay, so the point will be lying, that is the point will be lying in first and second quadrant. Okay, now we'll see the second concept. If a point if a point lies in front of VP and on HP. So we know that on HP means it is front view. Okay, so on HP means front view. We have to see further in front of VP means, so in front of VP means it is top view. So where the top view will be lying. So in front of VP means this is our vertical plane. In front of VP means there are two chances. Our front view can lie in first and fourth quadrant. That is, we can write, so top view can lie in first and fourth quadrant. So that is, point will be lying in first and fourth quadrant. Similarly, okay, if a point lies behind of VP and on HP. On HP means it is front view. So behind of VP means it is top view. So we have four quadrants. Vertical plane. This is horizontal plane. This is our first quadrant, second quadrant, third quadrant, and fourth quadrant. So top view behind of VP means there are two chances. The point may, the front view may, sorry, the top may lie in second and third quadrant. So I can write top view may lie in second and third quadrant. So that is, point will be lying in second and third quadrant. Okay, similarly, if a point lies below of HP and on VP. So and on VP means this is our top view. So below of HP means it is front view. Okay, so below of HP means we have to see it. So below of HP means two chances. The point may lie in third and fourth quadrant, that is front view. So we can write front view may lie in third and fourth quadrant. It is, point will be lying in third and fourth quadrant. So the point may be lying in third and fourth quadrant. Say if a point lies below HP and on VP means below HP means two chances, third and fourth quadrant. So the front may lie in third and fourth. That is, finally the point will be lying in third and fourth quadrant. Today we are going to discuss problem of points on side views. Okay. So in this problem, so we will be dealing with the side views here. So we will go with the question. A point P is lying. P is 30 mm in front of VP, 40 mm above HP, and 50 mm from RPP. Okay. So in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw this first quadrant, top view and front view. Okay. Okay, so we know that 30 mm in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means 3 boxes, and you put a point. So that is here the top view. Similarly, 40 mm above HP. So 40 mm above HP means it is our front view. It is 4 boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. You can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane, it is adjacent to the vertical plane. Okay. So in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view, we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 line because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point, then draw a straight line. This is your angle line, that is 45-degree angle line. Now from this top view, so we'll be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the and we can show the direction of the projection line. Okay, so this is what the side view. Welcome to Engineering Visualization channel. Okay, today we are going to see problems on points problem. Okay, so as we have discussing the problems on points, okay, so it is one of the different type problem. You can see in this problem they have not given any kind of dimensions. Instead of it, so using the concept we have to solve the problem. Okay, you can see the question here. Draw and state the quadrants in which the following points are located. Assume any distance. That means the distance you can take any of it. Okay, you have to identify which quadrant each of these points are locating, and then you have to write it by assuming any distance. Okay, so you can see front view below xy line and top view above xy line. So it is third quadrant, right? So I'll write here only. It is third quadrant. Similarly, front view and top views are below xy line. So this is fourth quadrant. Okay, front view and top views are above xy line. It is second quadrant. Okay, front view above xy line and top view below the xy line means, so it is your first quadrant. Okay, so it is easy to write. So first I am going to draw one xy line here. Okay, so here they have not mentioned to take exact distance, so conveniently you can take any of the distance. Okay, first I am mentioning this, the point here. Okay, front view below xy line and top view above xy line. So front view below xy line means this, I am taking convenient distance and I will put a point. So this is a dash. Similarly, this is a top view above xy line. Okay, this is your third quadrant. In the same way, leaving convenient distance, front and top views are below xy line. So I'll be mentioning here. Okay, both on the same line. I'll mention B dash. Okay. Next, front and top views are above xy line. So above xy line means I'll give one as 30 and another will be on 40. So here C and C dash. Next, fourth line, that is a point number D, front view above xy line, front view. So here I'll mention front view. This is D dash and top view below the xy line. So here it is. So here we have assumed any of the distances. You can assume it. It is given in the question. Okay, so that completes the problem. Okay, you can mention, if you want to mention, you can mention here A is in third quadrant. Okay, and B is in fourth quadrant. Okay, similarly C is in second quadrant and D is in first quadrant. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Okay, today we are going to discuss another problem on LPP, that is a side view problem. So the first problem we have done with the right profile plane. So now we are going to do the problem with respect to the left profile plane. Okay, so we know the procedure. First, to identify the point is lying in which quadrant. The point is 40 mm. A point, you can say point B here. Okay, point capital B is 40 mm behind of VP and 20 mm above HP. So it is in second quadrant, behind of VP and above HP. So for the second quadrant, so we have vertical plane, horizontal plane lying above the XY line. Okay. So XY, another both vertical plane and horizontal plane lying above the XY line. Now 40 mm behind of VP. So behind of VP means it is top view. Okay, behind of VP means it is top view. So I'll be drawing here 40 mm means 4 box. So So it is small b top view. Now 20 mm above HP. So above HP means it is our front view. So the same collinear line we can mention 20 means 2 boxes. It is b dash. So now we can show the dimension here. So it is 20. So it is 40. So now we have done with the both top view and front view. Now we have to do the side view. So you can see in this from 30 mm front, behind are from LBB. So that means from this projection we have to consider 3 boxes here. Okay, 3 boxes here, and we will be drawing a dimension line. Okay, that is 30. So here exactly leaving a 3 boxes, that is 30 mm, we will be drawing a projection profile plane, that is x1 y1 LBB, that is a left profile plane. Okay, so now we know the procedure. Where there will be a top view, we have to draw an angle line here. So we will be doing the same procedure. So intersection of these two lines here exactly, so we'll be marking for 45 degree. Okay, so it is 45 degree. Now from this point, so we have to draw a straight line, and we know that with respect to the front view we have the side view, so that's why I'm drawing a straight horizontal line adjacent to it. Okay, so from the intersection of this point, okay, from the top view intersection to the 45 degree line, so we have to draw downward. Okay, so here at the intersection of these two lines, so we get an side view b double dash. Okay, so b double dash, so this is what the direction of the projection line. Okay, now in this question they have mentioned name the side view, which view it is. So it is a second quadrant, in second and fourth quadrant. So it comes to the, you know, that second and third quadrant comes under third angle projection. Okay, so it comes under third angle projection. So in third angle projection, what happens with respect to the LPP, we have left side view. Okay, with respect to the RPP, we have right side view. So this is left side view. So this is, we can write here, left side view. Okay, so today we are going to learn on a single point how two or more views exist in a points problem. So we are going to discuss. So you can see the question. A point 30 mm above xy line is the front view of 2 points. You can see in this question, a point 30 mm above xy line is the front view of 2 points A and B. Okay, for the 2 points A and B is mentioning the front view, that is A dash and B dash, it will be lying above the xy line but a distance of 30 mm. Okay, so that's what it is directly mentioning. So we will be proceeding with the question. Okay, how it's mentioning. So this is another type of problem. Okay, so in this problem he is mentioning 30 mm above xy line, as we will be proceeding with the question. So 30 mm above xy line, so we drawn 30 and we have put a point. So this point 30 mm above xy line, it is indicating front view of 2 points A dash and B dash. So we'll be showing the dimensions. Okay, so that is our front view. Okay, the single point which is indicating two views, and it is lying at a distance of 30 mm above xy line. We have done it. Now we have to see, this is what the front views. Now we have to see for the top view. The top view of A is 40 mm behind of VP. So you can see the top view of A. Top view of A is 40 mm behind of VP. So behind of VP means, there are two chances. So this is behind of VP. So either the top view can lie in second quadrant or it is in third quadrant. Okay, so we see in the third quadrant, so HP VP, so the top view is lying above the XY line, and third quadrant also HP, it is lying above the XY line. You can see in this, the point A is 40 mm behind of VP. Behind of VP means two chances, either it is in second quadrant or third quadrant. In second quadrant also HP will be lying above the XY line, and in third quadrant also HP will be lying above the XY line. We know that the top view will be drawn in the HP planes. So that is, when you collinearly we have to draw the top view. Okay, already we have drawn 30. So we will be extending by 10 mm. Okay. So put a point, that is our top view. So 40. Okay. Now similarly, the top view of B is 45 mm in front of VP. So the top view of B is 45 mm in front of VP. So in front of VP means we know that there are two chances, either in first quadrant or in fourth quadrant. Okay, so in first quadrant, so where the top view is, so in fourth quadrant, so we know that HP VP lying below. So you can see this in the first and fourth quadrant, in both the cases the top view is lying below the XY line. So that means we will be drawing below the XY line 45 means 4.5 arcs. 1 2 3 4 4.5 arcs. Here you have to draw till here. So put a point, and this is your top view. Mention with the dimension line. Okay, so this is what the problem of on a single point two or more views. Okay, today we are going to learn about shortest distance problem in points. Okay, so they will be giving the shortest distance in this problem. So nothing but a arc distance we have to consider here. So in this type of problem they will be mentioning about only one view. Okay, using the shortest distance we have to construct all the three views. Okay, now we proceed to the question. You can see this is shortest distance problem. A point A is 20 mm above HP. Above HP means we know that it is front view, so we get it about the one view, and it is in the first quadrant. That means he is telling that we have to consider the first quadrant, that is VP above XY line and HP below the XY line. And then after that he is mentioning, and its shortest distance from the XY line is 40 mm. That means arc distance of 40 mm you have to consider to construct it, and then draw the projections, determine its distance from VP. Okay, so you all understood, right? In this problem they are mentioning only one view, that is front view, and then they have given the hint that we have to consider the first quadrant, and then they have given the shortest distance. So shortest distance means arc distance. So arc distance, that means we have to consider a compass here. Okay, so we know that it is in first quadrant here. So VP above the XY line, HP will be below the XY line. So we will proceed with the question now. Y. So you can see this 20 mm above HP. So 20 mm above HP means, so it is in first quadrant. So HP VP we have written. Above HP means it is our front view. So that means I'll be drawing the front view first. So 20 mm is 2 box. Put a point, that is A dash. Okay, so 20 mm it is done. Now you see that, so it is in first quadrant, we know its shortest distance from the xy line is 40. That means shortest distance from the xy line is 40 means we have to consider here, so x1 y1 line, okay, means from that intersection of that x1 y1 profile line we have to draw an arc here. Okay, so for that we have to consider a scale here, and we have to consider 40 mm. So take compass and measure 40 mm means 4 centimeter. So from this point to here take exactly 40 mm. Okay, so from this intersection point of this, okay, from this intersection point of this you draw an arc. Okay, after drawing the arc you mention the radius, okay, R40. So mention it R40. So after this what we do, after drawing an arc, so from this front view we will be drawing a straight horizontal line, okay, as it is intersecting this point arc. So this point is nothing but our side view, that is A double dash. Okay, now we have to draw an top view. So for that what we do, so here in this case we will be drawing an 45-degree angle line. Okay, all the three views you have to draw, right? So for that we will be drawing 45-degree angle line, 40, 45. So we can mark a point here. Okay, so this is our 45-degree angle line. Okay, now we can draw from this side view a vertical line until it touches the 45-degree angle line, and then draw, and from this point you draw an straight horizontal line. Okay, okay, we know that the front view and top view are there in a straight collinear line. So we'll be drawing a straight vertical line here. Okay, so where these two lines are intersecting, this point is our top view. Now we can measure the dimension because it is mentioned in the question. You can see that draw the projection, determine its distance from VP. So we need to measure. So it is around 39 mm. Okay, so it is around 39 mm. So you can mention 39 mm. So this is what our shortest distance problem. Let us see different type of problems in points. Okay. Now you see 2 points RS are on HP. So R on HP means we know that these are front views. Okay, so front views are on HP means these front views will be there on the XY line. Okay, so 2 points R and S are on HP means, so these are front views. So these front views will be lying on the XY line. Now we see the point R is 35 mm in front of VP. Okay, so in front of VP, so R is 35 mm in front of VP. So in front of VP means two chances, first quadrant and fourth quadrant. So in first quadrant, so in front of VP means we know that this is top view. So VP HP below the XY line. So here XY HP VP. So in both the cases, so this R top V, it is lying below the XY line. Okay, so now we will draw the first the top V. Y. So first I'm going to draw this top V or 35 mm below the X line. 35 means here 3.5 bucks. 1, 2, 3, 3.5 bucks. So till here. Okay. So the point, this is small r. Okay. So small r top V. This is 35. So we know that 2 points R and S are on HP, means these are front views. We know that top and front view, it is collinearly joined. We know that front view of R, it is there on the XY line. So that is R dash. Okay, R dash. Now we will proceed. While S, you can see that while S is 50 mm behind of VP. So now see for the S. Sorry. Now we will see for the S. S is 50 mm behind of VP. So behind of VP means two chances. There are second and third quadrant. So second quadrant. So what happens in the second quadrant? Behind of VP means this is our top view. So VP HP. So above XY line in the second quadrant, and in the third quadrant also. So we get HP and VP. So in both the cases you can see that the top view, okay, the top view of AS, it is lying above the XY line. Okay, so we know that we can draw, we have to draw here above the XY line, but before that you see the line joining their top views makes an angle of 50 degree with XY. Okay, line joining with their top views makes an 50 degree with XY. So this is our top view from this. So the top view, yes, will be exist somewhere here. We have to draw and 45 degree and 40 degree angle line. Okay. So mark for 40. So from this point, just draw a straight line. Okay, just draw a straight line. Okay, we know that we know that the top view of S, that is top view is lying 50 mm behind of VP. So behind of VP means it is lying above the XY line. So for that purpose, what we do, we will be drawing an 50 mm 1 2 3 4 5 50 mm line here. Okay, 50 mm line. Okay, 50 mm horizontal line 1 2 3 4 5. So 50 mm horizontal line. So that is nothing but locus of S. That is nothing but locus of S. Now we see that, so where this intersection of this 45 degree angle line with respect to this 50 mm, so we have drawn this. Okay, 50. So where these two are intersecting, this point is our the top view of S. Okay, top view of S. So collinearly, if you drawing downward, so this point is nothing but the front view of S dash. Okay, now we have to find out the distance here from this point to here. So horizontally find out. So the distance of this is around 101 or 2 mm will be, okay, 101 1 or 2 mm. Okay, so this is what the problem, and here it is an angle 40. Okay, welcome to engineering visualization channel. Okay, now we are discussing problems on points here. Okay, so it is one of the different type problem. It is a combination of 2 points A and B. Okay, so now we look at the question here. A point A is 30 mm in front of VP and 40 mm above HP. Okay, and it is and another point B is 20 mm behind VP and 35 mm below HP. The horizontal distance between the points measured parallel to XY line is 60 mm. Draw the three projections of the points. Okay, three projections of the points means here both top view, front view and side view. Okay, join their front views and top views. So we have to join both their top views and front views. Okay, so now first I am going to draw an XY line here. So this is X, this is Y. Now first we take the point number A. So point number A, what the information is 30 mm in front of VP and 40 mm above HP. Okay, 30 mm in front of VP and 40 mm above HP means it is the first quadrant. So 30 mm in front of VP means, so here I will be constructing 40 mm above HP means it is a front view. Okay, front view I am going to construct here. Front view we always got above the XY line here. Okay, so this is front view A dash. So you can show the dimensions also. It is 40 and 30 mm in front of VP. So in front of VP means it is the top view. So top view we are getting below the XY line. So 30 means 3 boxes. Okay, and put a point. This is your A. Okay, this is 30. So top and front view of the point A is done. Now point B is 20 mm behind VP. Behind VP 35 mm below HP. Below HP means it is the third quadrant. Here behind of VP. So behind of VP means it is the top view. So here the top view we are getting above the XY line here. So here before that you can see here they have given one information here. The horizontal distance between the points measured parallel to XY line is 60. That means, so in order to before drawing the point number B, we should consider a horizontal distance of 60 mm here. Okay, here I'll mention with the dimension line. Okay, this is 60, and here we have to construct. So you can see 20 mm behind of VP. Behind of VP means it is the top view. So top view in the third quadrant we are getting above the XY line. So here, so this point is top view. So this is B. I'm showing the dimension line. This is 20. And same way 35 mm below HP. So below HP means it is a front view. So in the front view in the third quadrant we are getting below the XY line. So 35 means 3.5 boxes. See, this is 1, 2, 3. 3.5 means till here we have to extend. Use the scale or the box, no problem. You'll get the same length. Okay, this point is B dash. So this is done. So both top views and front views are done, and it is shown with a difference of at a horizontal distance of between the distance it is 60 mm. that is also done. Now, so the horizontal distance between the points measured parallel to XY is 60. Draw the three projections of the three projection means you can see this is front view, top and front view done. Now we have to draw the side view. Okay, side view we have to construct. So for this purpose, what I'll do, so we need to draw 45-degree angle line. First, for this point A, so the top view we are getting in the, so this is our top view, correct? This is top view and this is front view. So wherever we have the top view, on that side we have to draw the 45-degree angle line. Okay, so here I'll draw one x1 y1 line. This is x1 and y1. I'll use the protractor here. Place it at the intersection of xy and x1 y1 and mark for 45 degree and then draw an angle line. Okay, now from this top view, so draw the projection line till it touches the 45-degree line and then project it upward. Okay, and then has a projection line here also. Okay, so this is the point where we get the side view, A double dash. You can see always with respect to the front view we'll get the side view here. Okay, adjacent to it we'll get the side view. Okay, in the same way now we have to construct the side view of this point B. So you can see here the top view here, this is the top view. So top view here we're getting above the XY line, that means we should construct the angle line. So I'll take this as the reference only, x1 y1 line. I'll place the protractor here and mark for 45-degree angle and then draw an angle line here. Okay, and you can mention this angle here, it is 45 degree. Now project the line, that is projection line from this top view we have to draw, remember it, till it touches the 45-degree angle line and then project it downward till the B dash end. Okay, till here and then project it from here also. Okay, so this is our point, this is our side view, B double dash. Okay, this is our side view. So both the side views and side views of both point A and point B it is done. Now join their front views and top views. So the front views, front view of A is here and front view of B is here. So I'm going to join their front views and top views with a straight line. I'm going to do that. Okay, and then joining their top views also. Okay, so this completes the problem. Okay, you can subscribe for the channel and hit on the bell icon for the latest notifications. Okay, and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video.
Today we are going to learn about basic problems on projection of points. Okay, basic problems. Point A is lying at 30 mm above HP and 20 mm in front of VP. Draw the projections. So we have discussed there are three concepts in solving the projection of points. So first concept is to identify which quadrant. We know that if a point is lying 30 mm above HP and 20 mm in front of VP, that is above HP and in front of VP, it is an first quadrant. Okay, so now we have identified the quadrant. Now second concept is to write the notations in terms of XY line. Okay, you know that for first quadrant the notation it is VP will be above the XY line and HP will be below the XY line. So these two things are over. Now we are going for and doing in
sketchbook. Okay, so now you can see in this sketchbook each of these units, it is equal to 10 mm. Okay, the length, width, everything here, each box it is of dimension 10 mm, that is 1 centimeter. This is 1 centimeter, this is 1 centimeter. Okay, so first initially we are going to draw an XY line. Okay, it is reference line. XY, VP, HP. Okay, this is an reference line. Okay, this is reference line. Okay, now we have to do the problem. Now we take one by one. Okay, a point A is lying at a distance of 30 mm above HP. We know that if any point is lying above HP, okay, if we know that if any point is lying above HP or below HP, means it is an front view. Okay, so the front view will be drawn in the vertical plane. So vertical plane, it is lying above the XY line. So initially we draw 30 mm. So 30 mm means 3 box here. So we can count the 3 box. Directly draw a projection line. Okay, we just draw to this line. Okay, projection line. So this projection line has to be thin. Okay, so we need to draw a thin projection line. Okay, drawing 30 mm, and you have to put a point. Okay, so this is an front view. Front view means it is A dash. It is A dash. Now we can show with the dimensions. This is 30. So similarly we have to write the top view. You can see that a 20 mm in front of VP. We know that if any point is lying in front of VP or behind of VP. Okay, behind of VP or in front of VP means it is top view. So it is 20 mm. So 20 mm means exactly we can count the 2 box and draw a straight line, and we can put a point here. This is our top view. We can show the dimension line. Okay, this is 20. Okay, so now we have done with the first problem. Say we calling these two lines as projection lines. These are views. Okay, these are views. This is front view, is also one view. This is top view. Okay, so now we have done with the first problem. Similarly, now we will write the second problem. Point B is lying at 20 mm above HP and 30 mm behind of VP. Draw the projections. Okay, here also we follow the same concept. First we will identify the quadrant. So here we know that if a point is lying above HP and behind of VP means it is an second quadrant. So we know that for the second quadrant, if it is written in terms of XY line, both vertical plane and horizontal plane lying above the XY line. Okay, now we draw the first we draw an XY line. So both VP and HP lying above the XY line. We know that if any point is lying above the HP means it is in front view. So first we draw in front view. If a point is lying above HP means it is front view. So we put a point here. This is B dash. Next 30 mm behind of VP. So behind of VP means it is also behind of VP means it is top view. We know that all these views are falling in a same collinear line. I'll be extending 10 mm. Okay, so it will become 30. This is top view. Now we will show the dimension line. So this is 20. Okay, and similarly this is 30. Okay, on the same collinear line, we calling this collinear line. On the same collinear line we get the views here. Okay, top view and front view. So this is we have done with the second problem also. Now we will move to the third problem. Point C is lying 30 mm below HP and 30 mm behind of VP. Draw the projections. Okay, so we need to identify the quadrant first. So below of HP and behind of VP. So that means this is an third quadrant. Okay, we have identified the quadrant. Now we have to write the convention for it in this third quadrant. So HP will be above the XY line and VP will be below the XY line. That it is nothing but reverse of the first quadrant. Okay, so now we represent in 2D. So initially we draw an XY line. So HP, VP. Now we have to draw the views. So 30 mm below HP. Below HP means it is, we know that in a concept that if a point is lying above HP or below HP means it is in front view. So front view will be drawn in the vertical plane. So in the vertical plane we have to draw 30. Draw a line and put a point. This is C. And show it the dimensions. Okay, now similarly we have done with the top view. Now we similarly write 30 mm behind of VP. So behind of VP means it is top view, correct? Behind of VP means it is top. So again 30 mm line. So we know the top view will be drawn in the horizontal plane. Okay, so now we have done with the third problem. So similarly can go for the fourth problem. Point D is lying 40 mm below of HP and 30 mm in front of VP. So draw the projections. Okay, now we have to identify which quadrant it is. So below of HP and in front of VP means it is in fourth quadrant. Okay, so point D is lying fourth quadrant. We know for the conventions both vertical plane and horizontal plane lying below the XY line. Okay, and draw XY line here first. Both vertical plane and horizontal plane below HP. Now 40 mm below HP. So below HP or above HP means it is front view. So we draw the front view first. That means 4 boxes, and you put a point. So this is D dash. Okay. So this is show with the dimension. Okay. Now 30 mm in front of VP. 30 mm in front of VP means it is top view. So we know that both the views are lying on the same collinear line. So this is our top view. Okay, so this is what we have done with the solutions of all the basic problems. Okay, today we are going to start the first problem in points. Okay, so we'll take the first problem. Draw the projections of the following points on the same XY line, keeping convenient distance between each projectors. Good. Name the quadrants in which they lie. So first one, point A, 30 mm above HP and 35 mm in front of VP. Point B, 35 mm above HP and 40 mm behind VP. Point C, 40 mm above HP and on VP. Next point D, 35 mm below HP and 30 mm in front of VP. Okay, so this is the problem. Say the basic problem which you have solved, it is only the one point on the XY line, but you see in this problem, draw the projections of the following points on the same XY line. That is, on the same XY line we need to project all these 4 points A, B, C, D on the same XY line. Okay, by keeping convenient distance between each projectors, and after that we have to name the quadrants in which they are lying. Okay, we need to mention either A is lying in first quadrant, B is lying in which quadrant, and C is lying in which quadrant, and D is lying in which quadrant. So that thing we have to do it. So first we are going to draw an XY line. Okay. First we are going to draw an XY line. Okay, herein you should not write VPHP. Okay, should not write, because there are 4 points are lying on the same XY line. Okay, so now we'll take one by one. First we will take point A. Okay, you can see the question. A point A is lying 30 mm above HP and 35 mm in front of VP. So above HP and in front of VP means it is an first quadrant. Okay, it is in first quadrant, right? So in first quadrant we know that. Okay, for your reference purpose I will be writing. So for first quadrant VP will be above X line and HP will be below the X. After drawing the projections we will erase this. Okay, so 30 mm above HP and 35 in front of VP, it is in first quadrant. So we know that 30 mm above HP, above HP means it is front view. So front view will be lying in the vertical plane. So we draw 30 mm means 3 boxes, and you put a point. So this is A dash. Similarly, so 35 mm in front of VP. 35 in front of VP means it is top view. So 35 means 3.5 box. Okay, 35 means 3.5. 1, 2, 3, 3.5. Okay, 3.5 box you have to mark. Okay, and you put a point here. That is your top view. Now you draw an dimension line for showing the dimensions. Okay, so this is 30 and this is 35. So now we have done with the point A. Similarly we look for the point B. So 35 mm above HP and 40 mm behind of VP. So above HP and behind of VP means it is an second quadrant. So point B is lying in the second quadrant. So after finishing this you just have to rub it. Okay, remove this VP and HP. For reference, for your understanding purpose, you can write initially, then you can rub it. So 35 mm above HP and 40 mm behind of VP means it is second quadrant. We know that in second quadrant both vertical plane and horizontal plane are above the XY line. So 35 mm above HP means it is front view. So first we draw for 35, that is 3.5 box. Okay, and you put a point. Above HP means it is front view, B dash. Next 40 mm behind of VP, so it is in top view. Already we have drawn 35, so I will be extending by 5 mm, and you put a point. Okay, now we can write the dimension line. So this is 35, and here you can show it for the 40. So it is 40. Okay. Okay, now we have done with the 2 points. Now point C. So 40 mm above HP. okay, 40 mm above HP and on VP. So as we have discussed in the previous concept, so and on VP means it is our top view, okay, it is our top view. So above HP means, say here above HP, so we know this concept, so HP VP. So above HP means the point may be lying in first and second quadrant, okay, first and second quadrant. So the point may be lying in first and second quadrant. You can see that already we have completed the top view. Now above HP means it is front view. So now we have to look in for the front view. So front view in first and second quadrant. See, in all these cases you just see in the first quadrant, so where the front view is lying, okay, VP HP. So front view lying in the vertical plane, it is above HP. Similarly in second quadrant also you have to see for the front view. So front view here also it is lying above the X view. So in both these cases front view is lying above XY, okay. So front view is lying above XY. So first we draw a front view. So front view of, that is 40 mm above HP, it is in front view. So front view it is lying in first and second quadrant. In both the cases first and second quadrant, the front view it is lying in the vertical plane. So vertical plane it is lying above the XY line, and similarly in the case of second quadrant also vertical plane is lying above the XY line. In both the cases the front view will be projected on the vertical plane, that front view will be drawn above the XY line, okay. So that's why you will be drawing 40 mm line, 40 mm line, that is 4 boxes, and put a point. So that is front view, okay, front view okay, 40 mm. Now so we have this point on VP. So on VP means we know that it is in top view. So on VP means we need to project this point, that is top view, on the XY line. Please remember it. On VP means it is top view. This top view has to be drawn on the XY line. So okay, so here the point will be the point C, okay. Now similarly we will look it for the point D. So point D is lying 35 mm below HP and 30 mm in front of VP. So it is in fourth quadrant, correct? It is in fourth quadrant. So below HP, 35 mm below HP and 30 mm in front of VP, fourth quadrant. So we know that in fourth quadrant both vertical plane and horizontal plane are lying below the XY line. Now we see, so below HP which it is in front view. So first we will draw in front view. So that is 35 and you put a point, that is D dash, okay. Now similarly we have in front of VP. In front of VP means it is a top view. So here in both the cases it is projected below the XY line. I will put a point here, 30 mm. So it is top view D. Okay, now we are going to project it, draw with the projection line. Okay, so this is what, after drawing this we'll erase these things, okay, we'll erase these things. So this is we have written for our convenience, okay. Okay, now we have to write down. You can see in this question we have to name the quadrants, okay. We have to name the quadrants in which they are lying. Now we have to write for the first one, point A. So point A you can write here. A is lying. A is lying. We know that it is lying in first quadrant. Okay. A is lying in first quadrant. Similarly for the B we will write B is lying in second quadrant. Okay, B is lying in second quadrant. Similarly C is lying, you can see that C is lying in first and second quadrant. Both the things you have to write. Okay, because front view it is lying in first and second quadrant, so we will consider front view as a reference for writing it. So here in the point C, it is lying in first and second quadrant, lying in first and second quadrant. Similarly for the point D we will write, so point D is lying, so point D is lying, we know that it is lying in the fourth quadrant. Okay, it is lying in the fourth quadrant. Okay, today we are going to learn about basic concepts regarding projection of straight lines. Okay, in this first we are going to see the case 1. Okay, so with respect to these cases we are going to learn the basic things about the projection of lines. Okay, so first case 1, it is a line parallel to HP and VP. So in this the line will be parallel to both HP plane and VP plane. Say if I am considering, so this is your vertical plane and horizontal plane. Here our line will be parallel to both HP and parallel to both VP. So this is what the condition. Okay, case 1, it is parallel to HP and parallel to VP. This is vertical plane and this is a HP plane. It is parallel to HP and it is parallel to VP. So this is what our condition. So in this so we will deal with the problem. Draw two views of a straight line 60 mm long which is parallel to both HP and VP. Okay, so here you can see that the line it is parallel to both HP plane and VP plane. Okay, and then they have given the line is so the length of line we got to know it is 60 mm. Okay, so the length of line we have to draw, that is 60, and so it is parallel to both HP and VP plane. Okay, and here we have, so you can see that two views you have to draw, front and top view. Straight line 60 mm which is parallel to both HP and VP. The line is 20 mm above HP and 25 mm in front of VP. So here we are going to use only the first quadrant. So first I am going to draw an XY line here. Okay, so XY VP HP first quadrant. Okay, so the line is 20 mm above HP. So above HP means it is our front view. So here vertically, so here I am marking 20. So this is 20 and 25 mm in front of VP. So in front of VP means it is our top view. So it is 25. So here we have to draw a line of length 60. Okay, so it is parallel means we have to draw a straight line. So from this end 6 boxes we can take, so up to 6 boxes here, and here also we have to draw for 6 boxes. Okay, so this is our line and we can show the dimensions. So this is our top view which is also 60 mm. Okay, so this is our front view. You can name it as B dash, B dash, and this is AB. So this is AB line of length and parallel to both vertical plane and HP plane. Okay, we see second case in projection of lines. So the second condition is the line is parallel to VP and perpendicular to VP. So we have to make it parallel to HP and perpendicular to VP. So how to do that? Parallel to VP means here you can see this is our vertical plane, this is horizontal plane. In this condition we have to make it parallel. So you can see here this is parallel to HP. So this pen, it is parallel to HP and it is perpendicular to VP. So perpendicular means you will get a dot here. Okay, you will get a dot on the vertical plane and there is a straight line in the HP plane. So this is what parallel to HP and perpendicular to VP. So like this we have to do. So first we are going to draw an XY line. Okay. XY, VP, HP, first quadrant we are using. Okay, so here the end of the line, so line it is, you see it here, line AB long parallel to HP, we have to make and perpendicular to VP. The line is 20 mm from HP and 30 mm from VP. So 20 mm from HP means it is 20 mm from HP. So 20 mm above HP means it is in the front view. So here, so above HP means here, and 30 mm means here downward. Okay, here you can show the dimensions. So this is 30 and this is 20. So here from this end we have to draw an parallel line. Okay, see this line 60, these 6 boxes. So it is A, B, line of length 60, okay, 60. And here we'll put a dot, that is A dash and B dash. Okay, so this point it is perpendicular and this is parallel. Okay, so this completes the second case. Okay, we see a third case. So third case is line parallel to VP and perpendicular to HP. So how to do this condition? We see it here. So this is our vertical plane and this is horizontal plane. So in this condition here, the line it is parallel to VP, straight line we get it in VP plane, and perpendicular to HP means we get a dot in the HP plane. This is what the condition, parallel to the VP and perpendicular to HP. So like this we have to do. Okay, line of length we have to draw a 50 mm. So here it is parallel to VP and perpendicular to HP. One end of the line it is 20 mm above HP and 20 mm in front of VP. So first we are going to draw an XY line here. VP, HP and Y. So here both the ends of lines are at a distance of 20. So 20, 20. So we can show the dimensions on one side. Okay, from this end, so here we have to consider 6 boxes. This is A dash, B dash, and you can show the dimension here on one side. It is 60. And here we are going to put a dot. This is AB. Okay, so it is perpendicular to HP and parallel to VP. So this condition also so done. The fourth case, that is line inclined to VP and parallel to HP. Okay, so parallel to HP. So how it is here, you can see this is our VP plane, this is HP plane. So here you can see this is parallel to HP and parallel to VP. So here you can see that this is inclination, we are giving inclination. So whatever the inclinations here, so we will be giving like this. So it is what the inclination to VP. So this inclination to VP, so whatever we give, say this is what the inclination to VP and it is parallel to HP. Okay, so like this we have to do it. So here first I am going to draw an XY line. So VP, HP and Y. So 30 mm above HP and 20 mm. So here we can show the dimensions. Okay, so here it is. So this is 20 and this is 30. So whatever the inclinations we have given inclination to VP, that is we can show it in the VP plane. So sorry, in the HP plane. Inclination to VP, so we have to show it in the HP plane. So inclination to HP, let's say some 45 degree. We will give the angle 45 degree. Okay, here. So here I will take an angle of 45 degree and line of length. So line of length we have to take, that is 50 mm. And here the angle we can 45 degree. Okay, this is A, this is B. Now projecting upward, here we get front view. So this is B dash, B dash. Okay, so this completes the problem. You can see. So this is true length of line. So it is 50. It's 50, right? So if the length of line, if this remains in after projection, say we calling that is true length of line. Okay, true length of line. If the length of line, if it is reduced, okay, after projection, we calling that as an apparent length of line. Okay, apparent length of line. Okay, so true length of line means the length of line will be remain same after projection. So that is true length of line. If the length of line it is get reduced after projection, we calling that as apparent length of line. Okay, so this completes the problem. See a fourth case in projection of line. So line is inclined to HP and parallel to VP. So here we have to give inclination to HP and make sure that line parallel to the VP. So how it is done? So you see it here. So this is vertical plane, this is horizontal plane. Say in this condition it is both parallel to HP and parallel to VP. So now what I'm going to give inclination like this. You can see here. So this is what the parallel to the VP, but here it is nothing but the inclination from the HP plane. Okay, it is inclined to the HP and parallel to the VP. Parallel to the VP means we get a straight line. So inclination to HP means either it is 30 degree, 45 degree, 90 degree. Okay, so this is what the inclination to HP and parallel to VP. So this is how we have to do. So for that, first I am going to draw XY line and first quadrant. VP, HP, Y. So you can see here the end of the line is 20 mm in front of VP, 30 mm above HP. So 30 mm above HP means here this is 30 and this is 20. So here the end of the line here you have to give the angle here first. It is inclined to HP. So whatever the inclination to HP it is there, it is seen in the front view. Okay, so it is seen in the front view. So here I am going to mark angle 60 degree. Okay, so here I am going to draw a line of length 60. 60 mm line we have to draw. So 1, 2, 3, 4, 5, 6. Okay, 6. So it is having angle of 60 degree, and this is A dash, B dash, and this is the length of 60. So now projecting downward, so we get the length of the line here. So this is our top view, A, B. Okay, so this is what inclined to the HP, the inclinations to the HP, it is shown in the front view, that is in the vertical plane. Okay, so it is inclined to HP and parallel to VP. So this condition also done. Okay, we see some basic concepts in projection of lines. So as we solving the problem, we should make sure. So we know that we have true length of line. We know the true length of line in top view. It is exactly equal to the true length of line in front view. Okay, so that is the first concept. And second concept is the true length is always greater than the apparent length. Okay, so be remember it. True lengths are always greater than the apparent length. And then apparent angles are always, which we find out, apparent angles are always greater than the true angles. Okay, this is the one of the difference. So when we are solving the problem, we should make sure the true lengths are always greater than the apparent lengths and apparent angles are always greater than the true angles. And the true length in top view and true length in front view, it is always the same. Say true length is given if it is 80 mm in front view, and in the top view also true length is exactly 80 mm. Okay, so that's what. So the basic concepts in projection of lines. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of lines. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I am going to draw an XY line here. So XY, VP, HP. So in this problem, you have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first, the end of the line, it is inclined end A. It is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP. So this is 20 and 30. 30 means here. Okay, so we can show the dimensions for it. So this is 20 and this is 30. It's the end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. We have to find out the apparent length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first we are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree to VP. And here line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash this is B1 dash, and this is A, and this is B2. And here, after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of A, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cut, we have to join from here to here. So this is AB, this is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is B2 dash. So by measuring from compass, measuring from compass from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut it. This is A dash, B dash. Okay, so this is nothing but the upper end length. So this A dash, B dash. Okay, upper end length we are going to measure how much it is. Upper end length, it is measuring 57 mm. Okay, so okay, 57 mm upper end length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And upper end angles, inclinations also we have to find out. So how much we are getting. So upper end length inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we're getting upper end lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first the end of the line, it is inclined end A, it is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP, so this is 20 and 30 means here. Okay, so we can show the dimensions for it. So this is 20 and this is 30, the end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. We have to find out the upper and ends. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first we are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree to VP, and here line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of B, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length, we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cut, we have to join from here to here. So this is AB, this is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is P2 dash. So by measuring from compass, measuring from compass from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut. This is A dash B dash. Okay, so this is nothing but the apparent length. So this A dash B dash. Okay, apparent length we are going to measure how much it is. Apparent length, it is measuring 57 mm. Okay, so 57 mm apparent length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And apparent angles, inclinations also we have to find out. So how much we are getting. So apparent length, inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we are getting apparent lengths A dash B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. Okay, so we are going to solve second problem from the Caed solution book. Okay, in the projection of lines. Okay, in this problem, line AB 18 mm long is inclined at 30 degree to HP and inclined to VP at 45 degree. So draw the front and top views of the line and determine their length. So in this problem they have mentioned true length and the angle of inclination to HP and an angle of inclination to VP they have given. Now we have to find out the apparent lengths and apparent inclinations. Okay, so proceed with the problem. So first I am going to draw an XY line here. Okay, so any one of the reference point I will take here. This is A dash and A. Okay, here, so they have not given any end of the line distance, so no need to draw the locus. The locus line it is there on the XY line. So first inclination, it is inclination to HP at 30 degree. And here we have to draw a line of length AD passing through this point. This is 30 degree. This is B1 dash. Similarly, we have to mark another angle at 45 degree, and this also having a length of 80. So this is B2. Now we are going to draw a locus line here. This is locus of B2 and this is locus of B1 dash. Okay, so now the procedure here it is we have to project it downward till here. Now we have to take the compass measuring from here. So we have to cut the arc. This done. we have to join. Okay, so I'm going to dark this length, and this is our apparent length AB. Now we have to project it upward. So arrow mark I'm writing here. So we have to join here. This is A dash, B dash. Okay, there are two apparent lengths we got. Now we have to measure the angle. Okay. Apparent length angles. So here we have, so this is 45 degree. This is alpha 45 degree. And this is beta. This is LQ. So this is we are getting beta 55 degree, and this is 45. So we need to measure these lengths. So this is around 57 mm. So we will write here A dash, B dash 57 mm, and AB. So alpha we are getting 45 degree. So beta we are getting 55 degree. AB length we have to measure. AB I am getting around 68 mm. So these are the things we have been find out. Okay, in projection of line. You can like the video, subscribe and share, and hit on the bell icon. Okay, we see another problem, that is problem number 3 from Caed solution book. Okay, so in this problem they have given line AB as its end 820 mm above HP and 30 mm in front of AP, and the other end 60 mm above HP and 45 in front of AP. Okay, and the distance between the projectors, end projector is given 70. So in this problem they have not mentioned either true lengths or any kind of inclinations. Okay, we have to use these end line distances so to do the problem. Okay, so now we are going to proceed with the problem here. First I am going to draw an XY line. Okay. So XY VP HP. So one end of the line is 20 mm above HP and 30 mm in front of AP. So 20 here and 30 here. Okay. So here we are going to show the dimension. So this is 20, this is 30. This is A dash and this is A. And then other end is 60 mm above HP. Okay, 60 mm above HP. So that is 6 boxes. Consider 60 here, 60. So what I will do 60 it is, and here it is 45. Okay. So this it is 45. Now I am going to draw the locus lines here. Okay. Okay, this is locus of B1 dash, this is locus of B2, and this is locus of B, and this is locus of A dash. Okay, now another thing what they have given in this question is distance between projectors. So distance between end projector is 70 mm. So I am going to draw that. So here distance between end projector is 70. So here I am going to draw on vertical line. joining it. So here I'm going to mention this is B dash and this is B. We know that as the apparent lines are drawn, so the end points, if you draw a straight line, so it will be falling in a straight line. Okay, so that's why we're getting this B dash and a B on a same line. So I'm going to join this. So this is apparent length 1 and this is apparent length AP. Okay, so these 2 points we are getting it. So now using these 2 points we are going to draw, we are going to find out the, okay, so reverse here. So in this problem we have to do the reverse process to get the 2 lengths. Okay, so now we join from here. So this is B2. Okay, that is 1 2 length. Now again from this end, so I can show the arrow mark direction in which these things are going. So now we will join this. Okay, so now we'll find out the distances here. So 2 length we are getting around AP2 and A dash P1 dash, it is AP2 mm, and AB we are getting around 72 mm, and this is B1 dash, 81. So AB1 dash is 81 mm. So we have to find out the angle of inclination for the 2 lengths, okay, or apparent lengths. So here we are getting around 30 degree alpha. So alpha here we are getting it is 30 degree, and beta we have to find out. So beta we are getting around 20. Okay, so this problem it is done. We solve another problem from Caed solution book, that is problem number 5. Okay, so what is given in the question? The top of weave PQ of a straight line, the top of weave PQ of a straight line is 70 mm. So they have given the top weave of 70 here and makes an angle of 60 degree with XY. The end Q is 10 mm in 10 end Q is 10 in front of VP and 30 mm above HP. The difference between the distance of PQ, P and Q above the HP is 45. So draw the projections and determine its true length and true inclinations with HP. First we are going to draw the end points. So for that first I am drawing an extra line here. Okay. So VP, HP, Y. So end Q distance given. So end Q it is 10 mm in front of VP. So from here it is Q and 30 mm above HP. So here it is Q dash. So we will show the dimensions. This is 30 and this is 10. And here another thing, the difference between the distance of P and Q above the HP is 45. So the distance between this P and Q, we have to consider the distance of 45 here. From this here I'm going to consider 45 here sorry, till here it is 10, 20, 30, so 45. Okay, so here I'm going to draw on locus, and here also I'm going to construct a locus line here. Okay, and here also the locus line. Okay, now so with the question they have mentioned, so the top V PQ of a straight line 70 mm, so 70 mm, so with the angle of 60. So here, keeping at this point, so marking at 60 degree, I'm going to draw 60 mm line here. So this is having inclination 60 degree and this is P. So here I am going to draw a locus line, another locus line here. Okay, so now to find out the true length, this is one of the apparent length, right? So apparent length, so apparent length will always be rotated, you remember it. So apparent length, it is going to rotate it like this, and then projected upward, so to get the true length. This is true length, so this is, so you can say P1 dash, P1 dash. Now so we are getting one apparent length and one true length. Okay, so now we have to get another apparent length. How to do? We know that apparent lengths, when they have been projected, so they are forming in a straight line. So I'm just drawing a straight line here. So this point we having, this is P dash. So now we are getting another apparent length in front view. Okay. Apparent length in front view. Now we are going to rotate this apparent length. So in this direction, then projecting downward, so this is, we have another true length. So we are going to measure the true length. So true length we are getting around 76 here. Okay, so you can write here, so you can like write it Q dash P1 dash is equal to Q P2. So you can measure here, it is around 75 mm we are getting. Okay, and true angle of inclinations we have to find out. So the first angle we are getting, it is around 37 degree I'm getting. This is side 37 degree. Okay. And second angle I'm getting around, so this is theta and this is psi. So psi I am getting around 45. So this completes the problem. So remember it. So always apparent lengths are going to be rotated. Okay, so I'm going to make this apparent length darks. Okay, so apparent lengths are always rotated. So true lengths are never be rotated. Okay, so remember it. This is one of the important point. So apparent lengths are rotated using compass. Okay. So we never rotate true lengths. So this is one of the important note. You can say that Okay, apparent lens are always rotated when we are doing the problem. True lens were never rotated using compass. Okay, so that is the important thing. Another problem from Caed solution book. It is problem number 6. Okay, so in this they have given line PQ, true length 85 mm long, as a end P 10 mm above HP and 15 mm in front of VP. The top weave and front weave of line PQ are 75 and 85. So these are the apparent lengths they have given. So this is true length 85. These are apparent lengths. So using these things we have to solve the problem. So we have to find out the true and apparent inclinations in this. Okay. So first I'm going to draw an XY line here. So XY, VP, HP and Y. So the end points first time write 10 mm above HP. So 10 mm above HP and 15 mm in front of VP. So here I'm going to draw a locus line. So wherever the end points were there, we have to draw an locus lines. Okay. So this point is P dash and this is P, and it is having a dimension of 15 and this is 10. Okay. And the top view and front view of line are 75 and 80. So the top view here, so this here on the HP plane we get the top view, so it is of 75. I'm going to measure 75 from the scale. Okay, 75 from the scale I'm going to measure, and here I'm going to cut the arc. Okay, and then I'm going to extend this. Okay, extend it with the straight line. Now I'm going to measure 85 from the compass and using scale. You can measure and you can cut the arc. Okay. So then join. This is having 85 mm and true length it is 85 and this is Q1 dash. So here one locus line here. Okay. So now we are getting the true length 85 here and the locus line. So next thing we have to do is again we have to consider this. The front view we have 80. Take here from the scale 80. So from this end I'm going to draw an vertical line here downward. Then again I'm going to measure 85 from the scale using compass. Okay. So now I'm going to cut the arc here. So this is another true length. Okay. This PQ2 is also 85 mm. So here we get another locus line. Okay. So now using this 75 mm here, we're going to cut the arc exactly here. Here we're getting the apparent length PQ, and here upper end means PQ dash. Okay, now we have to find out the angles. Okay, find out the angles. So first I'm going to find out the theta. So theta I'm getting around, so how much theta, it is around 28 degree. Okay, psi we have to find out. Alpha also, alpha is going to find out. So alpha I'm getting around, so alpha I'm getting around 28. Alpha I'm getting around 28 degree here. Now psi we have to find out. Psi we have psi have 20 degree, and beta I'm getting around 23 degree. Okay, so this completes the problem. Okay. We do another problem from Caed solution book. It is problem number 7. Okay, so what is given? A line has its end 10 mm above HP, 15 mm in front of VP, and end B is 15 mm above HP. And the line is inclined at 30 degree to HP and 35 degree to VP. And the distance between the end projectors given is 50 mm. So now we have to use, we have to go step by step here. So first I'm going to draw an XY line here. XY, VP, HP, same points, 10 mm above HP means this, and 15 mm in front of VP. And here we have locus line, and here also we have locus line. Okay, so this is A dash and this is A, and it is having a dimension of, so this is 10 and this is 15. Okay, now another end we have, that is 55 mm from here, that is, so 55 is still here. Okay, here another locus. Now, so we have to use inclination. The line is inclined at 30 degrees. So this is nothing but inclination to the true length. Okay, so from here we are going to mark for 30 degree. Then we are going to draw a straight line passing through a point. Okay, so this is 30 degree and this is B1 dash, true length. Okay, and another one is 35 degree to VP. I'm marking at 35 degree and draw a line. We have to find out how much length. So because we know that true lengths are same in both top view and front view, so we have to use this. So here we have true length, I'm getting around 88. So 88 mm. So this is the true length. So here also we have to draw another this is 35 degree. Okay.
CS 90, CD 30. CD lo DC CS ಎಲ್ಲ ಸೇರಿ 110. DC ನೋ ಅಷ್ಟು ತಗೊಳ್ಳಿಲ್ಲ ಅನ್ಸುತ್ತೆ. ಯಾ ಸರ್ ಈಗ ಎರಡು ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಎರಡು ಪ್ಯಾಟರ್ನ್ ಇರುತ್ತೆ. ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲ CS ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿ ಸಿವಿಲ್ ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ 100 ರೂಪಾಯಿ ಇರಬೇಕಾಗುತ್ತೆ. ಅಂದ್ರೆ ಯಾವ ಸೆಲೆಕ್ಷನ್ ಅಂತ 6 ಅವರು ಅಲ್ಲಿ 45 ಮಾಡಿಬಿಟ್ಟು ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿ ಸಿವಿಲ್ ಅಲ್ಲಿ ಸೆಪರೇಟ್ ಮಾಡೋದಂತ 30 ರೂಪಾಯಿ ಎತ್ತಿ ಹೋಗೋದು. maybe ನೀವು ಬರೋದು ಕಟ್ಟಕ್ಕೆ ಇಲ್ಲ ಬಂದು ಇವರು ತಗೊಂಡಾರೆ ಈ ಶಿಕ್ಷಣ ಮಾಡಿದ್ರೆ ಹೋಗಿದ್ದ.
So now we have to find out the angle here. So apparent angles we have to find out. Alpha, I'm getting around alpha 32 degrees, and here beta I'm getting around 44 degrees. Okay. And true length we have A dash, B1 dash, and A B2, it is around 88 mm. So that completes the problem. Okay, we solved the problem number 9 from Caed solution book. So it is, you can see in this problem they have given line of AB 60 mm as one of its extremities. Extremities means end point. Okay, so 20 mm in front of VP, 15 mm above HP. The line is inclined at 25 degree to HP and 40 degree to VP. So now we'll proceed with the solution here. So first I'm going to draw an XY line here. Okay, X, VP, HP and Y. So end point here 15 mm above HP, 15 mm, and it is, and 20 mm in front of VP, 20 mm in front of VP here. So here we are going to draw an locus line. And this is 15 and this is 20. Okay, 15 and 20, and this is A dash and this is A, and we have angle of inclination here. So 25 degree to 25 degree to HP, okay, and 40 degree to VP. So 40 degree to VP. Here the length of line we have to draw, that is 60. Okay. Here to these extremities, again another locus line. So this is the AB2, another length of line 60 we have to draw this end. Okay, here another locus line. Okay, so this is B1 dash, and show the dimension here 60. We can show the dimension. So this angle it is 25 degree. This angle it is 40 degree. Okay. So now this is true length. Now we have to find out the apparent length. So apparent length, it is going vertically downward till the locus of A. Now we have to take the compass and we have to rotate it till here. Okay. So here at this point we are getting apparent length AB. So we have to dark this apparent length. Okay. Now from this end, this is A dash, B dash. So this is what I want to tell. So if you just draw a straight line connecting the apparent length top face and the bottom face, okay. So this front view and top view it is drawn, you'll get the straight line, okay. That is what. So you can see A dash and A dash, A it is in the collinear line, and B dash and B in the collinear line, okay. So this completes the problem. Okay, now we can find out the apparent length angle inclinations here. So So apparent angle we have, so first angle we have here is around alpha is 34 degree, and this we have it is around beta. So beta angle we are getting around 46 degree. Okay, and then apparent length we have to find out. Apparent length, this is AB we have 55 mm, and B dash we have 46 mm. Dash B dash 46 mm. Okay. So this completes the problem. You solve problem number 10 from Caed solution book. So in this line AB measuring 70 mm has its end 15 mm in front of EP, 20 mm above HP, and the other end B is 60 mm in front of EP and 50 mm above HP. So first I'm going to draw an XY line. BP, HP and Y. So 20 mm above HP means here 20 and 15 mm means here. So here we are going to draw an locus line. above HP. 50 and 60 mm in front of EP. So here also we can draw an locus line. So this point it is A dash and this is A. So we have a line of 70 mm. So we have to measure 70 mm from 70 mm 7 cm from the scale. Okay. So and we have to cut the arcs from this end to here, first arc, and the second arc from this here to here. Okay. So now we have to join. So these are nothing but two lengths. Okay. A, B, 2, and here from this end to here, this is B1 dash. This is having exactly 70 mm. And this also 70. So now, projecting upward this line here, and from here we have to rotate this apparent length till here. Okay. This is B dash. Similarly, so we can project it downward till here, and showing from here to here we can cut the arc and can join this. This is AB. So now we can measure the length here. So A dash, B dash, it is around 55. So sorry, not 55, it is around A dash, dash, B dash. So we have to find out here inclinations, okay, not the length here. You can see here, find the inclinations. We have to find out the inclinations here. So inclinations, what we are getting, both the inclinations we have to do. First angle we are getting around, it is theta in 125 degree here. this is 25, it is theta, and alpha we are getting, this is 34. Now here psi we have to find out. Psi we are getting around 45 degree. This is psi. Okay. This angle getting around, it is beta we are getting 55 degree. So sorry, psi we are having 40 degree. And this beta we are having, it is 35. So you can mention the angle here: theta 25, alpha 34, psi 40 degree, and beta 45 degree. Okay, so this completes the problem. Okay, so when you are doing it, so always make sure you have to dark this apparent lens. Okay, you have to dark the apparent lens. The apparent lens has to be more thick compared to your true lens. Okay. Today we are going to learn about midpoint problem in lines. So it is problem number 37 from Caed solution book. So you can see in this problem, draw the projections of a line AB 90 mm long. So here they have given true length of line, okay, and find its true and apparent inclinations. We have to find out, that is theta, psi, alpha, beta, everything. So with HP and VP, when end A is on HP and 20 mm in front of VP. So for the end A they have given the distances, and for the midpoint M, it is 20 mm above HP and 40 mm in front of VP. So now first we are going to draw XY line, then for the end points we are going to draw. Okay. So X, VP, HP. So end A here, you can see that end A is on HP and 20 mm in front of VP. So 20 mm in front of VP. So here we are going to draw an locus line. Okay. So this distance, it is 20. Okay, for the midpoint we have 20 mm above HP, 20 mm above HP here, and 40 mm in front of VP. Okay, 40. So here also we are going to draw an locus line. Okay, so I'm going to mark a middle point here. This is M dash, and here we have M. Okay, so middle point it is drawn. So now we have true length of line, it is 90. So half means it is 45. So we have to consider. So 45 length I have considered. And here from this point on the XY, I'm cutting first arc. Okay, so now we have to join. Okay, so this is beautiful. So we can extend it. Another 45 mm. So extend it. So this is A dash and this is P1 dash. Now here we are going to draw another locus line. Okay. And this is having the length of 90. So it is having a length of 90 mm. Now same way, so we already measured 45. So from this end here we are putting dot. So this is E. So we are going to extend this till here. So this is B2. Okay. So another locus line is drawn, and this is having the length of 90. So now we have to find out the upper length. So we have to project it from B1 dash till the middle point of M. So where the locus of L is there, till here we have to extend. So from this end to here, measuring this length, so we have to cut the arc. So now we can find it. So this is B. Okay. So we have to extend from here till the locus of M. Okay, so till the locus of M we have to extend. So measuring from this length, we have to cut the arc. Can show the another direction here. So we are extending it. So this is A. Now in the same way, so we are going to extend from this A till the middle point of M here. Okay. Now measuring this length to here, so we have to cut the arc till the locus of A. So we have to join it here. Again from extending from this point to the locus of M. Okay, measuring this length, we have to cut the arc. So this is the direction in which it is cut. Now from here to here, we have to join. Okay. So this is V dash. Now we have to find out the angles. So you can see that we have to find out the angles here. So true length angle, that is theta, we are having 25 degree, and alpha we have around 29 degree. Same here. Psi we have 26 degree, and beta we have around 31 degree. Okay, so this completes the problem. So you can like the video, share it, and subscribe for the channel, and hit on the bell icon. It is one of the special type of problems in lines. It is problem number 39 from Caed solution book. So you can see in this problem there are two lines given, two lines AB and AC, makes an angle of 120 degree between them in their front and top view. Okay, AB and AC, so that will be making an angle of 120 degree, and AB is parallel to both HP and VP. Okay, so we have to make AB, so both parallel to HP and VP. Determine the real angle between AB and AC. So how we do that? So first we have to draw an line here, XY line. So I will take here only. So XY line, XY, VP, HP. So first I will draw a line AB. So you can see that AB line parallel to both HP and PB. So I will take around 6 mm length line. So this is A dash, this is B dash. Okay, the same manner here, parallel to it, because the AB line, it is parallel. Here I am considering 60 mm. Okay, so this is B. So AB line, you can see that line AB, it is parallel to both HP and VP. It is parallel to both HP and VP. And now AB and AC makes an angle of 120 degree. So here I'll take so marking at 120 degree here, and then marking it here also 120 degree. Okay, so we have been marked 120 degree. Now I'm going to join this line. Okay, so line of length will take around here will take around here 50. Okay, so 50 will take here, this BC length 50. Okay, so this C dash, and here BC, and so 50 will take. Okay, so BC, so here we have angle 120, and this is also we have 120 degree. So this is done. Now so we are going to join it from this end to here will be joined, and here also. So I have to join. Okay, here I will draw locus lines. Here also we have to draw the locus lines. Okay, here also I have to draw the locus lines. Okay, so now after this what I have to do is, so we have to measure the length from here B to C, measuring this length. Okay, so we have to cut the arc. So this is, we have this is C1, and now measure this length. So this length is C2. Now so this is will give C2. Now projecting upward till here. Okay, so till here I have to project it. So now we are going to join this. So this point we have C1 dash. Okay, and this point we have C2 dash. Now after this what I have to do is, we have to measure the length from here to here. So I have to cut one arc, and after that measuring from here, so you have to cut this arc. So here, so this point we have, this is C2 dash. Okay, this point. So this point we have to join here. This point we have to join, and now from here to here I'll join. Okay, now this angle we have to find out. Okay, so this angle till here. So the real angle between the lines here we have. So we're getting here real angle. So real angle we are getting around, you can see here it is 120 12 degree. So 112 degree is the real angle. Today we are going to do midpoint problem in projection of line. Okay, so this is one of the important problem. Here in this problem, a straight line given AB measuring 80 mm long has the end A is in the HP and 25 mm in front of VP, and the midpoint M is 25 mm above HP and 40 mm in front of VP. So this is our problem. So first we are going to draw an XY line. Draw here. VP, HP and Y. So here in this the end A is in HP and 25 mm in front of VP. So 25 means here. So here we'll draw one locus line. Okay. And one end it is in HP. So here we get. So now for the midpoint, so it is on end of the line is in 25 mm, so 25 it is done. Now here for the midpoint it is midpoint M 25 mm above HP. Okay, 25 mm above HP. It's 25, and this also. Here we draw an locus line here. Okay, locus line here will be drawn. Another is 40 mm. So this is 40. Okay. So here also we draw an locus line. Okay, so after this we know the straight line AB measuring 80 mm, so it is measuring 80 mm, so that means so we have to take a compass and measure 40 here. So exactly 40 mm. Here from this end any one end you can choose. Say I will choose this is our midpoint M. If I choose this is M. Okay. And here I choose this is M dash. Okay, from this point, so we already measured 40 mm because it is 80. So I am taking half part means it is 40. So we are taking 40 mm here. Going to cut it. So after cutting the arc, I'm going to join it. So in a straight line, I'm going to extend this till 8. Okay, till 8 I have extended. So this point we have B dash and this is B1 dash, and here also we get the locus line. Okay, same way here also we do. So the point already we have measured 40, so I'm going to cut the arc. Here I'm going to join. Okay. I'm going to extend it. Okay, here at this point to draw another locus line. So this point it is, so this point, sorry, so this point it is A and this point is B2. Okay, this is A, this is A dash and this is B1 dash. Okay, so it is done. So now you can see that this is our true length of line. Okay, so these are our true length of line measuring 80 mm. So now we have to find out the upper end length. Okay, so how to draw upper end length means here we have to project it downward till here. Okay, till the locus of M. So we have to project it downward by taking this length. Okay, measuring this length here, measuring this length, we have to cut the arc. Okay. So till here. Okay, this is one point, this is B. Now in the same way, so we have to extend from this end till here. Okay, till here. Now measuring from M to here. So I have to cut that. So this point it is B. So now we can join these two lines also. So this we have the upper end length. Sorry, this is not B, this is A. So we have AB upper end length, we got it. In the same way, so we find out the upper end length. So we draw a straight line till the locus of M here. Okay, till the locus of M. So from this point to here, measuring this length, we are cutting the arc. Join, and this is B dash, again extending from this end. Okay, this end. Okay, measuring this length from here to here. So I'm showing the direction of the arrow mark, in which direction we're taking it. Now we have to join so this is A dash, this is A dash and this is B dash. So this completes the problem. You can see that we have to dark this upper end length. AB, this is A dash, B dash. Okay, so this completes the problem. Problem number 25 from projection of line. So in this straight line PQ inclined at 40 degree to VP has PQ 60 mm and P dash Q dash 60 mm. So this is upper end length and this also upper end length. So end P is both in HP and VP and 40 mm from the right or the left profile plane. Okay, so draw the projection of straight line PQ, find the true length and true inclination with HP, draw the profile view of the straight line and find the position of the end Q with HP. In this problem we have to find out the side view also. Okay, side view. So first I'm going to draw a straight XY line here. VP, HP, and here right. Okay, so first, so we know the end point P is both in HP and VP, so that means it is P dash and it is P, and here P dash Q dash 40 degree to VP has a PQ 60 mm. Okay, so PQ having 60 mm, so it is at 40 degree. So line of length we have to take here 60 means 6 mm. Okay, so PQ is 40 degree. So this is 60. Okay, so now so that is 40 degree to VP, that's why we have drawn a line here. Okay, so now so we know that we will drawing straight line here. We know that PQ it is 60 and P dash Q dash 50. So that means I will take, we know that upper end lengths will be falling in a straight line. So now I am measuring 50 mm from scale. So I am measuring 50 from scale. I am cutting the arc here. This is P dash Q dash, and here we have focus line. Okay, now we're going to take this length and we're tilting now to find out the true lengths. Okay, so this should do. So taking this length, so we can put this Q1 dash. You can rotate this also, like that. So it is done. This is 50. Now we'll find out now here. So from this end, so we'll be drawing a line of 40. You can see this here, 40 mm from the right of the left profile plane. So right of the left profile plane here, we're going to draw another line for, so this is x1 and y1, and here and for the top view I'm going to draw 45 degree angle line. And here from this dash there is a line going in this direction. Paramount direction. So this here we have Q double dash, and this point we have P double dash, and this is our side view. Okay, our side view, and this is the dimension we have to measure. So it is M, it is 22. Okay, so in this length also we have to measure. So this is having 38. So this will be as here to 38. Okay, so now true length we are going to measure. True length is around 63. True length in front view is equal to true length in output, that is 63. Angles we have to find out. Theta 20 degree, alpha 25 degree, plus psi we have 38 degree, so beta 50 degree. Okay, so this is the length we have. Next we have M around 22, then we have 38. Okay, so this completes the problem. Now we will proceed to the special type of problems. Okay, so in the special type of problem, the first problem we are choosing, that is a set square. You can see for the construction of a set square, they have given two angles here, 30 degree and 60 degree. Set square of 60 mm longer side is so kept such that the longer side is in HP. So we have to keep the longer side in the HP plane. So making an angle of 30 degree with VP, the set square itself inclined at 45 degree to HP. So we have to draw the set square. So the main thing in this problem is we have to construct a set square, that's it. Other than that, it will be similar to your normal type of problem. Okay, so I'll be showing how to construct a set square here. So the problem is easy. Only thing here is we have to construct a set square. Okay, so how to construct, you can see that first we consider a longer side 60. 60 means 6 box. Okay, so longer side 60 I have drawn. Now you can see 30 degree, so this is the internal angle difference, 30 degree, so the external angle it will be 60. Okay, so from here can mark for 60. Okay, sorry, it's not, it's 30. We have to mark for this point, mark 30 degree. Okay, 30 degree. Okay, so here, so we have to mark at 60 degree. Okay, so here 30, so this is 30. Okay, and this is 60. So this angle, how much we got? This is 60. So this is what the 30 degree, 60 degree set square. Okay, so in this you see it. So we have drawn with respect to the question given. So we will be showing the dimension. Okay, 60. So we have drawn a with respect to the longer side, and we will be giving the naming for it A, B, C. Okay, to project it to complete the front view. So it is A dash within bracket, B dash, C dash. Now angle of inclination to HPT is 45 degree. So that is A dash, B dash we have taken. The angle how much it is? 45. So mark for 45 degree. Okay. Now we have to cut the arc. Cut the arc from A dash to C dash. Okay. Same procedure how we did the normal type. So it is same. Only thing here in this we have to construct this set square. Okay. Other than that everything remains same with respect to the normal type. This is A and this point is B and this point is C. So we will join it. Okay, so now we have to draw the third position, that is inclination to VP. It is 30 degree, marking a reference point. So mark for 30 degree, draw an angle line. Okay, so this is 30 degree. So after this we have to mark reference point A. Okay, so from A to B we have to measure. We have to copy this diagram over here. That's it. So cut the arc. So this is the diagram we are copying it. Okay, from now A to C, first arc, then from B to C. So we get C here. Okay, now we have to join. Okay, so to complete the final position here, so here we get A dash. Similarly, we got B dash here and C dash we are getting here. So this is C dash. So now we will join to complete the final V. So that's complete the problem. Today we are going to learn another special type of problem on the isosceles triangular plate. Okay, now we will proceed with the question. Isosceles triangular plate of negligible thickness has a base 25 mm long and altitude 35 mm. So they have mentioned these dimensions: base dimension 25, altitude 35. You know how to construct the isosceles. I will show you how to construct. Now before construction, it is so placed on HP. You can see that he is telling that, so it will be placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm side. So he is telling that it will be placed on HP, but in the front view we have to get an equilateral triangle of dimension 25. So with the side that is parallel to VP, with the side that is the side which will be parallel to the VP. Okay, so that will be inclined at angle of 45 degree to VP. So you can see in this question they have mentioned only one angle of inclination, that is 45 degree to VP. So there is no angle of inclination to VP given. Instead of that, they are telling that with the side that is parallel to VP is inclined at 45 degree to HP. So second angle of inclination they have not mentioned. Instead of it, they have mentioned second weave. Okay, the second weave, it is an equilateral of dimension 25, and it is an front view. Okay, and so in the front view, so we have to get an equilateral triangle. So now, so before going to the problem, first we have to identify, is it resting on the HP plane or on the VP plane. So for that I'll be doing a trial. Okay, in trial 1, what we do, say this is our XY VP HP. Say we have constructed with the on the if we placed on the HP plane, what happens? Say this is our SSLS. Consider this is altitude. Okay, top view. So this is front view. Okay, now by inclining this, we'll get a here equilateral triangle. We will construct it. Then by projecting here, we get the angle. But herein you can see this equilateral triangle we are getting in the top view. Okay, so this is top view. This is wrong because we have to get an front view. Okay, we have to get the front view. So this trial is wrong. So similarly, we'll go for the trial 2. So we will try for the trial 2. You can see in this we will construct here. Okay, such that one of the corner touching the it is in the vertical plane, but it is one of the corner, it is resting on the XY line. If it is resting on the XY line, means it is touching on the HP also. Okay, it is placed like this. You can see this. Say consider this is horizontal plane, this is vertical plane, and we have placed like this. Okay, like this we have placed like this equilateral triangle. Say so the equilateral triangle, it is in the vertical plane, but one of the edges, okay, corner, it is touching the base edge, it is touching on the XY line. On the XY line means it is touching the XY line. Okay, so that's how it is. Say this is the front view, then projecting downward, we get the top view. Now in this position they have not mentioned the second angle of inclination, so we have to construct a triangle here. Okay, equilateral triangle of dimension 25. Okay, dimension 25 we have to construct. Then we have to, by proceeding like this, by taking this length, we can find out this angle of inclination. Okay, so this trial 2, it is correct because you can see this is equilateral triangle, so we are getting in the front view. Okay, and you can see that, so both the conditions we have to match. So it is so placed on HP such that in the front view, so we are placing an isosceles triangle in such a way that it is touching the HP plane. So how it is touching the HP plane? By placing on the XY line, we are making this one of the end touching the HP. So when it is inclined in the second position, it is seen as an equilateral triangle. Okay, so when it is inclined like this, okay, when it will be inclined like this, we are seeing an equilateral triangle of dimension 25. How it is means, say like this. So say consider this is our isosceles triangle, we have placed like this, and in second position we are inclining. We don't know how much inclination. We are inclining an isosceles triangle here, but in the front view we are getting an equilateral triangle, but we don't know how much angle. So that angle we are going to find out. Okay, so I'm proceeding with the question, so all of you carefully follow it. So this condition is correct, so all of you carefully follow. So first I will draw an XY line. So drawing the XY line is compulsory. Okay, VP HP. So first I'm constructing isosceles triangle. First I consider base edge, that is 25. Okay, so after constructing base edge 25 exactly, I will show the dimensions initially. Okay, so exactly at the middle of this we have to consider a center point. So it is exact 25 means it is 12.5, somewhere here we get. Okay, 12.5. to this 12.5 we have to mark altitude. Okay, altitude of 35, straight line, horizontal line of dimension 35, exactly 35 you have to draw a straight line. Okay, then after drawing 35 you join this. Okay, so this is what your isosceles triangle. So we are giving the naming A dash, B dash, and C dash. Okay, so when we draw the top view of it, so we'll get it on this xy line only. Okay, so it is A and B will be in bracket and C. So this is what the top view. But in this second position, angle of inclination to VP, they have not mentioned. Instead of that, they are telling we get an equilateral triangle of dimension 25. So I'll be drawing an equilateral triangle here by taking 25 dimension. Okay, so this problem is a little bit different. That's why we call it as an equilateral triangle, special type of problem. Okay, so we know how to construct equilateral triangle. Dimension 25. So in this problem they will be not mentioning one angle. Instead of that, they will be telling one view. Okay, so in this we are getting a front view. Okay, front view. So in the front view we are getting an equilateral triangle. Okay, so it is A dash, this is B dash, and this is C dash. So this is a equilateral triangle, but we need to find out how much inclination we get it here, how much tilt we have to do this isosceles triangle such that we get a equilateral triangle here. Okay, for that I'll just drawing an projection line here. Here at this point I will take a reference point here, A of B, then measuring this length A to C, measuring this length A to C, measuring this length A to C, I am going to cut the arc. Okay, so okay, so now we can find out how much angle of inclination it is. So herein I'm getting around 50 degree. You have to get 52. Okay, 52. So I'm getting 50 degree. Okay, so now we have done the second position. You can see in this problem how it is present: 1, 2, 3 and 4. First we have drawn this, second, third and fourth. Now fifth. You can see in this question, with the side that is parallel to VP is inclined at 45 degree. So this is what A dash, B dash, and this is what parallel to the VP. Now we have to incline this end. Okay, we have to incline this end by an angle of 45 degree. So how we do that? So here we are marking a point of B dash. Okay, so here at this point I will be taking an angle of 45 degree. Okay, drawing a line. Now measuring this end, because this is what the end, A dash, B dash end is parallel to VP. So I'm going to cut the arc. So this is A dash. Now similarly with the same length we have to construct a triangle, same dimension 25. Okay, it is already measured 25. Okay, now we join this. Okay, you can show the angle here, it is 45 degree. So now we can write the notations. So here I am getting A, and this point is B, and this point is C. So join it. Okay, so this is how we completed this fifth, sixth. Actually this problem it is proceed like this. Okay, like this in the arrow direction. Say first we constructed this, second position, third, fourth, fifth, sixth. In this problem they have mentioned only one angle, that is angle of inclination to HP. They have not mentioned the angle of inclination to VP. Instead of that they have mentioned one view, that is equilateral triangle of dimension 25. So this is how like this. Okay, good morning. We see another type of different type of problem in pentagonal lamina. So you can see in this question a pentagonal lamina of dimension 25 is having a side both on HP and VP. Okay, we have to make sure that one of the side has to touch both the HP plane and VP plane. Okay, so that's what the condition. The corner opposite to the side on which it rests is 15 mm above HP. That means it is indicating the second position. So drawing a 15 mm line and drawing the locus, so you can construct the second position. So you can see in this question they are mentioning we have to make sure that one of the edge has to be there in the HP plane and one of the edge has to be there in the BP plane. So you can see with respect to the condition I have drawn the edge AB, it is resting on the HP plane. Okay, and second angle of inclination is there with respect to 15 mm above HP. Now the third position we have to go with this condition. A side has to be there on both on HP and VP. Now the side AB, it is already there in the HP plane. We have to make sure this AB plane has to be there in VP. How to do that? We will take this AB edge and has to touch the XY line. By touching this AB edge, touching the XY line, we are making sure this AB edge, it is touching the VP plane. Okay. First I will take a reference point of B here. From B to A. So this is the length. So we have to transfer this diagram with respect to BA. These two lengths will be same. Okay. Now reverse it is. Okay, so reverse we have to touch it. So after this we have to transfer the diagram measuring this length E to D. So this length is exactly equal to okay. So this is C, this is D, and this is E. So join all these points. Okay. So now projecting upward, we can complete the rest of the diagram. So we have B dash and A dash here. Okay. And similarly we have this is C dash, this is E dash, and this point is D dash. So these are we complete the problem. You can see that we have to make sure the side both on HP and HP VP means the side it is there in the HP plane. Okay, now we are making it touching the VP plane. Okay. We see a different type of problem in hexagonal lamina. You see, in this problem we have to construct a hexagonal lamina of dimension 30 is resting on HP with one of its corners in VP. Okay, it will be a different type, and the surface inclined at an angle of 30 degree to VP. The diagonal, okay, the diagonal passing through the corner which is in VP, appears to be, they have mentioned appears to be, so means means no beta angle. Okay, and then they have mentioned inclined at 40 degree to HP. So in this problem you may be coming across, so it is resting on the HP plane with corner. So we see with the trials here. Okay, trial 1, just a rough sketch, XY. Say it is resting like this, first position. Okay, first position, inclination to HP given 40 degree, and here we get another diagram here like this. Okay, so this is the diagonal, but you can see in this question the diagonal passing through that corner which is in VP. So this is our diagonal. So this diagonal, it is there in the HP plane. Okay, so with the question it is telling which is in, okay, the diagonal passing through that corner which is in VP. So that means this diagonal has to be there in the VP plane. That means this triangle, this trial, it is wrong. Okay, so this trial you can see that. So in this problem we run the first trial, so resting on the HP plane, corner touching the VP. So inclination we have mentioned. Now with the second condition, the diagonal passing through that corner which is in VP. So this diagonal, it is not there in the VP, it is there in the HP. So that's why this trial, it is wrong. Now we see the trial 2. So in this trial 2 we are going to construct like this, on edge touching the HP plane, corner it is in the VP plane, the first position. Okay, and then inclination, it is inclination to VP given, so you get it like this. Okay, second inclination, and third inclination, you can see this is what our diagonal. So you can see here diagonal, it is there in, is in VP. So this trial, it is correct. So we will proceed now with the solution. Okay, so we have to get the hexagon here, hexagon of dimension much 30. So I'm going with another method, that is measuring 30 mm and drawing a circle, so it will become easy to construct it. So drawing a circle here. Okay, so herein we have to construct like this, right? So for that I'll be drawing like this, initially 30 mm line, edge, okay, edge with the dimension 30, and then measuring for 60, angle method only will do it. Okay, so 60, marking the angle and draw a line. Similarly here also we will do with the same procedure. Here 60 in this direction. Okay, now we have to cut it at 30 here, right? 30 mm. Okay, so we have 130. Again to this point, we have to merge this line. Okay, again we have to mark at 60. So again 60. So already we have measured at 30. So I'm cutting the arc. So now we have to join it. Okay. So this is what A dash, B dash, C dash, D dash, E dash, and F dash. So it is having a dimension of how much? So 30 it is. Okay. So the top we get it here on this line, on the XY line. Okay. So this is B, C, F, A, D, F, F, E, right? So the second angle of inclination, that is inclination to VP, they have mentioned 30 degree. First I will mark a reference point here. So to this reference point we are taking an angle of 30 degree. Okay, now we have to cut the arc from B to E. Okay, from B to E we have to cut the arc. So this is B and this is E. The another arc we have to cut from B to D. Second arc, and third arc from B to C. Okay, so this is CFE, this is DFS, is 30 degree. Right? So we are going to dark this length. This is what the thing which is important. So now we will project it upward to construct the second position front view. So here we get here B dash, and here at this point we have A dash. Okay, and this is we have F dash, this is F E dash, this is D dash, and this is C dash. So we have to join this. Okay, now you see the question, we have to take the diagonal passing through that corner which is in VP. So this is what the diagonal which is there in the VP, right? So this is the diagonal in VP. So we have to incline at an angle of 40 degree to HP. So what we do, so here it appears to be no bit angle. So we'll take a reference point. Okay, and the angle of inclination we take here is 40 degree. So 40 degree we have taken. Okay, so now we have to take this B dash. Okay, so we have to place it with respect to the diagonal. B dash, B dash, B dash, B dash. B dash, E dash we have put it. Now from for 2 arcs we have to cut, then another 2 arcs here. Okay, so now it is reverse. So now it is cutting here. So now we have to join this. Okay, this is C dash, D dash, C dash, F dash. Now projecting downward so we can complete the final position here. Okay, so we get B here. Okay, so we get C here, and we are getting D point here, and we are getting E here. This is F. Okay, so the E point we are getting here. Okay, so we have to join this. So this is how we complete the problem. Good morning. We see a different type of problem in hexagonal lamina. You see the question. So we have to construct a hexagonal lamina for dimension 30 mm, lying in such a way that one of its sides touches both the reference planes. So it is somewhat like a similar pentagonal lamina problem in which one of the side has to touch both HP plane and PP plane. That's what. That says that one of its side touches both the reference planes. If the side opposite to the side on which it rests is 45 mm above HP. So you can see that this is what the side which is opposite to this side, it has been inclined at a height of 45 mm. Okay, so that's how we get the second position here. They have not mentioned any kind of inclination here. Instead of it, for the second position they have mentioned this sentence, that is side opposite to the side on which it rests is 45 mm above HP. So what we do after completing the first position, we draw 45 mm line and draw the locus. Okay, after that I will be making a reference point. Okay, then measuring the length from B dash G dash, I am cutting the arc. Okay, then after cutting the arc I will be joining a line here. Okay, after that I will be measuring again from B dash to C dash and then cutting the arc on this line. So this is how we draw this second position. Now you can see in the third position we have to make sure such that the side should touches both the reference planes. Both the reference plane means both HP and VP. Now it is there in the HP plane. What we do that, we will take this AB end and we will make touch the XY line, thereby making touching the VP plane. Okay. So for that we will be taking a reference point of here B. So B to A, okay. B to A it is. Now cutting the arc length from A to F. So these two lengths will be same. Okay. Okay, now it is reverse. A to C. So here we have to cut. So we are not cutting, so we'll measure again A to F. So it is getting here. It's getting here. Okay, we're getting 2 points here. This point is C and this point is F. Again from F to E, we have to measure this point. F to E is over. Now reverse it is from F to D. Okay. So this point is D and this point is E. It is touching at this point. Okay, so now you see that this is the end AB, which is touching both the HP plane and the VP plane. Now we'll project upward to complete the final position. Okay, so here this is B dash, A dash, C dash, F dash, D dash, E dash. So you can join it. Okay, so this is what completes the problem. Problem number 47 Caed solution book. In this problem you can see that they have given circular lamina of diameter 50. So standing with one of its points on the rim on HP. So it is resting on the HP plane. The lamina is inclined to HP at 45 degree and that is the second angle of inclination. The diameter at right angles to the diameter which is passing through the point on which the lamina rests is parallel to VP. So we have to make that diameter parallel to VP. So that is what our third position. Okay, first we need to construct a circle here. Circular diameter 20, diameter 50 means, so radius we have to consider 25. Okay. So circle it is drawn. Now we have to divide the circle into 8 equal parts. -35 degree and 35 degree. So I can extend. So it is divided into 8 equal parts: A, B, C, D, E, F, G, H. Plus 50. So projected word dash dash slash c dash b dash b dash and f dash and v dash. Take a dash is the angle of inclination to HP 45 degree. So we'll take 45 degree here. So marking at 45 degree. We can give the namings here. B, C, D, E, F, G, H. So now we have to go on a list. So ellipse is constructed. Now we have to make this, okay, this the diameter we have to make it parallel to VP. Okay, parallel to we have to VP, we have to make it. So take here, this is V. Using compass, everything we have to copy this diagram. This is V. Exactly the point. So this completes the problem. Okay, we see a special type of problem in circular lamina. You see in the question, a circular lamina is inclined to the VP, appears in the front view as an ellipse. So the first position will be a circle. When it is inclined to the VP, it will become an ellipse of major axis 30 mm and minor axis 15 mm. But in this question, you see it, they have not mentioned the circular lamina dimension. So what we do is we consider major axis dimension 30. By taking 30 mm, I will be constructing a circle of diameter 30. Okay, so that's how first position and second position. Then after that, you see major axis is parallel to both HP and V. You have to make major axis parallel to both HP and VP, and one end of the minor axis we have to make major axis is in both HP and VP. So what I will do in this question is, first I will be constructing a circle by considering major axis. Okay, VP, HP. So herein I'll be, so diameter 30 means the radius will be 15, correct? So radius will be 15, diameter 30 means radius will be 15. So from this point you can say where it is touching the XY line, here, exactly here we will drawing. Okay, like this we have to draw a circle for dimension 30. So we can show the dimensions above here. Diameter 30. So what we do here is we are going to divide this circle only 4 parts, not the 8 parts here in this special type of problem. Okay, so we are dividing the circle into 4 equal parts. So we are giving the naming A dash, B dash, C dash and D dash. And here by projecting this we are getting a top view here on this XY line. Okay, so here we have A, the B it is in bracket, D. Okay, so B it is in bracket, D and C. Now we know that the second position it will be an ellipse, okay, of major dia 30. So directly we are doing it. So I am drawing a major dia 30. Next, exactly from the center we know that minor axis is 15. 15 means exactly at this point 7.5 we have to consider. 15 half, it is 7.5. So for 7.5 we have to end here. Okay, for 7.5, so marking at 7.5 on both sides. So you can see that this is our major axis, this is our minor axis. Now with respect to this we have to draw an ellipse here. Okay, so this is what the ellipse with a major axis 30 and with a minor axis 15. So this is our A dash, B dash, C dash and D dash. So we don't know how much angle it is. To find out that, we are going to extend it. Okay, so extend it. This is A, measuring from this end, from A to C, I'm gonna cut the arc. Okay, so this point is C. I'm gonna draw a line, okay, angle line. Again, there are two arcs here, right? From A to B also I'm cutting the arc. Okay, so this is B of D. So we can measure how much angle it is. So the angle we get it here, it is around 60 degree. Okay, 60 degree we are getting. Now you see the question. So the major axis has to be parallel to both HP and VP. So this is what the major axis. Okay, this is major axis and this is minor axis. So this major axis now it is parallel to VP. So we can make parallel to HP means like this. So you can see this one end of the one end of the minor axis is both in HP and VP. Now one end of the minor axis it is in VP. Now we have to make it in HP means we have to touch this point. Okay, so how we do that? So I will take this reference point A dash here. Okay, one end of the minor axis and drawing 15 mm. Okay, drawing exactly 15 mm. Okay, so drawing exactly 15 mm. Now, so we have drawn exactly 15 mm. So now I have to consider exactly half part of it. Okay, that is 7.5. We have to mark 7.5. So I marked. Now from this exactly 7.5 we have to mark 15 mm. Okay, 15 this side for to construct a major axis, right? Okay, so major axis. Now we can draw here. This is C dash. So this will become D dash and this is B dash. Now ellipse we have to draw here. It has to be a smooth curve. Okay, so this is what we complete the third position. Now final position, it is just extending okay. Projection lines. Okay, now here we get A. So this point is D, this point is C, and this point is B. Correct? So this is B dash. So now here again we get a circular ellipse here. So make sure you draw with a smooth curve. So this is how we complete the problem. Problem number 50 from Caed solution book. You can see in this problem, so they have given a circular lamina of 30 mm diameter rests on VP. So first position starts from the VP plane such that one of its diameter, so they mention one of its diameter is inclined at 30 degree to VP and 45 degree to HP. Okay, 45 degree to HP. This is HP. So you can see that they have mentioned one of its diameter means it's an beta angle problem. Okay, so in this problem our first position starts from the VP plane. Okay, So diameter 30 means we have to consider a radius of 15. Okay, 30 mm. So 15 diameter. So we have to divide the circle into 8 equal parts. Dash, dash, slash, D dash, dash, F dash, H dash, H dash. You can show the dimension. So by projecting downward, we can complete the top view. So inclination to VP we have 30 degree. Inclination to VP 30 degree. inclination to HP 45 degree. So inclination to HP it is 45 degree. So now it is a bit angle problem. We have to use these diameters. Take a plate dash. First diameter length will be this. Second I'm going to use this. Okay. Now we have to transfer this diagram over here, okay, using arc method. this completes the problem. Okay, we will learn another type of problem in rectangles, that is shorter edge and longer edge problems. Okay, in the shorter edge problems we have shorter edge problem. You can see this, we have two types of problems in rectangle. One is shorter edge and longer edge. So if it is in the problem they have asked to construct a shorter edge problem, means we have to consider a shorter length in the rectangle for the first position. Similarly, if they mention a longer edge in the question, we have to consider a longer edge in the first position. Okay, so that's what the first positions in the shorter edge and longer edge problems. Today we are going to learn another problem on longer edge. So you can see in the question, we have to construct a rectangular lamina of dimension 20 mm into 30 mm. So rests on HP on one of its longer edges. So this problem belongs to the longer edge problem in a rectangle. The lamina is tilted about the edge on which rests till its plane surface is inclined to HP at 40 degrees. So inclination to HP given, and the edge on which it rests is inclined at 30 degree to VP. So both the inclinations were given. Only thing is we have to construct an rectangle with respect to the longer edge here. Okay. So we have to construct a rectangle here with respect to the longer edge. Here 30, longer edge here it is 30. So 30, 20, so this is A, B, C and D. Okay, so we construct the front view now. So here we got the B dash, C dash, A dash, D dash. So inclination to HPT is 45 degree. Take a reference point B dash, A dash. So marking at 45 degree. Okay, so we have to cut the arc from B dash to C dash. So this is C dash and D dash. So the angle we are getting here, it is 45 degree. So here A, B, C and D. So this is what the second position top view. Okay, now inclination to VP is 30 degree. Take a reference point here. It is 30 degree. So I'll take a reference here A. Okay, measuring the length from AB. So AD and BC, these lengths will be same. Now it is reverse. A to C, and B to D. Okay, now we will project it upward to complete the final position. So here it is A dash, B dash, C dash, D dash. So this we complete the problem in the longer edge in rectangles. Today we are going to learn shorter edge problem in rectangles. Okay, so we have to see the question first. You can see this rectangular lamina of dimension 35 into 20 mm. So we have to construct a rectangle of dimension. This rests on HP, so it is resting, first position resting on the HP, on one of its shorter edges. So we have to construct an rectangle with the shortest edge here. Now the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So it is similar to your isosceles triangular problem, wherein the second position is an equilateral triangle, right? Similar to it, herein they have not mentioned the angle of inclination to HP. Instead of that, they have mentioned a second position V. Okay, in the second position top V, we getting a square of dimension 20 we can construct. Now the edge on which the lamina rests is inclined to VP of 30 degree. Okay, so in this first we have to construct a rectangle. Next, in the second position we will get a square of 20. Okay, and in the third position we have to incline it by 30 degree to VP. Okay, so we will proceed with the question. So XY VP HP. So our first position start from the HP plane with respect to shorter edge. Shorter edge means here it is 20 mm. So I'll be taking 20 here. So this is 20 and here it is 35. 35 means 3.5 box. Okay, 3.5 box. This is 20, this is 35. Okay, now we can write the notations A, B, C and D. So we'll draw the front view. So B dash and C dash visible, but A dash and D dash not visible. So you can see in this problem they have not mentioned the second position. Instead of that they have mentioned we get a square in the top view. You can see that the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So if we project it here, we get a square here, dimension of 20 here, see. So if we project it, we will get a square of 20 here. Okay, so we will get a square of 20 here, dimension. So first we will construct this. So it is similar to your isosceles triangular problem. Okay. So here it is A, B, C and D. Okay, now projecting it upward, we will get the inclination to HP. Okay, so how much we have tilted the rectangle such that we get an angle here. Okay, so this is the reference point B dash, A dash. So we are measuring this length. Okay, it is similar to your isosceles triangular problem. Measuring this length, we are going to cut the arc. So we'll get angle here. So C dash and D dash. We have to find out how much angle it is. Okay. So can find out how much angle. So it is around 55 degree. Okay, 55 degree it is. Okay. So now in the third page you can see that the edge on which the lamina rests is inclined 30 degree to VP. So we have to first take a reference point. To this reference point, drawing 30 degree angle line. Okay. So 30 degree angle line. So we have to place this resting edge on this angle line. That's it. So take a reference of A. Now A to B. Cut the arc. Next from A to D. This is also same, right? All are 20 mm only. So this is B. Now reverse A to C and B to D. A to C. Okay. Then B to D. So this is D and this is C. Okay, now projecting upward, we can complete the first problem. Okay, so we get it here. This is A dash. So B dash we get it here. C dash is this and D dash is this. So we'll join these points to complete the final position. Okay. So this is how we complete the shorter edge problem in rectangles. We see another type of problem in rectangular lamina. Okay, in this problem also they have not mentioned any kind of inclinations. So based on the question we have to proceed with the solution. Okay, you can see in this question, first we have to construct a rectangular lamina of dimension 20 into 25 has an edge. So you can see in this problem, constructing a rectangle 20 into 25 has an edge in HP and adjoining in edge in VP. So that's what our first position. It is tilted such that its front view appears as a rectangle of dimension 20 into 15 mm. So that's what your second position. Okay. So now I am drawing the first position. So you can see in this first we have to construct a rectangle of dimension 20 into 25. VP HP. So here you can see that we need to construct a rectangle of dimension 20 to 25. We know that, so it will be there in the vertical plane because the next view is in front view, correct? So how we have to proceed? You can see that one edge has to be there in HP, another adjoining edge has to be there in VP. So what I will do, I will be drawing one edge that is 20, that is touching the vertical plane, another edge of dimension 25. So I am starting with the VP here. Okay, so you can see that 20, 25. So you can see in this problem, so one edge is there in the HP plane, another adjoining edge it is there in the VP. So based on the question, has an edge in HP, okay, and adjoining edge in VP. So both the things are done. So now we'll show with the dimensions. it is 20, this is the 25. Okay, this is A dash, B dash, C dash, E dash. So here you can see that A, B, D, C. So this is what the front view. So front view also we get it on the same line. So we are done with the first position. Now we see that, so such that it is tilted, its front view is a rectangle of 20 into 15. So what we do in this problem is, it is like this. Like this. You can see that this like this. Say this is our first quadrant. Like this we have placed the lamina, and then we are tilting like this. Okay, tilting like this such that we get another rectangle of 20 into 15. So another rectangle of 20 into 15 we have to get it here. So if we project it here, okay, if we project it here, we will get 20. So that means one edge we get it here, that is 20. Okay, another edge we get it, that is 15. 20 into 15 you can see in the question. So 20 into 15, 20 into 15, that is A dash, B dash, C dash, D dash. So this is what 15 and this is what 20. Okay, it's 20 and this is 50. Okay, so this is dimension 15, this is 20. So now we have to project to get the angle here. So we have, this is what E of B. So measuring this length from here to here, you can cut the arc. Okay, this is D of C. Then you can join this, can find out angle here. So how much angle we will get it here, we'll check it. So the angle we are getting, it is around 53 degree. Okay, 53 degree. Now you see in the question, the edge which is in VP is 30 mm from the right profile plane. The edge which is in VP, right profile from the, so which is 30 mm from the right profile plane. So this is what the edge which is there in the VP, because A dash, B dash, A dash, B dash. So from this end we have to count 33 boxes. Say 3 boxes. This is 30, and exactly here we have to construct an x1 y1 line, x1 y1 line to find out the other view here. Okay, side view. So here I am marking at 45 degree. To get the side view we have to draw 45 degree angle line, correct? So this is 45 degree. So now I can project, okay, project it from both sides. I can see that where we get a D and C. So D double dash here we get, and C double dash here we get, and then here you can see AB from this end, and we have AB. So A, it's the B double dash we get it here, and this is B double dash. So this is what our side view. So this completes your problem. So based on the question we have proceeded, right? So you can see in this question also they have not mentioned any kind of view here. Okay, any kind of view. So this is RPP, so this is left side view. So based on the question we have done this problem. Today we are going to learn another type of problems on rectangles. You see in this problem the top view of a square lamina of side 30 mm is a rectangle of side 30 into 20 mm. So it's like your isosceles triangular problem, wherein first we have to construct a square here, square of dimension 30, and your second diagram will be a rectangle. Okay, After that we have to proceed with the longer side of the rectangle being parallel to both HP and VP. So you can see in this problem they have not mentioned any kind of inclinations. Okay, there are no inclination to HP or VP. So based on the question given, based on the questions, we have to do it. First thing is we have to construct a square lamina of dimension 30. This is the top view. So top view of a square lamina means first position will be in square, second will be in rectangle. Okay, rectangle of side 30 into 20. Instead of giving an angle, they mentioned the views here. Okay, first I will proceed with the question here. Okay, so you can see in this, first we have to draw an XY line. Okay, XY, VP, HP and Y. First we have to construct a square of dimension 30. Square of dimension 30 I'm going to construct. That is 4 boxes. Sorry, that is 3 boxes, right? So dimension 30 here. Square of 30 we have to construct. So this is our top view, A, B, C and D. So it is 30 mm. So the front view, what we get here, front view we get it on this line. Okay, so that is B dash, C dash visible, but A dash and D dash not visible. Now you can see in this problem we have to get a rectangle. They have not mentioned any kind of inclination. Instead of that they have mentioned a one weave, that is rectangle. So in the second position we are going to incline the square lamina such that we get a rectangle here, rectangle of 30 by 20. If I project from this side, okay, project from this side, so we will get a longer side of 30. Okay, we'll get a longer side of 30. So first I will get draw 30, then 20. We have to construct here 30 by 20, right? So 30 by 20 is the rectangle, that is A, B, C, D. 30 by 20 rectangle. So we can show the dimensions here. So this we know this is 30 and this is 20. Okay, now we have to find out the angle of inclination. How to do it? Just projecting the lines upward here. Okay, so take a reference of here this B dash and U dash reference. So by measuring this length from this B dash to C dash, okay, so we are going to cut the arc. So this is C dash and D dash. Now we have to join this after cutting the arc. Then we will find out how much angle of inclination here. So herein I am getting around 48 degree. Okay, so this is what the first position. Second, now we have to see, you can see in the question the longer side of the rectangle being parallel to both HP and VP. So longer side of the rectangle, so this is what the longer side of the rectangle, right? 30 mm. This is what you have to make it both parallel to HP and VP. So in this position it is parallel. Okay, it is parallel to HP. Now we have to make it parallel to VP. How to make it parallel to this? What is this edge AB? It is parallel to HP now. Okay, so this position it is parallel to HP. How to make it parallel to VP means we will take this AB side here like this, we'll draw like this, so that will become parallel to VP. So you can see in this here it is 30, right? So 30 right here, 30 by 20, right? 30 by 20 rectangle. These are 30 by 20. So this is B, A, T, C, correct? So yes, so we have done. So now we can see this AB end, which is parallel to HP, now it is become parallel to VP here. So now we will project it upward to complete the final position. So in this you see it, so B dash not visible, and C and we have C dash, we get it here, and D dash we are getting here, and A dash we are getting here. So this is what the actual final view. Okay. Now we can see in this question, draw the top and front views of the lamina. You have to find out the inclinations, okay, inclinations of the surface of the lamina with HP and VP. We got one inclination, that is inclination to HP. To find out inclination to VP, what we do, herein first we will draw an x1 y1 line, okay, x1 y1 line, okay. We'll draw 45 degree angle line here to this reference point, to this point, okay. So this is 45 degree angle line we will draw. Then we have to start from this top view until it touches the 45 degree angle line, okay. Then we have to project it upward. It is touching, okay. So then from this front view also, so we have to project. Now we have to see where the top view notations and the front view notations are merging. Okay, here we get, you can see that here, exactly here at this point, we have B double dash and A double dash. Similarly here exactly at this point we have C double dash and T double dash. So this is what our side view, okay. This is what our side view. Now we can find out, this is what the angle of inclination to HP, this is what the angle of inclination to VP. So if you just measure it, so already we have got this is 48 degree, right? This is 48 degree, so this is 42 degree. 48 plus 42 means 90 degree. So this is how we completed the problem. Okay, parallel to HP here, now it is parallel to VP. That's how we have proceed in this problem. Good morning. We see another problem in rectangular lamina. Okay, we see the question in this. So what is given in this question is the front weave of a rectangular lamina of sides 13 to 20 mm is a square of 20 mm side. So that's it. They have given only this thing. The front weave of a rectangular lamina 30 mm into 20 is a square of 20 mm. Draw the projections and determine the inclination of the surface of the lamina with HP and VP. So in this problem they have not mentioned either any of the inclination to the HP or to the VP. They have mentioned only the second weave. Second weave will be in square, okay. So that is occur only in the front view. So this problem will be proceed with respect to the differently. So I'm going to show it how it is. Say if you consider this is your first quadrant, so the lamina will be placed like this, okay. Lamina will be placed like this, and the inclinations, okay, the inclinations what we give, okay. So what we give, it will be like from this end, say it is like this, so it will be fixed to the one end in the first position, the second inclination like this, okay. So the inclinations we can see only with respect to the side view. For that we will be drawing an x1 y1 line, okay. So x1 y1 line will be drawn in this, and we are going to find out, okay. So this problem will be proceeding like we say, just show it how it is. VP HP. So here we draw, okay, rectangle of dimension 30 to 20. So the first view, second view, get it here. So in order to find out the inclinations, what we do, we will be drawing x1 y1 line here, and we will be drawing 45 degree angle line, and then projecting it here, we get the angles, okay. So that's how the problem proceeds. Okay. X VP. So in this, first we construct a rectangle of dimension 30 into 20, that is 3 boxes. 30 into 20. Okay. So this is A dash, B dash, C dash, D dash. So the top view we get it on this XY line only. Okay, B, D, F, C. Now the second view is a square. Okay, square of dimension 20. So we will construct that is 2 by 2 box. Okay, so we can show the dimensions here. So this is 30 and this is 20. Okay, and also 20. So 20. So this is A dash, B dash, C dash and D dash. So herein we have to find out the angle of inclinations. Okay, so how we find out here is we will be drawing in here x1 y1 line. Okay, x1 y1 line, and we are going to project these side views. Okay, project these side views. Okay, how we do it? Like the side view of this lamina first position will be lying on this x1 y1 line. Okay, so that's what the side view of this first position. So what we get here is A double dash, D double dash, B double dash and C double dash. This is what the side view of the first position. Similarly for the second position, so what we have to get the side view here is, so projecting here, so we know that, so this is what the first lamina, by inclining it how much angle we don't know, we are getting a square of 20 by 20, right? So this is what has been inclined like this. So it has been inclined like this. Say this is our first quadrant, means say this is our rectangular lamina, this has been inclined like this. So right, it has been inclined in such a way that we are getting a square of 20. So whatever the inclination is there, we can show it in the side view. Okay, how to show it in the side view means, so say this is what the side view of the first position, A double dash, D double dash, B dash, right? So this is what the side view. So this side view we are going to incline it with the help of arc. Okay, with the help of arc. So here exactly at this point we are getting the side view of the second position. Okay, so this is what the side view of the second position. Okay, so now we can get the angle here. So this is what the angle for the both the inclinations. So we can write down this. So the one angle of inclination here, it is 42 degree and this is 48 degree. Now we have to draw the top view of this. So what we do is that we will be drawing an angle line here. 45 degree we have marked angle line. Okay. So by projecting it downward, we get the another view here. Okay, so here we get it A, D, B, C. So this is what we completed with the problem. Okay, so in this position first we have drawn this one, and top view. Second, after that we have drawn this one. Okay, then after that we have drawn an x1 y1 line to draw the side views. The side view of this, it is falling on the xy line, and the side view of this, it is falling here. By taking this, because we are inclining this in such a manner that we are getting the top view, so that's why we are inclining it by means of an arc. Here I'll be showing the direction of the arrow mark. Okay, inclining it by cutting the arc, we are getting the side view of this position. So by doing it, we get the both angles. For the angle of inclination to HP, angle of inclination to VP, then the top view of this position we are getting by drawing an 45-degree angle line. Okay, so for drawing a 45-degree angle line, we are getting the top view of this position. Okay, now we are going to learn the concept for beta angle problems in plane surfaces. Okay, so how to identify a particular problem is beta angle or not. Okay, so you can see in this, if any one of the angle of inclination with respect to HP or VP, any one of the angle of inclination, so you can take either the inclination to the HP or VP. If it is there with, you can see these words are important: median for triangle, diagonal for square, perpendicular bisector for pentagon, and diagonal for circle, and diameter for circle. Okay, diameter for circle, if it is given, then it is called as beta angle problem. You can see in these diagrams, for a triangle, a line drawn from this corner point to the exactly middle of the this side, we calling that is a median. Okay, for a triangular type of problem, he will be mentioning a word called median. Okay, similarly for a square problem, he will be mentioning a word called diagonal. Okay, diagonal will be there connecting the corner 2 points, so he will be mentioning that. So that is indicating that it is in beta angle. Similarly for pentagon, we have perpendicular bisector. If this word is mentioned, means it is an beta angle. Similarly for hexagon, they will be mentioning a word called diagonal. Okay, if that particular word is defined, means it's an beta angle. Similarly for the circle, you can see this circle, so there will be diameter given. The angle of inclination will be given with respect to diameter, any one of the angle of inclination. Okay, either with respect to HP or with respect to the VP. So that's how we can identify it is an beta angle problem. So remember it, any one of the inclination either to the HP plane or to the VP plane, if it is mentioned with respect to median for triangle, diagonal for square, perpendicular bisector for pentagon, diagonal for hexagon, and diameter for circle given, then it is an beta angle problem. Okay, in beta angle problem, you see this, the first two positions will be remaining same. So that's why I've drawn the first two positions here. You can see equilateral triangular lamina of dimension 25 lies on one of its sides on HP. So we have constructed the first position top and front view. Next, the lamina makes 45 degree with HP. So 45 degree inclination also we have shown here. Now you see the only change with respect to normal type problem and this beta angle is, so it is changed only with respect to the third position. So first two positions will be remaining same. That's why I have drawn initially these two positions. Now we have to construct the third position. So that is one of its median is inclined at 40 degree to VP. That is, so you can see here the median it is given for an equilateral triangle. So it is an beta angle problem. So what is the procedure here? So please you follow it. First I'll marking a reference point, and then keeping at this reference point, I'll be marking at 40 degree because angle of inclination to VP it is 40 degree. So I'll be drawing an angle line here. Okay, so this is having angle of inclination 40. So after this drawing angle of inclination, what we have to do is we have to draw the medians here. Okay, median length. So median length it is starting from this point to here, horizontal line. So this is BD1. Okay, now similarly we have second median length, that is we have second median length from here to here. Okay, that's what the second median length. So this is BT. So we have two median lengths. Initially what we do, we mark a point of B here. First we are going to measure this first median length, this is second median length. Okay, there are two medians, one is BD1 and second one is BT. First we have to use this BT1. Okay, using the compass we are going to measure this length. Okay, we are going to measure this length. Now cut the arc. Okay, So this is PT1. Okay, after cutting the arc, what we have to do is, using the scale, we have to draw locus of line. Locus line we have to draw here. Okay, we have to draw a locus. So we call it as locus of D. So we have to draw a locus line. So after that, what we have to do? So we have to measure this length, that is from B to D. So measuring from B to D, you can cut the arc. So somewhere here you can get the arc. Okay, so after cutting the arc, so you have to join this point. Okay, you have to join this touching point, and then you can extend this. Okay, you can extend this, so the angle you can get, so that is nothing but bit angle. Okay, this is BD. Okay, BD. Now we are going to measure how much the angle we have to get here. So here okay, we have to join it here. Okay, some mistake happened here. So you can see here, 1 minute. So we have to measure exactly the length. Okay, so from BD, so cut the arc. So exactly it is cutted here. Okay, so joining of these 2 points is very important. Okay, then you can extend this line. Okay, extend this line. So this is where it is very important. Now you find out how much angle it is. So this is BD. Okay, so angle here I am getting around 70 degree. Okay, so you need to get 71 degree, but if you are getting 1 or 2 degree variation, that will be okay. So we get the BD length. Now we have to transfer this diagram over here, correct? So we have to transfer the diagram over here. So what I will do here initially, so with respect to this line, BD line, I am going to merge this 90 degree line. Okay, merge this 90 degree line. Okay, merge this 90 degree line and draw a straight line here. Okay, straight horizontal line. Okay, so after this, by cutting the arcs, okay, we have to transfer this diagram. So this diagram we have to copy. Okay, that is BD. Okay, BD, sorry, BC and BD. This will be having the same length. Okay, so here at this point we get it. This is BC and this is BA. Okay, so now what we do? So we have to join this. Okay, so this is our okay, so understood. Now we have to project it upward from B, from C, from this A point. Okay, so where they are merging, we have to see it. A, it is merging here, it is A dash. C, it is merging here, it is C dash. And similarly B, so it is merging here, B dash. So now we have to connect this. Okay, so this is what the problem. So you understood the procedure, right? So after constructing these 2 positions, we have to draw the median, that is BD1 first median and BD. So this is the first median, this is the second median. So we draw 40 degree angle line. After that we mark a point B. So first we will measure BD1, this median length, and we cut the arc. After we getting the arc on this 40 degree angle line, we will be drawing a locus. So we mention it is locus of D. Okay, we mention it is locus of D. So after that, what we do, we measure again from B to D. We're measuring from B to D, we will be cutting the arc on this locus line. So there is a locus line here, right? So on this locus line, we are cutted the arc. After cutting the arc, we are going to join BD. Okay, after cutting the arc, we join BD. And then we are going to extend this BD line using a scale till it is touches the XY line. Okay, after that we are going to find out angle. This is what your beta angle. Okay, beta angle 70 degree, around 71 degree you have to get. If it is 1 or 2 degree variation, there is no problem. Okay, so after that, same procedure by extending from C, from B, from BA, we'll get the final diagram. Understood, right? First two positions remain same as it is with the normal problem, but in the third position we see the changes. Okay, first we have to use the first median length, second median length. After that we have to find out the beta angle, then transfer this diagram using arc method, then finish the final position. So we learn another problem on a square plate lamina with respect to the beta angle. Okay, we will proceed with the question. So in this question, a square plate of 30 mm side, we need to construct a square of 30 mm side, rests on HP. So the first position starts from the HP plane, such that one of the diagonals is inclined at 30 degrees. So you can see that one of the diagonals they have mentioned. So one of the diagonals for a square means it is an beta angle problem, right? So one of the diagonals they have mentioned means it is an beta angle problem. So is inclined at 30 degree to HP and 45 degree to VP. So you can see in this question they have not mentioned either it is resting with the on the HP plane with respect to edge or corner. So we need to find out, okay, is it resting with the edge or with the corner. So is he mentioning that the angle of inclination will be there with respect to the diagonal here. Okay, so how we are going to find out? So the angle of inclination are there with respect to the first position, it is there with respect to the edge or with respect to the corner, because you can see, say consider this is one of the square, so which is connected with the diagonal. Okay, because here in the angle of inclinations were given, say like this angle of inclination to HP and an angle of inclination to VP. Okay, so what we do, you can see here. So I'll be taking a particular book here, so you can understand easily. So you can consider this is this only. Okay, so say angle of inclinations will be there with respect to this diagonal here like this. So you can see in this, so the angle of inclination if it is there with the diagonal means your first position has to be a corner here. Okay, first position has to be corner, because so angle of inclination if it is there with the diagonal, then you can see that the first position will be there with respect to the corner only. Okay, so here both the inclinations will be there with respect to the diagonal. You can see that one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. So for that I'll just drawing a rough sketch. So if our first position, okay, just for our trial, okay, trial 1, say we have been drawn a square with respect to edge. So what will be the conclusion? Say first position it is, if it is with the edge means what happens? So the second position, so in second position we are not able to incline it with the diagonal. So diagonal, say if it is there here, okay, so we are not able to incline it with the diagonal in the second position. So this one is wrong. Okay, this one is wrong. So let's say trial 2, say we have been positioned square like this. Okay, this is just a rough sketch. Say with the corner. So this is our diagonal. Okay, diagonal. So we can incline it in the second position. Okay, with the diagonal like this. Okay, so we can incline it. Say we have been placed the square lamina like this. Next first position. So in second position we can incline it. Okay, with respect to the corner point, with respect to the diagonal like this. Okay, there are two ends which is connected with the diagonals. So that means our first position starts from the corner point here. Okay, this is how we have to analyze it. Okay, so I'm going to construct a square with respect to corner here. So understood, right? The two trials we have done. So one trial with the edge. So in the second position we are not able to do it with the diagonal in case if it is started with the edge. Say if we have started with the corner means we can able to give the inclination in the second position also and in the third position also. Okay, so how to draw the square with respect to corner means as we have learned. Okay, so what is the first, I'll be marking a reference point here. So that is what the reference point. Okay, to the reference point. So using a protector, we know the procedure. So we have to mark for 45 degree, correct? So exactly 45 degree we can mark here. So I have marked for 45 degree. So I'll be drawing an line here, passing from this reference point to this. Okay. Okay. Now after this, what we have to do? We have to measure 30 mm because a square of dimension 30. So measure 30 mm from the compass using a scale. Okay. So 30 we have measured. So you can cut the arc here, 2 arcs. So after cutting the arcs from this end, so you have to cut another arcs. Okay. Okay, it is cutting here. Okay, it is wrong. So you can take little bit downward. Okay. So because in order to construct it correctly, so we'll take the reference point a little bit lower here, such that it should not merge. Okay. So we can mark again 45 degree. No need to worry. Okay. So we have drawn it. Now using the compass, we have measured 30 mm, right? Already measured it. Again we can measure it again. So it is 30. So cut the arcs. Again second arc from here. Okay. So you can join this. So this is what the square of dimension 30 will show. The dimension on one side. This is 30. Now we can mark the namings A, B, C and D. So now we'll project to complete the first position front view. So we are able to see A dash, B dash, C dash, but D dash not visible here. Okay. Now the second position. So first two positions will be same, 30 degree to HP. Okay. Second position. So I'll mark A dash. I'll be marking at 30 degree. So mark at 30 degree. Okay. So it is 30 degree. We have to cut the two arcs here. Okay. First arc from this A dash to C dash. First arc. Second arc from A dash to B dash. So I can mark the naming B dash, D dash, and this is C dash. Okay, from this A to C dash we have marked the length, and we can erase the remaining part. Now we will be projecting downward. Okay. Okay. Now we can mark the namings A, B, C. This is D. So we can join this. So this is what the first two positions. So first two positions will be remaining same. Now we have to draw an diagonal line here. First we will draw for the first position diagram. Okay, so this is I'll be marking AC1, and this one it is AC. So we will not mark with the other name, the same name, but we will change it to AC1. So this is your first diagonal line, and this is your second diagonal line. Now, so we have to draw the 45-degree angle line. Okay, 45-degree angle line we have to draw. So I will be drawing an angle line here, taking a reference point here. So mark for 45. This is 45 we have drawn. Now first I will be marking a point, reference point here. Same procedure. Mark point A. Now we have to use this first diagonal length. Okay, AC1. Okay, AC1 we have to measure. Okay, AC1 length I have measured, and I am cutting the arc. This is AC1. So after this you can draw an locus line here. I'm calling that locus of C1. Okay, locus of C. Okay, this is locus of C. Now the second arc length from A to C. Measuring from A to C, cut another arc. So this point is C. So now we join this. This is where the point is joined, then extend. Okay, and then you find out this angle. So this angle, it is your beta angle. So here the angle I am getting, it is around 55, 56, 57 degrees. Okay, so 57 degree is my beta angle. Okay, now you see that this diagram we have to copy. Okay, this already we have drawn AC, so we have to construct this diagram here. So we already have AC, so we have to construct from A to D. Okay, this A to D, it is exactly equal to C to D. Okay, just say it. A to D length, it is exactly equal to C to D, and similarly this C to B, it is same. Okay, so these two lengths are same. Okay, in a vice versa case, so you can connect it. So now you can mark this. So this point is D, this point is B. Now you join this. Okay. So this is we have done. Now we have to project upward to complete the final position. So now we have to complete the final position. You see where A is merging. So this is A dash. Similarly we have, this is B dash. So this point is C dash, and this point is D dash. Now we will join these points to get the final position here. Okay, so this is what the final position. So today we are going to learn beta angle problem related to the pentagonal lamina. Okay, so in this problem you see it, pentagonal lamina of dimension 25, so placed on one of its corners and HP. So we know that in a pentagonal problem also first two positions will be remain same, so that's what on the two positions. You can see that pentagonal lamina of dimension, so resting on HP with one of its corners. On the left hand side I have drawn the first position, and then inclination to HP it is given 30 degree, so that I have drawn. Now we have to proceed with the beta angle, because they have mentioned a word called perpendicular bisector. Okay, so for that first I will be drawing an angle line. Okay, So angle line I'm so 45 degree. So now we have to draw the perpendicular bisectors here from this corner point to exactly the middle point. Okay, this is M1. So first I will be taking a reference point of A. AM1. So this is locus of M. So this is the angle that is nothing but beta angle. So we have to find out this. So angle here we get it is around 55 degree. Okay, so now we have initially
ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿ ಕೊಡಿಸಿಬಿಡೋದು
C to B, next D to E. So these two lengths will be same. Now we have to cut the reverse here, A to B. Okay, so this is B and this is E. Okay. Okay, now we will be extending this to get the final view. Okay. Okay, now this is A dash. So B dash we get this is, C dash will get this, and D dash we are going to get here, and E dash will be getting here. Okay, now we have to join these points. Okay. This is how we complete the beta angle in pentagon. Now we will solve the hexagonal problem on a beta angle. So first two positions are already drawn. Now we will proceed with the beat angle. You just see the question. A hexagonal lamina of dimension 25 rests on one of its own corners on HP. So we have drawn the first position. The lamina makes 45 degree to HP. So we have drawn the second position. You see it. Now we can see the question in they mentioned diagonal passing through the corner that is inclined to 30 degree to VP. So now we are going to show how the beat angle here. Okay. So before for that we'll be drawing a diagonal here. Okay, this is what the first diagonal and this is our second diagonal. So I will be writing this FC1 and this is FC. Now I'm drawing, and first I'll take a reference point here, reference point. Okay, and now I'll be marking at an angle of 30. So that's what the inclination to 30 degree. Okay, so now I'll be taking a reference of a reference here F I have taken. Now first arc, so this is what the first diagonal line we have to consider, this is what the second. So first we have to consider FC1. okay, now with the beat angle concept, first this length we have to consider FC1. We are cutting the arc. Okay, so after cutting the arc, so to this point, exactly to this point we have to draw a locus. Okay, so this is locus of, this is C1, locus of C. Okay, after this the second arc length we have to cut, that is this one, FC. Okay, FC we have to measure and we have to cut on this locus line. This is your FC. Okay, now we have to join this FC line and then extend it. Okay, extend it to get the beat angle. How much beat angle we will get it here? So you have to get so we are getting it around 44 or 45 degree, so it will be okay, no problem. We have this length. Now we have to transfer this diagram over here. We have the FC length. Okay, so first I'll be measuring this FE. So this FE length, okay, see this FE length is exactly equal to your FA. Okay, so we can cut two arcs here and here. Okay, two arcs. Similarly we have FD. This FD is exactly equal to this FE length. CD and CB. So four arcs we have cut. Now the reverse, one arc length, it is exactly equal to C. FD, it is exactly equal to your FB. Similarly, so this FD, FB is exactly equal to FE and FA. So that means measuring one length, we can cut the four arcs. Okay, here this arc and this arc. So now this arc is not cutting. So this is FE. Okay, so now understood, right? The initial arc from FE is equal to FA, so that is exactly equal to CD and CB. Four arcs we have cut it. Then after that reverse we have cut it, that is FD exactly equal to FB. Similarly FB exactly equal to CE and CB. That's what we cut it. 1, 2, 3 and 4. So after cutting the arcs we have to name it. So this is E, this is D, this is A, this is B. So now we'll join this.
Sorry, sir.
Okay, so now we have to extend this. Yep. So A and A dash, so it is merging here. Okay, Similarly, we will see for B. So where the B is, so here we have the B. Okay, so initially we have marked for A dash, this is B dash. Similarly, series C, this is C dash. Similarly, we have
I will ask you for everything every time. So if you have any network problem, you have to ask. You have to tell Alga. But then
B
you
dash.
cannot tell anything from the five
F3.
That's why so that last madam also told like that. So some network problem is there. You have to come from the network person. So after that, I will for every class I will ask the students. So if you have any doubt, if any network issue, how to ask them.
Okay, so now we will join it.
Clear. Okay. Yeah, madam. I already told you that today I will share with you. Okay. Okay, thank you.
So this is what the final position. So understood, right? So first diagonal length will be cut at FC1, then locus line, then FC. So we have to cut the arc, then connect, and then extend. You get the beta angle. Then transfer the diagram using arc method. Then the final position.
Sir,
So what is the concept for normal type of problem in projection of solids? So the concept here, it is very simple. If the angle of inclination it is given with respect to HP and VP, if it is there with the base edge and axis, so you can see that one of the inclination will be there with the base edge and other inclination will be there with the axis. So then it is a normal type of problem. So it is very simple. You need to see in the question the angle of inclination either to the HP or VP if it is given with the base edge, and angle of inclination either to the HP and VP if it is given with the axis. Then the problem will become normal type of problem. Okay, normal type of problem in the projection of solids. And the same concept hold goods for the prism, pyramid and cone. Okay, the same concept apply. Problem number 5 from Caed solution book. So what is given in the question is a pentagonal prism, dimension 25 and axis length 60. So rests on HP on one of its edges of the base. So we have to get the edge on the right hand side. So which is inclined to VP at 30 degree. So here it is base edge inclination to the VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 40 degree. So here it is a normal type of problem because angle of inclination they have mentioned with respect to base edge and the axis. Okay, that's why it is normal type of problem. Okay, now we will construct. First we are going to construct an XY line. So we have to construct a pentagon with respect to edge on the right side. Okay, so dimension 25. So now we will take protractor and mark for 72 degree on either side. Okay, from that reference point we are marking at 72 degree and drawing a line of length at 25 to that marked angle point. Again keeping at the another end point, marking at 72 degree and drawing a line of length 25. Okay, now taking compass, measuring 25 mm length, so we have to cut 2 arcs from that reference point. So join it to complete the pentagon. So now we are going to mention the dimension 25. Now we write the namings. Top face A, B, C, D, E and bottom face A1, B1, D1. So all the things written in bracket because bottom face not visible from the top view. Now we draw perpendicular bisectors by marking middle point of any 3 edges and drawing thin lines here. Okay, so herein we are drawing thin lines to find out the center of the axis. So remember it. So in prism we are drawing the thin lines. So O1. Now project it upward to complete the front view. Okay, the front view of a prism, it is a rectangle. So here we have to construct a rectangle for a length of 60 mm. So first I am constructing an axis for length 60 mm. So we are going to construct a rectangle here. Now writing the notation, which are the ends visible, we write without brackets, and which are the ends which are not visible, so we are going to write down with the within the brackets. Now second, it is second position written with the base head's inclination. So base head's inclination is equal to 90 degree minus angle of inclination to the HP, that is 40 degree. So 90 minus 40 degree, it is 50 degree. So first I will take a reference point of T1 dash and C1 dash, taking protractor, marking at 50 degree. So mark at 50 degree and draw an angle line passing through that point. Okay, draw an angle line passing through that point. Now we have to cut the arcs for the base heads. Okay, so cutting the arc using compass from D1 dash to A1 dash, then D1 dash to B1 dash, then D1 dash to O1 dash. Okay, now writing the notations. So A1 dash, B1 dash and E1 dash, O1 dash. Okay, now you see these vertical edges are exactly perpendicular, so that's why from all these points we are placing the protractor and marking at 90 degree to draw the exactly perpendicular lines. Okay, so on all those reference point we are marking at 90 degree, so we have to draw perpendicular lines. So mark at 90 degree. So now, so draw a line of length passing through these points at a length of 60 mm. Okay, so draw a line of length passing through that point, length will be 60. So writing down the notations. So now we are extending the axis to show the angle for angle of inclination to HP. Extend the axis and check the angle. So here we are getting the angle of 40 degree. Okay, so inclination to HP it is 40 degree. Now project the lines, project it downward, project the lines, project it. Project it from this end also. Okay, first writing the notations for the bottom face. So here it is A1, B1, C1, D1 and E1 and O1. Similarly A, B, top face, we are writing for the top face now. A, B, C, D, E and O. So now we write the outer boundary line. So that is what the first step, writing the outer boundary line. Okay, connecting all the outer points to draw outer boundary line. So constructing the outer boundary line. Now visible face, the top face it is visible, that's why we get the continuous pentagon here. And then edge, you see A dash and A1 dash, that is also visible. So continuous line. Now you see bottom face not visible from the top view, so that's why a part of the pentagon will be written with the dashed line. Okay, now the slant triangle, rectangular face D1 and CC1 not visible from the top view, that why it is also dashed line. Okay, so part of the axis we show it. Now we have to draw an angle line for the base edge inclination. So base edge inclination we will be drawing angle line like this. Inclination to VP 30 degree. So we have to make sure our third position diagram should not merge with the XY line. Okay, so when we construct, so from D1 to C1 we can cut the arc. We have to place the resting edge on that angle line. So it is merging, so we should avoid that. So we can take that angle line little lower here. So we will take the angle line so little lower here. Okay, so mark the reference point and mark for 30 degree. So D1 is the reference point. From D1 to C1 we have to cut the arc. From D1 to D and C1 to C. Okay. So now it is reverse. D1 to C and C1 to D. Reverse we have to cut. That is D and that is C. Using compass we have to construct two pentagons here. So the length will be here remaining same, you just measure it. D1 and D1 it is exactly equal to D to E and C to B. Okay, C1 to B1. So those are all the same lengths. Okay, that's why I am taking that only one length and cutting the 4 arc, because all those 4 lengths are same. Now it is reverse. Okay, D1 to B1 if you measure, and that will be used for D1 to B1 and C1 to B1. Okay, that will be same. Okay, now from D1 to A1 and C1 to A1, that is also same length. Okay. So now you have to write the namings. It is E1, A1, B1, that is E, A and B. So now O1 we have to cut. D1 to O1 and C1 to O1. Same, C to O and D to O we have to cut. Now you have to join all these points. Using scale we have to join. First we are going to join constructing a pentagons. So wherever the dashed line is there, so we are going to draw the dashed line. where there is a continuous line, we are going to draw with the continuous line. Okay. So part of the axis, you can show part of the axis. Okay. Now the nearest point to XY line, you see here it is D. Okay. So D is the nearest point to XY line. D is connected with C, and D is connected with E, and D is connected with D1. So these are the dashed lines. Okay. Now we write for the top face, and considering top face, we write the notation first. Writing down the notations carefully here. Similarly for the bottom face also we write the notations. Okay, first we are going to construct the dashed lines. You see this. So D dash to E dash, first dashed line. Okay. Then D dash to C dash. Then from D dash to D1 dash dashed line. Now everything, now remaining thing will be written with the continuous lines. So first we are going to construct the pentagons. Finally there is an axis. Okay, this completes the problem.
Good morning all of you. Today we are going to start first problem in projection of solids. So with the prism. So we know that in the projection of solids we have to consider the right hand side reference for placing the base edge or the base corner. Okay, say just for an example, say you can see that this is our pentagonal prism which is having top face and bottom face. So you can see that this is our base edge, okay, base edge, and this is our base corner. Okay, so we have to place it with the right hand side reference, and we know that our first position starts from the HP plane. Okay, so that's not the thing. So how the problem proceeds here, say consider, so this is our first quadrant, say this is our pentagonal prism, say I am placing with the right hand side reference. So right hand side reference means this side, okay, right side, first position, drawing the top view, front view. You can see that you have two faces, top face and bottom face. Then drawing the top view, front view. Second position, it is a inclination, right side inclination, okay, inclination to HP, and then top view, front view. Similarly, inclination to HP was already given, so it is inclination to VP. Okay, so understood, right? So it is what the inclinations, you can see that first position, inclination to HP, then inclination to VP, like this. So now we will proceed with the problem. Say in this problem we have to construct a square prism here, XY, VP, HP. So you can see that we have to construct a square prism. So of square prism of dimension 35 mm side, of base and axis length 65. Rests on HP on one of its edges of the base. You can see that. So say consider this is your square prism. So this is having, we need to construct with the base edge here. Okay. So here we have to construct the right hand side, we have to construct the base edge. So if you consider a square prism, the top view, okay, the top view of a square prism, it will be in square, correct? Square, which is having top face and the bottom face. That means you need to construct a square here, square of dimension 35. Okay. Okay, so we have drawn a square here. You can see that. So in the square prism, we have two faces, top face and bottom face. So top face will give A, B, C, D, like that. If you take this duster, okay, top face A, B, C, D, which is visible to us, and the bottom face, which is not visible from the top view, so will be giving A1, B1, C1, D1. That will be in bracket. Okay. So the top face notations are A, B, C, D. Similarly, bottom face notations are A1 in bracket, B1, C1, similarly D1. Okay. So now this is what the top view, and there will be an axis here. Okay. There will be an axis connecting the top face center and the bottom face center. We need to find out the axis of the center. Okay. So how to find the axis? And we will draw the diagonals here. So diagonals will be thin lines here. Okay. Draw with the thin line. So here exactly the top face center O and bottom face center O1, which is in bracket. Okay. Now we know that we have to draw the front view. Say if you consider this, this is as your square prism. Though we have drawn the top view, okay, top view of it with the two faces. Say when we are looking in the front view, we will get a rectangular face here, okay, rectangular face. For that rectangular face, they have not mentioned anything. Instead of that, they will be mentioning a 65 mm axis length. Using the 65 mm axis length, we can draw the front view. So we know that axis center connecting the top face and the bottom face, which is having an axis length of 65. So by projecting, okay, these are the projection lines. Directly. So using the axis length, 65 axis length, I am drawing the front view. We know that front view is a rectangle here. So remember it, front view of a prism. The front view of a prism in the first position is always a rectangle. So first I am drawing an axis line here. So axis line of dimension 60 here. So first I will draw an axis line, so which is having a dimension of 64. Okay. So using this axis length, I am going to construct the rectangle. Okay. So in the front view we get a rectangle. Now we have to write the notation of it. So from the front view we can see that. So from the front view, so you consider this is your front view. So we can able to see from this front view B, B1, C, C1 visible, but A1 and D1 not visible, correct? So you can see that. So from the front view we can able to see these ends B, B1 and C, C1. So first I am going to finish with the top face. You can see that. So B dash it is visible, C dash that is also visible, but A dash it is not visible from the front view, and D dash not visible. You can see that this A and D not visible. Similarly, you can see that bottom face B1 dash which is visible and C1 dash which is visible, but A1 dash and T1 dash not visible. So similarly you can write so O1 dash and O dash. So that is 1 T. So now we have done with the first position, top and front view. So second position, we know that we have to give the angle of inclination to the right side. Okay, angle of inclination to the right side. So second angle of inclination to the HP, here they have mentioned 45 degree. So what is the procedure here to do it? So first we will be taking this reference point of C1 dash D1 dash reference point. By taking this reference point, using the protector, you can keep the protector here exactly and mark for here in the right side from here 10, 20, 30, 40, 45. So mark for 45 degree angle and draw an angle line here. Okay, draw an angle line. So that is for 45 degree. After say first taking the reference point and keeping the protector and marking up for 45 degree and drawing an angle line, what is the thing? Next you have to take the compass and measuring from C1 dash to B1 dash, you need to cut the arc. Okay, you have to cut the arc. This is B1 dash, B1 dash, and the second arc you have to cut it from C1 dash to O1 dash. This is O1 dash. Okay, so after cutting this arc, so this is the length we require, right? So this is the length. So after this, say we have been drawn the bottom part of it. So these vertical lines we have to draw. You see that these three vertical lines are exactly perpendicular to this base line, right? So you have drawn the base. So what you do, you take the protractor, keeping at this reference point, you mark for 90 degree. So here you have to keep the protector and mark for 90 degree. Similarly, you have to keep the protector and mark for 90 degree. After drawing the 90 degree, this length we know it is 65. Using a straight line scale, you can draw a straight line here. Okay. So draw the straight line. And then run it using the scale. So this is B dash, A dash. This is O dash. This is C dash, D dash. Okay. So now, so you can extend this axis because the angle of inclination it is given with the axis. If you extend this axis and measure the angle, you will get exactly 45 degree. Okay. So now we will project it downward to complete the second position, top view. Okay, so for writing the notations, so you have to consider either the first face first or the bottom face. First I will consider bottom face here. You can see that, so here they are merging. This is A1, this is B1, this is C1, this is D1, and this will be O1. Similarly for the top face also, for this one also we can write. So this is A, this is B, this is C, this is D, and this is A. Okay, so you have done the namings. Now you see the concept here. So here it involves 3 steps to construct the second position top view. First thing is you need to draw an outer line. Okay, remember it. So first we have to draw an outer boundary line. You can see that I'm starting from the A1 point. So A1 to B1. So that's an outer boundary line. Then B1 to C, okay, B1 to C, C. So it is another horizontal line. Then from C to D. Then D to E1. So this forms an orthogonal, that is A1 to B1, B1 to C, C to D, C to A1. So that is the first step, orthogonal line. Now, if the second step in writing the second question is seeing for the visible faces and visible edges. Say we are looking this thing from the top view, right? Looking from the top view. So you can see this in this diagram. We are clearly able to see the top face of this sphere prism, right? That is top face, it is visible like this. It is inclined like this. We are able to see from the top view this face. This face is exactly visible from the top view. So that is, so this sphere is visible. So we can join this ABCD. So that is the sphere we get it. So similarly, you can see that this edge B dash A dash B1 A dash, this is also visible. It is already written with the continuously. Okay, that's what the second step. Second step is writing the visible faces and visible edges. Okay. Now the third step is writing the hidden face and hidden edges. So you can see this bottom face not visible from the top. Okay, bottom face that is not visible, but already we have written a part of it. Okay, part of the sphere. But the remaining part we can show it with the dashed line here. Okay. So that's what a dashed line. So in this we cannot able to see this B1 and C1 here. Okay, that's what the thing. And then you can see that there is another this face also not visible. That is C1 D1 to D and C1 to C. But already we have written a continuous line. Okay, no need to show. Now you can show the axis line here. Okay, so that's what the axis line. Now in the third position you can see that. So you can see that one of its edges of the base which is inclined to VP at 30 degree. We know that in the normal type of problem, one angle of inclination will be there with the axis, okay, and then another angle of inclination will be there with the edges of the base, okay, base edge inclination. So what we do, so we have to draw an angle line here, okay, angle line here. So what we do, initially we draw a straight line here, okay, smaller line parallel to the XY, okay, parallel to the XY. So here I am marking the reference point. So you can keep the protector here and mark for how much angle. So angle here given, that is 30 degree. So mark for 30 degree and draw an angle line. So draw an angle line. So this is 30 degree. So now what we have to do, so if say see that, so this is what the base edge, okay, this is CD1 D1. You can see in this problem also we are inclining like this, inclining with the C1 D1, that's what the base edge. So we have to take this base edge, you can see in the question also. So one of its edges of the base which is inclined to VP at 30 degree, that is taking this D1 C1. So we have to make it resting on this angle line. Okay, how to do that? So I'll be taking first a reference point of D1 here. Okay, then using measuring from compass, measure from D1 to C1 and cut the this is dashed line, right? So D1 C1. So we have cut it. Now we can see in this question. So to this line, to this D1 C1 line, these two lines are exactly perpendicular, right? Exactly perpendicular. So what we do here, you take the protractor and mark for 90 degree on both sides, because these lines are exactly perpendicular to this. So taking the protractor, mark for 90 degree on both sides. Okay, you keep the protractor here, mark for 90 degree. Similarly, you keep the protractor here, mark for 90 degree. So after that, what we do, we will be drawing a straight line here. Okay, straight line here. Okay, straight line. So after that, what we do, we will take the compass, measure from D1 to A1. You can cut the arc. This is A1. Similarly, C1 to B1 you can cut the arc. So that is B1. Okay. Now similarly we have D1 to A1 also you can cut the arc. D1 to A. So D1 to A also you can cut an arc. Okay. Similarly C1 to B also you can cut the arc. Now from A to D also, by measuring from compass we can cut the arc A to D. Okay. A to D. Similarly from B to C also you can cut. Now we left with this O1 and O. You can see that you can cut that from A1 to O1 and B1 to O1 using the compass. Okay. So we are going to cut that. This is O1. Similarly, we have A to O, the arc, then B to O. Okay. So now after cutting all this arc, so using a scale, you can join all these things. So join all these things using a scale. So this is the second diagram we have copied to the third position. Okay. So now we have to complete the final position here. Okay. So how to do the easiest method here is, easiest method is, first I'll be drawing this, writing the notations of this top face and the top face, and then bottom face and the bottom face. Okay. First I'm finishing with the top face. You can see that. So draw a projection line till here only. So where it is the D dash. Here we have this is D dash. Okay. Similarly, you can write for C dash also. C dash also we get it here only, right? So this is C dash. So similarly, you can write project only till where our any point we get it is A dash. This is B dash. So similarly we have this O point. Okay. This is O dash. Okay. So understood, right? Top face of this and the top face of this are getting here. Similarly, now we see the bottom face. So here the bottom face we have, this is D1. So here we have D1 dash. Similarly, this is C1 dash. Okay. And A1 is here. We are getting this A1 dash here. Similarly, we have this is B1 dash. And here it is exactly here we have O1 dash. Okay. So now we have done with both bottom face notations and top face notations. Okay, this is how we have to do it. Now for writing the final position we have here concept that, so we have to see the nearest point to the XY line. So this is our XY line. The nearest point to the XY line, it is D here, correct? So you can see that the D is the nearest point. I will write here. So the D is the nearest point here. Okay. So nearest point is D. You can see that D is connected with which other? D is connected with C and D is connected with A. Okay, and D is connected with D1. It is like this. It is inclined like this. It is inclined like this. So this is what the D point. Okay, D point. So D point, it is connected with C. D is connected with A, and D is connected with D1. Okay, like this. D is connected with C. D is connected with A. D is connected with D1. Okay, these are the near connected points to it. So D is connected with C, and D is connected with A, and D is connected with D1. So these are the dashed lines. Okay, first we will finish with the dashed lines. That's all the concept. Take the nearest point. After taking nearest point, see that which are the adjacent points. D is connected with C, D is connected with A, D is connected with D1. Okay, so those are the dashed lines. So D dash to C dash. So this is a dashed line. So this is a dashed line. Then D dash to A dash. That's also dashed line. Then D dash to D1 dash. You can see that from here to here. Okay. So we have drawn with the dashed line. You can see that D dash to C dash, D dash to A dash, D dash to D1 dash. Then the rest of the thing, it is only with the written with the continuous line. First I am writing with the top face. Okay, the top face it is written. Similarly, the bottom face. So using a scale, you can do it. So you can see that A dash, B dash, C dash connected with the top square, bottom face it is done. Now the vertical edges, say from A dash to A1 dash, B dash to B1 dash, C dash to C1 dash. So straight vertical line using a scale you can do it. Okay, so C dash to C1 dash. Similarly we have B dash to B1 dash. Okay, so this is what we done. Now we have to draw an axis line. Say axis line from O dash to 1 dash. So we are showing with the axis line. So understood, right? So how to write the final position here it is. First take refer nearest point XY line D. Okay, 1 point. D is connected with C, A and D1. These are the dashed line. First we have done with the dashed line. D dash to C dash, D dash to A dash, D dash to D1 dash. After that what we did? So after that remaining part we have written with the continuous line. Okay, so that's how we complete the first problem in projection of solids.
The concept for beta angle in projection of solids. So what is the concept here is if the angle of inclination to the HP and VP, say both the inclinations to the HP and VP, if it is there with the axis, then it is a beta angle problem. Okay, beta angle problem in projection of solids. So the same concept it is related to the prism and pyramid also. So you have to see that if the angle of inclination it is there with the axis for both HP and VP, then it will be an beta angle in the projection of solids. The same concepts hold good for prism, pyramid and cone. Welcome to Engineering Visualization channel. Problem number 8. A pentagonal prism, 25 mm sides of base, 50 mm axis length, rests on HP on one of its corners of the base, such that two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projection of the prism when the axis of the prism is inclined to HP at 40 and VP at 30. So here first we have to construct a pentagon. In the first position we have to construct a pentagon, okay, of dimension 25 with respect to corner here. Given in the question, corner of the base, that means we have to corner on the right side. We know that in solids right side is the reference for considering the base corner. Okay, now here type of the problem. So which type we have to identify. Here the type of the problem here, the axis is given for the inclination to both HP and VP. So axis given means it is nothing but beta angle problem. Okay, beta angle problem, because axis is given for both HP and VP for the inclinations. Okay, now we are going to construct an XY line, okay, using the sketchbook sheets, okay, grid sheet, using grid sheet, because many of the students are using the grid sheet in VTU. So we will be considering the same thing here. First I will be drawing an XY line, horizontal line, exactly at the middle of the page. Okay, use the scale and draw a straight line. Okay, draw XY line and mention VP HP. Okay, because we are using first quadrant, so we have to mention this VP and HPs, remember it. And now we have to construct a pentagon. Okay, pentagon with respect to corner position, okay, which is of dimension 25. So using the scale, draw a line of length to 2.5 centimeter at 25 mm. Then use the protractor here, protractor for marking an angle of 72 degree. Outer angle we have to consider here, remember it, 72 degree exactly we have to mark. And now passing to that angle point from the reference end, we have to draw a line of length 25 mm, that is 2.5 centimeter from the scale we have to draw. In same way on this end also we have to mark an angle of 72 degree. Okay, and draw a line passing through that angle point, length of 25 mm, that is 2.5 centimeter. Draw a line. Okay. Now using the compass, measure 25 mm from the compass and cut the arc. You measure any one of the length here because all the lengths of 25 mm only. By keeping at that reference point, cut the first arc. Okay, and keeping at the second reference point, cut the first arc. Now you are getting a cut point. So join that arc cut point for this end point with the straight line using scale. Join it. Okay. You can give the naming for this. In prism, you know, it is having two face, top face and bottom face. A, B, C, D, E is the naming of top face. A1, B1, C1, D1 and E1 is the naming of the bottom face. Okay, which is not visible from the top view. That's why it is written within brackets. Okay. Now show the dimension for one edge here. Here I am showing for one edge as 25 mm. Mention 25 mm here. Now we have to draw a perpendicular bisector here. I will be drawing two perpendicular. You know how to draw. So you need to draw a line exactly. First mark the midpoint of the edge and try to connect with the opposite corner using straight line. Okay, marking the midpoint and then try to connect with the opposite end. You will get the perpendicular bisector. Now you are getting the center, that is O1. Okay. Now draw the projection lines to construct the front view here. So here projection lines should be thin lines here. Make sure you should draw the thin lines. Okay. So in the problem given the axis height, axis 50 mm it is. So here the front view of the prism, okay, front view of the prism, it is a rectangular face. So here first I will be constructing a axis for a dimension of 50 mm. Same way you can draw here vertical lines for a length of 50 mm. Draw the rectangular face here. Okay. So show the front view dimension. Here front view dimension it is 50 mm. Mark the dimension of 50. Okay. Now we can write the front view namings. So from the front view, B dash, C dash and D dash visible, A and the E dash not visible. So B dash visible here, C dash visible, D dash visible, E dash and A dash in bracket. In same way for the bottom face, B1 dash and A1 dash not visible, C1 dash visible, D1 dash visible and E1 dash not visible. In same way axis center O1 dash and O dash not visible. So now we have done with the first position. Now we have to construct the second position. For the second position they have given inclination to HP 40 degree with respect to axis. Okay, but we will be constructing using the base edge here. Okay, so base edge inclination is equal to, we know the formula, 90 degree minus angle of inclination to HP. It is given 40. So 90 minus 40 degree means it is 50 degree. First I will be marking a reference point, that is D1 dash on a XY line. Okay. Then place the protractor and mark for angle 50 degree here, because base edge angle is 50 here. Now draw a line passing through that point. Okay. Now using compass we have to cut the arc. So the reference point here, it is D1 dash. We need to measure from D1 dash to B1 dash. that is our first arc we need to cut on the angle line. Okay, measure it like this and cut it. And this point is nothing but B1 dash and E1 dash. Okay, A1 dash. The second arc should be from D1 dash to O1 dash for the axis. Okay, this is your O1 dash. Now the third arc we need to cut from D1 dash to E1 dash, that is C1 dash you can say. So measure the arc length and cut it. Okay, now we can see for this base edge here, these vertical lines are exactly perpendicular. You can see this, all these 4 lines are exactly perpendicular to the base. So what we do, we are going to use the protractor and mark for angle 90 degree for all these reference points. Okay, place the protractor here, mark for angle 90 degree, fix up for the C1 dash here, mark again 90 degree, same way mark for O1 dash axis point, mark again 90 degree, then fix it for the last corner point, again you mark for 90 degree. Okay, now using scale, so we should be drawing for that 90 degree a length of 50 mm, because it is the same length we should copy here. So draw a line of length 50 mm. Count it 1 2 3 4 5. So till there you have to join. Same way for the axis also, to that reference point we have to draw an axis. Now we can connect from C1 dash to, from there you draw one perpendicular line for a length of 50 mm, and again for the D1 dash also you draw one line which is of length 50 mm. I can now draw the top face by joining all this point. Okay. Okay, now join the top face, write the top face notations: B dash, A dash, O dash, C dash and E dash and D dash. Okay, now we have to extend this axis to show the angle, because angle of inclination to HP they have mentioned with respect to the axis. So we need to show the angle for the axis only here. Okay, you can cross check the angle using protractor. So it is exactly 40 degree. Okay, that's what the angle given in the question, 40 degree. Okay, now draw the projection lines downward to complete the second position top view. So draw the projection lines here, vertically downward one by one from all these reference points. So draw straight lines. Okay, horizontally also we need to draw the projection lines. So use the scale properly and draw the horizontal lines. These lines need to be straight. Okay, so use the scale properly in order to draw the straight lines. Okay, now we can write down the namings for the second position top view. First I am writing for the bottom face, that is bottom face is A1, B1, C1, D1 and E1, and this is O1. Same way for the top face, A, B, C, D and E, and mention the O here. Now to construct this second position top view, we will be following 3 steps here. Okay, to construct or write, you can say, second position top view. So this concept will be holds good for all the prisms and pyramids. First step is writing the outer boundary line. So outer boundary line we have to draw, that is from A1 to B1, B1 to C1. We need to connect it using the scale here. So just draw the straight lines connecting it, A1 to B1, B1 to C1, then C1 to C, then C to D, then D to E, then E to E1, then E1 to A1. So this forms an outer boundary line. Okay. Now the second step is writing the visible faces and the edges. So we have to write or construct the visible faces or the edges. Okay, that is our second step. So visible faces and edges we will be constructing using continuous line. You can see as we are looking this diagram from the top view, this position. Okay, so as we look from the top view, so this face is visible, right? From the top view, this top face is visible. So which are the visible face? Here the top face is a pentagon. So we will be connecting all this with the continuous line here. Okay, you can subscribe to my channel and hit on the bell icon for the latest notifications and share it to maximum students so that they can be benefited. And this rectangular face also visible here, that is A to A1 and B to B1. So this also you connect it with a continuous line. Okay. Now the third step is writing the hidden faces. Okay. So constructing the hidden, or you can say invisible faces and edges by dashed lines here. So we need to use the dashed lines here. Okay. So you can see here the bottom face of this pentagonal prism not visible, but already a part of the pentagon we have written with a continuous line. So here there is a concept called if there is a merging. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. We have to show the continuous line. That means we will be showing only a part of the pentagon with the dashed line here. You can say because already we have constructed a part of the pentagon with the continuous line. The remaining part, okay, the remaining part we will be constructing using the dashed line here. So try to join with the dashed line here. Okay. Now this head is also not visible from the top view, that is D dash and D1 dash. As we try to write in the top view, it will be from D1 to D. Okay, that will be the dashed line here. Okay. Now we can see here we need to write the finally the axis here, axis from O1 to O, but part of the axis I can show because there is already a dashed line there. Now the third position. Okay, now the type of the problem here, it is beta angle, because they have given axis of the prism is inclined to HP at 40 degree and to VP at 30 degree. So for that angle line we have to draw like this. From their reference point I will consider and draw an angle line for 30 degree. So inclination to VP they have given in the question, it is 30 degree. So you need to make sure the space which is to be constructed here, make sure that the second diagram when we try to copy, it should not merge with the XY line or it should not leave the page. Okay, like that you try to draw the angle line. You should be here careful. Okay, when you are drawing an angle line, I think I should take the angle line little lower so that the diagram can be copied easily. So now from their reference point you can mark an angle 30 degree. Okay, mark for angle 30 degree. So from that point I'll be considering the angle line little lower. Okay, as I mentioned, you should not merge with the external or with the second diagram. Okay, draw an angle line for 30 degree. So this is having angle of 30 degree. Okay, now so we know that in the beta angle problem it is with respect to the axis we have to do. So there are two axes given, 50 mm front view, that is your first axis, and the second axis length is second position top view. So this is your second position, so we should be considering this length, okay, as your second length for cutting the arc and finding out the beta angle. This is your second length. Okay, so first axis length we have to use this one, that is 50 mm for cutting the arc. Okay, so this is your second length we should consider. Okay, second axis length. So first axis length given in the problem it is 50. First you take a reference point. Okay, take a reference point, that is your O. Measure the length of 50 mm. Okay, from the compass and cut an arc. So here axis length is 50 mm. So measure using compass and cut the arc. And to avoid the confusion here, we will be giving this as O2. Okay, after cutting an arc, we should draw here locus line. Locus line we should draw here, where exactly it has cut it, right? So draw an locus line. We'll be mentioning this as locus line. Okay. Now the second arc we should cut, that is from O to O1. From the second position top view, from there to there we should measure using compass and cut the arc. We need to cut the arc on the locus line. Okay, so cut it, and you can mention this as O1. Now connect from O1 to O. Okay, and then extend and find out the beta angle here. So using the protractor, so here the beta angle we will be getting, it is exactly 41 degree we'll get here, angle of 41 degree. Okay, so here the beta angle how much we got, it is nothing but angle of 41 degree. So we can mention. Now we need to copy the diagram. So this second position top view we need to copy on the O1. Okay, this one we should copy here. So you can see we have already O1. Okay, on O1 we have to copy the diagram. Okay, using the compass I'll be constructing this top face first and then the bottom face. So measure the length using compass from O to D here. O to D and O1 D1 both are having the same length. I'll cut two arcs here. First arc is from O to D. I'll mention that D, and same length it is there, right? So I'll be cutting another arc without changing, that is O1 D1. That is also of the same length. Okay, you can do that like this. You can do O1 and D1. Okay, now using from O to A or O to E, you can say O to E and O to C. These two lengths will be same. We can cut two arcs here and here. Now from D to E, because you have the D point, right? D to E and D to C, these two lengths are also same. Just cross check it, same lengths. Now cut those first arcs, this one and this one. Okay, and we need to mention its naming here. So this is E point and C point. So mention. If it is not cutting properly, you can do it. Yes, now it is cutted. This is your point number E and this is point number C. Okay, now we have to cut the arc from O to A and O to B. These two lengths were same, OA and OB. So cut it, OA and OB. You have to cut. Now we can cut from D. Okay, we have that reference point, right? DA and DB, we can cut it from there to here and here. Can mention the naming as A and this is B. Now construct the pentagon. Connect all these points using scale here. So connect all these points here. We'll get the pentagon, and same way we need to do it for the bottom face also. Using O1 and D1 we need to construct the lower pentagon. So measure from O1 E1 and O1 to C1. Cut it here and here. Now from D1 to E1 and D1 to C1. Here and here you can cut it, and these 2 points you can mention as E1 and C1. Okay. Now again from O1 to A and O to B, these 2 lines will be same. Cut the arcs here and here. Okay, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. So cut this arc. So finally we get it A1 and B1. Okay. Now again construct the pentagon here. So however it is there in the second position top view, we need to maintain the same thing. Wherever there is a continuous line, we'll draw with the continuous line. Where there is a dashed line, we'll connect with the dashed line. So construct the pentagon here. So in the same way we have to construct. Wherever there is a dashed line, we need to construct with the dashed line. Where there is a continuous line, we should be constructing with the continuous line. Okay. Okay, now we need to construct the final diagram. For this we should be drawing the projection line upward. So to draw easily, you can see, consider top face here and here. So first you consider these top faces and write the notations, so that it will be easy to write the notations. Okay, otherwise there may be chances of confusion in. So you can see here from A I am drawing a line here, projection line. A and B, vertical lines, straight lines you just draw. Okay, don't get confused that it should be merging or not merging. No need to consider anything, just draw the horizontal and vertical straight lines. So these 2 points are nothing but A dash and B dash. Okay, now same way we will be drawing the projection lines from E and C. Okay, from E also you draw the projection line, that is E dash. Same way you draw the projection line from that C end. Okay, draw the horizontal line properly, that is your C dash. Okay, now same way we need to construct D here. D and D dash, where it is merging, we have to see D and D dash merging at this point. This is we call D dash. Now finally O and O dash, we need to connect O and O dash. This is your O dash here. Okay, now from bottom face also we need to do the same thing. D1 dash, draw the projection lines and connect and try to write the namings so that it will be easy. Okay, by following this procedure you can finish up the problem in less time. Okay, You can subscribe to my channel and hit on the bell icon for the latest notifications, and share it to maximum students so that they can be benefited. So particularly these problems are very useful to the first year engineering students throughout the world. They can benefit it by solving these types of problems. Can write the notations like this. Okay, and finally we have left with O1 dash. So you can project it this also. Okay. And this is your O1 dash. Okay. Now here to procedure to construct the final diagram, here it is. First you need to construct the base here. So here in this problem it is pentagon. So we will be constructing a pentagon. If it is a square, you can construct the square. If it is hexagon, you can construct the hexagon. Okay. So try to connect all these points. You will get a pentagon here. Okay. Now we can see from the pentagon, so when we try to join the vertical edges, so vertical edges which are coming outside of the pentagon are continuous lines. If the vertical edge coming inside of the pentagon, that will be the dashed line. Okay, you can see from E1 dash to E dash. Okay, it is passing inside of it, so that's why we are going to draw the dashed line here. Okay, the remaining lines will be continuous here because all the lines were passing outside. I'll be drawing those lines. Okay, you can see here E dash is the dashed line. E, it is connected with A dash, that is your first dashed line. E, it is connected with D dash. E dash, A dash and E dash, D dash is the dashed line. Now all the lines here, that is vertical edges, we should be constructing with the continuous line here. Okay. That is a procedure here. You need to see whether the lines were going inside of the base of the pentagon or outside. Outside means continuous line, inside means the dashed lines. Okay, so that's what the procedure is very simple. You can follow these steps so that you can easily able to complete the final diagram. Okay, so finally the left one, it is the axis, that is from O1 dash to O dash, draw an axis. Guys, thank you all. Thank you for watching the video, and share it to maximum students so that they can be benefited. Thank you all. Okay, we see another problem in hexagonal prism. So you can see that we have to construct an hexagonal prism dimension 25. So hexagon of dimension 25, axis length 50 mm. So rests on HP on one of its edges of the base. So we have to construct an hexagon with respect to the base edge on the right hand side. Draw the projections of the prism when the axis is here. So when the axis is inclined to HP at 45 and VP 30. So when the axis is given means it is an beta angle problem. Okay. So first we're going to construct an XY line. This is VP, HP and Y. So we have to construct an hexagon here with respect to edge. Dimension 25. Okay. So it is 60. So now can take a dimension of 25 and we have to cut the arc. So this 25. Okay. Again can keep the protector here. Mark for again 60 degree. So here also mark for 60 degree. So here also we have to cut 25. Already we have cut it. Okay, so we have to join this. Okay. So we can write the notations now. A, B, C, D, E, F. Okay, bottom face notation B1, C1, D1, E1, F1. To find out the center of the axis, we will draw thin lines. Okay, thin lines, thin diagonal lines we will be drawing. Okay. So exactly at the center we have O and O1. Okay, now projecting this. So axis length is 50. So here so for the top face notations we'll write A dash, B dash, C dash, this is F dash, E dash and D dash not visible. Okay, similarly A1 dash visible, B1 dash visible, C1 dash visible, but F1 dash, E1 dash, D1 dash not visible, O1 dash, O dash also not visible. So now we will go for the base edge inclinations, that is 90 minus inclination to HPT is 45. So 45, that is we get 45 here. Okay, so here we have C1 dash and D1 dash. So we will keep the protector here, mark for 45 degree. Okay. First arc, second arc. Okay, so we can write this is our A1 dash, F1 dash, this is B1 dash and E1 dash, this is O1 dash. So these vertical lines are exactly perpendicular to this, so we can mark it. Taking a reference of this, we will be marking at 90 degree. Okay. now drawing a line of length 50 mm. So now we can join this. Okay, so I can write A dash, dash, this is B dash and E dash, this is C dash and D dash, and this is O dash. So by extending this, okay, here we can show an axis. So if you measure the exact angle, you will get it here. It is exactly 45. Okay, 45 degrees. So now by projecting downward, so by projecting the lines from both sides, first we'll write the notations. Okay, so here, so this is A, this is B, this is C, this is D, this is E, this is F, and at this point we have left. This point it is O. Similarly for the this is for the bottom face, right? A1, B1, C1, D1, E1, F1 and O1. Similarly for the top face also we can write. Okay, so this is A, B, C, D, E, F. Okay, this point is O. Okay, we know how to construct the second position top view. That is, first we have to construct an outer boundary line here. Okay, first we have to construct outer boundary line. This is connecting here, and this outer boundary line it is done. Now visible space, as it is looking from the top view, we are able to see this face and this. Okay, so the top hexagonal face it is visible. So we write the hexagon here. Okay, and this rectangular face also visible from the top view. F1 and A1 visible from the top view, but this base of the hexagon not visible from the top view. So part of it is written with the dashed line. Okay, and then this rectangular face C dash, D dash and C1 dash, this rectangular face also not visible, so we can show part of it here. Okay, and we can show an axis here, so this is an axis line. Okay, so now, so this is an angle of inclination to VP, it is 30 degree, but So this problem, it is an beta angle. Okay, so here we have, this is having 50 mm, right? So this is your first axis length, and this length, okay, from O1 to O, this is your second axis length. Okay, considering these two axis length 1 and 2, we can, so 1 and 2 we can done the third position. So herein we will take here the axis line here. So this is mark reference point, then marking reference point, we'll be marking at this 30-degree angle line. Okay, so axis line it is drawn, it is 30 degree. So what is the procedure is, first we have to take this 50 mm axis length. Okay, you can extend this. First I will take a reference point of O, and I'll be measuring this axis length first, that is 50 mm, measuring 50 mm. And cut the arc. So this point it is O2. So after drawing this point, you have to draw an locus line here. Okay. Then after that, you have to cut the arc from this, from O to O1. And the arc. So this is O1. So now you join this an axis, and then extend and find out the beta angle. So here for this we are getting an beta angle of around 50 degree. Okay, now we have to transfer the diagram. Okay, this diagram here. So here you can see that we have 2 points O and O1. Using these 2 points, we have to construct the rest of the diagram. So here we have this O point. So I can construct this from this O and O1. You see that O and O1. So I'll be constructing the rest of the diagram. So from this O point, O to F and O to A, these 2 points are same. We'll be cutting 2 arcs. Okay. Then I'm cutting from this O1 point to F, O to F and O1 to F. Okay. So this point it is F and this is A. Similarly, you can cut this O to E and O to B. You can see that these 2 lengths are same. Okay, so from this point only you can cut it. We have 2 points. Okay, F to E and A to B. See, this is B. Again we can cut this O to D and O to C. Okay, now reverse it, F to D and B to C. This point it is D and this point it is C. Similarly, we have to construct this one from O to D and O to C1, O1 to D1 and O1 to C1. Okay, and from here again reverse it is O1 to D1 and O1 to C1. So this point it is D1 this it is C1. Now O1 to E1. Okay, now from D to E1, this is E1 and B1. Again from O1 to F1 and O1 to E1. Okay, now from here E1 to F1. Okay, then B1 to E1. So this is F1 and this is E1. Now, so we have to join this. Okay, then from these two hexagons, first we complete these two hexagons, then we'll join vertical edges. Okay, so now we have to finish the final position. To construct the final position, here we have to consider two nearest point. Okay, so before that, first we construct this final notation, this one and this one, top face of this front view, top face of this. Okay, first horizontal line projections. Okay, now we will do one by one. So till here, so this point it is A dash. Now here we have, so this point is B dash, and similarly we have this point, and this point it is C dash. Okay, C dash, and D point it is this is D dash, D dash, and we have this point is F dash, and exactly the center we have this point, this is O dash. Similarly for the bottom face also we do it. Okay, so this point is E1 dash, B1 dash, C1 dash, D1 dash, point is E1 dash, and this point it is F1 dash, and we have this point, it is O1 dash. Okay, so herein you can see that the nearest edges are E and D. So I will write here nearest 2 points to x5. Okay, so that is E and D. So E point, you can see that is near connected to E to D and E to F. Okay, and then E to E1. Okay, E to E1. Similarly, we have D. D is connected with E, D is connected with C. Okay, and D is connected with D1. So these are the dashed lines. Okay, first we are going to complete the dashed lines here. Okay, E to D, and that is E dash to D dash. Okay, and then E to F, you can see that. Okay, E to F. And then E to E1, E to E1. Okay, now we have D2 is done, D to C. Okay, now D to D1. Okay, so these are the dashed lines done. Now we will complete the base of the hexagon. Okay, so in this base also we'll complete it. Okay. Okay, now from A dash to A1 dash, and then from B1 dash to B1 dash. Okay, now finally we have axis. Okay, so this is how we complete the problem. Today we are going to start a new problem on a square pyramid. So you can see the problem. So you have to construct a square pyramid of dimension 35, base 8 dimension, 65 mm axis length. Okay, rests on HP on one of its edges of the base. That means we need to construct a square with respect to the edge here. Okay, so first we are going to draw an XY line here. Okay, square of dimension 35, you have to 35 means 3.5 box here. Okay, so here in the slant edges will be thick lines. Okay, because these are slant edges. Okay. So I can write A, B, C, D, O and O1. So I can show the dimensions here on one side. So it is 35. Okay, now projecting okay, here axis length is 65. Okay, 65. Take here 65 using the scale. here. Okay, the front view of a in pyramid, it is a triangle, you know it. Okay, so here B dash visible, A dash not visible, C dash visible, D dash not visible, O1 dash in bracket, and O dash. So here we'll take base edge inclinations. It is 90 minus angle of inclination to HP, it is 45. You can see that. So that is 45 degree. Okay, here take a reference point of C dash and D dash. So using protractor, we want to mark 45 degree. So here angle line. So now using compass, we have to measure this length from C dash to B dash. The first arc, second arc from C dash to O dash. Okay. So you can write here B dash and O dash. This is O1 dash. Okay. Now using compass, second arc from C dash to O dash. So you can join it. Okay, so we have to join here. Okay, so this point we need to join. Okay, and we have this axis, so we have to draw an axis here. So by extending this axis, if you measure the angle, so that will be exactly 45 degree. Okay, so this is O dash. Okay, now projecting the lines vertically downward. B, C, D, 1, O. So first we construct outer boundary line. C to O to D and D to E. So this forms an outer boundary line. Now here triangular face B dash, A dash, O dash, triangular face visible from the top. Okay. So it is visible. Okay. Now we can see that this square base not visible from the top. So that's why it is a dashed line. Okay. Then finally we have an axis. So I can show it. Now angle of inclination to VP is 30 degree. I'll draw a parallel line here. Take a reference point. Here I will mark 30 degree. Okay. 30 degree. So this is what the resting is, not visible from the top. We'll take this. Okay, so for the angle line we are going to draw the angle of inclination line here. Okay, it will be convenient. Cut D point. So this is C. Okay, now from C to B, and D to A. Next street is reverse. At this point it is boven. From D to O. This is O. Okay, now we'll join these lines. So this is dashed line. Okay, and finally we have an axis. Okay, now projecting the lines to construct the final position. Okay. This is O dash. B dash. This point it is C dash, and D dash we have this D dash, and finally we have this O dash. Okay, the concept for constructing the final position in the pyramid is, first we have to construct the base, that is here in the base it is in square. So first we are constructing a square here. Okay, then we draw the slant edges. Say first slant edge I am drawing from A dash to O dash, next from B dash to O dash, third from C dash to O dash. You can see that with respect to this base, if the slant edge is passing inside of it, inside of this square, the base, we can say that that will be n dashed line. Okay. Yeah, the dashed line. And finally we have an axis. So this is how we complete the problem. Today we do another problem in pentagonal pyramid. So the problem number, it is 23 in Caed solution book. So in this problem they have given pentagonal pyramid dimension 25 and axis length 50, rest on HP and one of its corners of the base. That means the first position starts from the corner on the right hand side, and then you see that draw the projections of the pyramid here. When the axis of the pyramid, it is inclined to HP at 40 degree and to VP at 30 degree. So angle of inclination, it is there with the axis for both HP and VP. Then it is an beta angle problem. Okay, it's an beta angle problem. So first we construct an XY line here. First we construct an XY line here. VP, HP. Alright. So pentagon we have to construct dimension 25. The angle we have to construct 72 degrees. Okay, 72 degrees. So I'll be drawing a line of length to this. Also. So now using compass. Join it. Okay. So pentagon it is constructed. Now perpendicular bisectors we have to do. So for that we will be marking exactly the middle points of all the edges. Okay. So after this these edges. Okay, you have to keep only the slant edges here. Okay. Keep only the slant edges here. So marking is A, B, C, D, E. This is O and O1. So now we'll project it front view. So for the front view they have given dimension of 50. Okay. For the axis line. So A dash in the B dash, C dash, E dash in the so 1 dash, this is G dash. Okay. So now second angle of inclination it is 40 degree. So we will go to base edge inclinations. That is 90 minus angle of inclination to HP, that is 40. So we will get 50 degree. So I will take first a reference point of here, D dash, marking it 50 degree. Using compass. Start. Second arc. order. Okay, so we will give the name is 1 dash C dash and D dash. Okay, so we are going to erase this part using compass from T dash to O dash first arc. Okay. Second from this B dash to this. So now I have to join it. So there is an axis here. And a straight line. Okay, so we are going to extend this axis, and we can show the angle here hitting exactly 40 degrees. So projecting downward, okay, O dash. We can write the meanings here. A, B, and this we have 1. C point is this. This is D. This is E. And this point is O. Okay, so D is not visible. So first we construct an outer boundary line. Okay. Boundary line. Now the triangular face, this A dash, B dash, O dash, visible from the top view. It is triangular face. So A, B, O, it is visible from the top view. Okay. Now this is pentagonal base, not visible from the top view. So part of it we are going to show with the dashed line. Okay. Then we have finally from to here part of the axis, so I can show. So this is a bit angle problem. The first axis line we have to use this, and second axis line we have to use this. So how much we are getting this? This is around 40 mm. Okay, 40. So now it is in beta angle problem. First, so I can take here, draw a line, and here reference point. Angle of inclination, that is 30 degree. First reference point I will take, that is O, measuring 50 mm. Is O2, then draw an focus line. Again we measure from O1. This is 1. So we will get the angle between here. So we are getting an angle of 41 degree. Okay. So now we have to copy the diagram. So this diagram we have to copy here. Look at this diagram. So we have 2 points here. You can see that on the same point, then we have O1 to D. Next one here, O to B and O to C. Next from this D to this point we have this point we have B, this is B. So we are going to join it. From here to here, this is dashed line. So we are going to show with the dashed line only here. Okay. Now we have to project it upward. Dash. Dash, and finally we have this is dash. One dash. So how to construct the final position? First we construct the base of the pyramid, right? That is base. Here we have pentagon. So pentagon we will be constructing. Okay. Now we have to construct the slant edges. With the slant edges passing outside, that will be continuous lines. You see that from B dash to O dash, C dash to O dash. Okay, you can see from here, from E dash it is passing inside. That's a dashed line. Similarly from this D dash also. So it is passing inside of it. That's why dashed line. Finally we have an axis. So we can show an axis. So this completes the problem. We see a different type of problem in pyramids, that is slant edge and slant triangular face. Okay, in this type of problem they will be not mentioning second angle of inclination, that is inclination to HP, they will be not given. Instead of that they will be mentioning slant edge, resting on the slant edge and slant triangular face. In this problem another thing is that they also don't mention the first position also. So how to identify the first position? If they mention slant edge, means the first position will be starts from the corner. Okay, if they mention slant triangular face, means your first position starts from the edge. Okay, base edge. So this is how you have to identify in the slant edge and slant triangular face. remember they will be not mentioning second angle of inclination to HP. Instead of that, they will be telling resting on the slant edge or slant triangular face. And they are not mentioning the first position also, it is resting with the base edge or base corner. So we have to identify from these words. Say slant edge means first position starts from the corner, slant triangular face means first position starts from the edge. Okay, so problem number 24 from CAD solution book. So in this problem, it is a problem from projection of solids. You can see in this problem what they have given: hexagonal pyramid of dimension 25. Sides of base 50 mm axis length they mentioned, rest on HP and one of its corners of the base. So first position start from the corner, okay, with respect to the right side. So is the two base edges. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and appears to be. You can see that if they are given appears to be means no beta angle. Okay, no need to find out the beta. Now we are proceeding with the solution. So first I am going to construct XY line. Then after that I am going to construct VP, HP and Y. Here you can extend this. So here first position starts from the corner. So dimension 25. So I have to mark it 60 degree. So we have to mark it 60 degree here. I am drawing a line of length 25. Okay. Again we have to mark at angle 60 degree. Again drawing a line of length 20, so 24. So again we have to degree. And drawing a line of length here. Now finally, so we can join. Okay. So we can show the dimension on one side. Give the naming A, B, C, D, E, F. Now drawing the slant edges, here inside lines has to be thick lines, okay? Inside lines has to be thick lines in case of pyramids. So remember it. So in case of prism, we are drawing the thin lines to find out the center of the axis. Okay. This is O and O1. Now projecting the lines. Okay. So from here we have to draw an axis of length 50. dash, B dash, and F dash. This is O1 dash, C dash, and E dash, and D dash, and this is O dash. Now first we are going to take E dash here. So here we write base edge inclination. Okay, so base edge inclination, it is 90 degree minus angle of inclination to HP given 40 degree. So 90 minus 40 means it is 50 degree. So we have to incline this at an angle of 50 degree. Okay. First star, vertical, second arc, third arc, fourth arc. So now I have to write the namings: A dash, C dash, F dash, Z1 dash, C dash, B dash. Okay. Now measuring from here, so if you measure this angle, you have to get exactly 40 degree. So this length we have 50 mm. Okay. So this is O dash. Now projecting downward, so we have to construct an outer boundary line first. Okay, outer boundary line. So first we have to construct the outer boundary line here. Okay, now these edges are visible. Okay, F2 is also visible and this also visible from top view, but this base, it is not visible, so that's why it is written with the part of it is written with the dashed line. Okay. Again from D dash to O dash, that is also not visible, so dashed line. And then A to O, that is also visible. You can see that A dash to O dash also visible. Now take a reference point. So angle of inclination to BP 45 degree. Take that. 45 degree. So appears to be problem, no need to find out theta angle. So first is the O point. Now measuring from O to F. First measuring from O to O1. Okay, measuring from O to O1. Next measuring from O to D. So these points we are getting is D. So D point is not visible. This is O1 and this is G. Okay, we have 3 points here. G to F. Okay. Then reverse it is from here G to you can see this length also same. It is from D to E. So we can join S, E, B, C. So now we write the final position. Okay.
Tilak, Sumut, Harish ಬಂದಿಲ್ವಾ? Harish DNA submission ಯಾವಾಗ? 23rd ಇವತ್ತು, 26th is the last date. ಇವತ್ತೆಲ್ಲ ಕಂಪ್ಲೀಟ್, you take all this coordination of that and complete, make it ready, you have to get it the signature from the principal and your hತ್ರ.
Chairman or secretary ಅಂತ
ಅದನ್ನೇ ಅದು ಹಾಕ್ಸಿ ನಾನು ಫಸ್ಟ್ ಯು ಟೇಕ್ ದ ಪ್ರಿಂಟ್ ಔಟ್ ಆಫ್ ದಟ್ ಪ್ರಿಂಟ್ ಔಟ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಏನೇನು ಕಂಪ್ಯೂಟರ್ ಆಗಿದೆ ಅದು ತೊಗೊಂಡ್ಬಿಟ್ಟು ಎಸ್ ಅಂದ್ರೆ ಇನ್ನು ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕಲ್ಲ ಸಿಗ್ನೇಚರ್ ಅದನ್ನ ಅಕೌಂಟ್ ಸೆಕ್ಷನ್ ಸೈನ್ 25%. ಅದೇ 25% ಕಾಲೇಜಿಂದ ಹಾಕಬೇಕು, ಸ್ಯಾಂಕ್ಷನ್ ಆಗುತ್ತೆ ಅಂತ. ಈಗ 25 ಲಕ್ಷ ಸ್ಯಾಂಕ್ಷನ್ ಕೊಡ್ತಾರೆ ಕಾಲೇಜಿಂದ, 25 ಅಂದ್ರೆ 25 ಕೊಡ್ತಾರೆ ಅಷ್ಟೇ. So you all of you should be ready because there is no time. ಇವತ್ತು 23 ಇವತ್ತು ನಾಳೆ ಒಳಗಡೆ ಸಬ್ಮಿಟ್ ಆಗ್ಬಿಡಬೇಕು ಅಷ್ಟೇ. ಆಗಿದೆ ಸರ್, ಅದು ಚೆಕ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡ್ತಾರೆ. PPT ಮಾಡಬೇಕು, ನಿಮ್ದು PPT ಮಾಡಬೇಕು. ಇವ್ರು ಬೇಕಾಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಇವ್ರು PPT ಕೊಟ್ಟಿದ್ದಾರೆ. PPT ಇನ್ ದ ಸೆನ್ಸ್ ಏನಾಗಿದೆ ಅದೇ ಸೇಮ್ ಥಿಂಗ್, ನೀವು ಏನು ಮಾಡಿದ್ರೆ ಅದೇ ಸ್ವಲ್ಪ ಹೇಳಬೇಕು, ಈ ಥರ ಮಾಡಿದ್ದೀವಿ ಸರ್. ಪ್ರಿನ್ಸಿಪಲ್ ಎಸ್ ಅಂದ್ರೆ ಇಲ್ಲ ಅಂತ ಅದು ಇಲ್ಲ. Just you have the responsibility for this one. You have to take care of the dividend. They have to complete by today and tomorrow. ಇವತ್ತು ನೀವು ಹಾರ್ಡ್ ಕಾಪಿ ನನಗೆ ಅಲ್ಲಿ ಹೋಗಿ ಸೈನ್ ಮಾಡಿಸ್ಕೊಬೇಕು. ಸೈನ್ ಮಾಡಿ ಪ್ರಿಂಟ್ ಬೇಕಲ್ವಾ?
This completes the problem. You can like the video, subscribe for the channel and hit on the bell icon. So now we are going to discuss problem number 31 in Caed solution book, question bank solution book. So this problem we are starting with the slant edge. Okay, you can see in this problem we have to construct a square pyramid of dimension 35 and axis length 50. So rests on HP and one of its slant edges. As I mentioned, if they given slant edge means our first position starts from the corner. Okay, first position starts from the corner here. Here first position starts from the corner here. Draw the projections of the pyramid when the axis, you can see when the axis is given, and they are also mentioned appears to be. So if they mention appears to be, no need to find out the beta angle. Okay, appears to be, if they given means no beta angle. Okay, no beta angle. So here in we have to construct a square of dimension 35 with respect to corner. Here slanted means for corner we have to start. Okay, first I'm going to write an XY line. Okay, so VP HP. So first I'm going to take a reference point here, somewhere here I will take. Okay, here I will take reference point and I'm going to mark 45 degree on both sides. Okay, 45 degree, and here also 45 degree. So I'm going to draw a line of length 35 from this end. Okay. So 30, 35, here I will end. Similarly here also. Okay, so it is done. So now using compass, measuring 35. So we are going to cut the arc. So it is around here getting. Okay. So we can give the name A, B, C and D. So we will write the slant edges here. Slant edges we have drawn O1, and we can show, we have to show the dimensions here. So now project it upward to complete the front view. So front view axis length we have, it is 50. So A dash, B dash, C dash, or D dash not visible, O1 dash also not visible, O dash also not. So in this problem we have to make it this resting on the, this is our slant edge, we have to make it this slant edge resting on this XY line. Okay, that's what the problem here. C dash, from C dash to O dash you can cut the arc. Dash again from C dash to A dash. So we are going to cut the arc. Then again from this O dash to A dash. Okay. So we are going to join this. This is A dash. also here. So now we'll project it downward. So you can write the names. This is A, B, C, this is D, this is O1, and this is O. First we construct the outer boundary line. This top face, it is visible, okay, square, it is visible from the top view. Sorry, this is B dash and this is C dash, this is C dash. Okay, this see that this slanted edge, it is visible from the top view, so it is continuous A to O, but from this C dash it is not visible. Part of the we are showing the dash line. Okay, so it is on now, it is appears to be, so appears to be means no beta angle, so replace it, take a reference point here, and here we have 55 degree. So first I will take reference point of O here, next from O to C we have to do. We go to C. I see this from C to O1. Then O1 to E1. In the same line we are having it. This is O1 and this is A. Now putting the arc. This is D, this is B. Now we can join it. Part of the dash line you can show here. So now final position, dash, finally we have one dash. First we construct the same concept and pyramid. First we construct the base of the pyramid. Okay, no slant edges passing outside, and this also passing outside, and this also passing outside, but from here T dash to O dash is passing inside. That's why dash line, and finally we have axis. Okay, so this completes the problem. Another problem in from the Caed solution book, on the slant triangular face and the hexagonal pyramid. You see in the problem, hexagonal pyramid dimension 25 and 15 axis length given. That's on each on one of its slant triangular face. So slant triangular face means our first position starts from the base edge or the side. Okay, so draw the projections of the pyramid when the axis appears to be. So axis appears to be means no beta angle. Okay, so when the given appears to be means no beta angle. So here first we have to construct an hexagon with respect to edge here. So edge we have to construct hexagon with respect to edge. So 25 dimension. So marking at 60 degree. So 25 here again. So you have to mark it 60 degree. Again we have to mark 60 degree. So 25 and again here. So marking it 60 degree. Finally we have so constructed second A, B, C, D, E, F. Now the slant edges. Slant edges we have drawn. So here, so 25. Okay, it is O1 on the front view. So front view axis length we have 50. So naming dash not visible, B dash, C dash visible, F dash not visible, D dash visible, E dash not visible, O1 dash, O dash. So on the slant edges, so we have to mark D dash and E dash. So measuring the length from compass from D dash to O dash. From D dash to E dash. And again from the O dash to E dash. So join it. Dash, C dash, F dash. Okay. Now drawing the second position top view. writing annotations here. This is E, this is D. This point we have C, and this point is B, this is E, and this is F, and centrally this one O1, and this is O. So first we are constructing an outer boundary line. So outer boundary line is on hexagonal face, it is visible from the top view. So actually this is connect here. This part, and this is D. Okay. So and this triangle of is A dash, B dash, O dash visible from the top view. So it is a continuous triangular face. Okay, this bottom face, you see that this bottom triangular face E dash, D dash, O dash not visible, so that's why it is written with the dashed line. Okay. And finally we have an axis. We will show an axis. So no bit angle here. So because appears to be, they have mentioned angle of inclination to VP is 45 degree. So take a reference point of O. Next from O to O1. So we can cut the arc. This is O1. Now using from O to A, exactly the same length. So here we have to cut first arc, second arc. Next from O1 to A and O1 to B. So this is A and this is B. Okay. Now we have F. Constructing hexagon. So here from this point we have dashed line. So final position we have to do this is O dash. We have A dash here. Small A dash. This is A dash, B dash. C dash. This is 1 dash. So first we are going to construct a hexagonal base here for the pyramids. Slanted this. Okay, here two slant edges from F dash to O dash. It is passing inside, and from here A dash to O dash also passing inside. Finally we have axis, so we can show the axis. So this completes the problem. Okay, today we are going to start problem number 43 from Caed solution book. Okay, it's a cube problem. So the dimension is given 40 mm side, rest on HP on an edge. So which is inclined to VP at 30 degree. Draw the projection with the lateral square face containing the edge on which it rests makes an angle of 50 degree. First we have to construct a square of dimension 40. Okay, we will draw thin lines here to connect the center of the axis. Here is the naming A, B, C, D, top face, A1, B1, C1, D1, O, O1. Front view we getting this, front view also 40 mm. B dash, A dash in bracket, C dash, D dash in bracket. Similarly A1 dash, B1 dash, C1 dash and D1 dash, E1 dash, and this is O dash. Lateral square face containing 58 means we have to do base edge inclination here. Base edge inclination is equal to 90 minus 40, that is 40 degree. So here can take a reference point of C1 dash and D1 dash. Here marking at an angle of 50 degree. measuring the length from here to here. Cut the arc. This is A1 dash, B1 dash. So this is O1 dash. Okay. Now we will be marking at 90 degrees. So we have to draw a line of length 30 here, 540. So we can join here. So B dash, A dash, this is O dash, C dash, and D dash. So if we extend the axis, find out the angle of inclination here exactly 50 degree. Okay. So now projecting downward, so we can write here this is V1, B1, C1, D1, this is O1. Similarly we have this is A, this is B, this is C, this is D, and this is O. So first we construct an outer boundary line here. Outer boundary line we are constructing. This top face, it is visible, ABCD top face. Okay, the bottom face here it is C1 and D1 not visible from the top face. That's why D1 and C1 it is in bracket. And finally we have an axis, so we are showing it. Now inclination to VP here 30 degree. So take a reference point here, mark for 30 degree. You have to take this reference point of D1. From D1 to C1, cut the arc. So this is dashed line. We'll be showing with the dashed line. Okay. So now, to these points, I will be marking it exactly 90 degrees on either side. So now we are going to cut the arc. Can join it. So this is A, B, this is A1, B1. So this is D, this is C. This is O1 and this is 1. So this remaining thing we are going to rub it. D dash, this is C dash. O dash. Finally, the bottom face. This is 1 dash and this is B1 dash. B1 dash, this is D1 dash and this is C1 dash. So okay, we take a nearest point. So nearest point equivalent is D here. So D connected with C, D is connected with A, D is connected with D1. So these are the dashed lines. Okay, so understood, right? So from D to C, that is from D dash to dashed line, then D dash to A dash dashed line, then D dash to D1 dash dashed line. So remaining diagram. This completes the problem, and finally we have an axis. Okay, so this completes the problem. So we can like the video, subscribe, and press on the bell icon. Problem from the CAD solution book. So the problem was, it is on hexahedron. So hexahedron, it is nothing but a cube. Hexa means 6, hedron means faces. So 6 equal faces we can find only in the cube. Okay, so it is a cube of dimension 30 mm resting on one of its corners. So first position starts from the corner and here you can see one of the solid diagonals, so we have to make use of the solid diagonals, so which is there in the cube, so is perpendicular to VP. Okay, perpendicular to VP. So that means when they have mentioned the third position, and in the second position we are going to make it parallel to VP and then perpendicular to VP. Second position parallel to VP, third position perpendicular to VP. So now we will see the problem. So now we have to construct a square of dimension 30 here. So for that, first I will take a reference point here. Reference point of 145 degree marking. Now I'm drawing a line of length 30. Okay, here also. So 30 is encompass. Okay. And we can join here. So this is A1, B, B1, C, C1, D, D1. So inside lines will be thin lines because it is an prism. Okay. It is 1. So so it is 30 here also. Okay, so dimensions I can show on one side here. So dimension we have 30, and here also it is 30. Okay, we write the notations here. A dash visible, B dash visible, C dash visible, but D dash not visible. Okay, same case A1 dash, B1 dash, B1 dash not visible, C1 dash, and here O1 dash and O dash. So now I'm drawing in solid diagonal. Okay, so I'm going to check this angle, how much it is. I want to make it parallel, right? So for that I'm going to check this angle. It is exactly 35 degree. Okay. So 35 degree I'm taking here. Reference of here A1 dash. Okay, and here exactly I'm marking at 35 degree and drawing a line of length. With my compass I have to do so this is C1 dash and this one we have this point P1 dash and T1 dash. This is O1 dash. Now marking at 90 degree. Now straight pin you have to draw. It's 30. Yeah, 30. Here also we have 30. Okay. You can see that here dash right line. This is A dash, B dash, and D dash in bracket, C dash, and O dash. Now projecting the lines vertically downward. So we can write E, this is B, this is C, and D. Same case here. So we can write this is E1, B1, C1, C1, and here we have O, and this point O. Now we construct outer boundary line first. So you can see that the top face, it is visible from the top view. So that means this at C dash and C1 dash, it is visible. Now the bottom face, it is not visible from the top view. Okay. Okay, so this is we have done, and part of the axis I'm showing here. Now, so this is a solid diagonal which is now parallel to VP. I'll make it perpendicular to VP. How to do that? Take reference of C1 now here. Now measuring from this length. So I'm going to cut dark. So here I'm going to draw a straight line. Okay. Now I'm cutting the arcs. Okay, so this point we have C and O1, this is O and A1, and this is A. Now using compass we have to construct the squares here. Same thing here also. So we are going to join it. Pull up the dashed line. Now final position. So we are going to do this is C1 dash. So namings we have to write this is D1, this is D, this is B. Okay. Now projecting this D1 here. This is B1, D1 dash, B1 dash, and this point here B1 dash, and this is O1 dash. C dash, B dash, C C dash and C and B dash C dash. Okay, nearest point x value it is C1. Okay, C1 it is connected with D1, C1 connected with B1, C1 connected with C. Okay, so these are the dashed lines. That is from C1 to C1 dash to D1 dash, C1 dash to D1 dash, C2. Okay, C dash line. Now remaining lines will be written with the continuous lines. So this completes the problem. So you can like the video, subscribe, and press on the bell icon for the new upcoming videos on the solid edge. Problem from the CAD solution book, that is problem number 45. So it is a cone problem. So for the cone they have given 50 mm base diameter and axis length 60, and it is resting on one of its generators, like slanted and slant triangular face problem. And then draw its projections when the axis, so they have given angle of inclination to axis means, so it is an beta angle problem. So what we have to do in this problem is, first we have to construct a line, okay, and then you have to draw a circle and divide that circle into 8 equal parts. Okay, so first we have to draw an XY line. Okay, VP, HP, Y. Now we take a compass, and here, so diameter 50 means you have to take a radius of 25. Okay, radius of 25, take it, draw a circle of diameter 40. Now we are going to divide this circle into 8 equal parts. So now it is divided into 4 parts, right? So to divide into 8 equal part, so mark at 45 degree here and 45 degree here. Okay, I can extend it. Show the dimensions on one side. So it is 50. Okay, now projecting it. So the axis length we have 60. So these lines has to be thin lines, okay. So now write down the notations. A dash, B dash visible, H dash not visible, C dash, D dash not visible, D dash and F dash not visible, and E dash, and here O1 dash and O dash. So So the axis length we have here, it is 60 mm. Okay. So now it is resting on the generators. So take E dash, measure from E dash to O dash. Okay, measure it and then cut the arc. So this is O dash. Next point, it is measuring from E dash to E dash. Okay, here from here O dash to dash. This is E dash. Okay. So we have to cut the arcs here now. So the namings we can write B dash, H dash, and this is 1 dash, C dash, G dash, and this is we have D dash and F dash. So this is an axis. This is thin lines. Okay, now projecting downward, so we can complete the problem. So here we have E dash, and this point it is D dash, and this it is C dash, and this point we have B dash, this is A dash, and this is H dash, and this is G dash. This finally we have dash. Okay. So we will first we construct. So this point it is 1 dash. First we construct an ellipse. And finally we have an axis, so we will show an axis here. Okay, so now it is an beat angle problem. Okay, so mark at 30 degree. Marked. First I will take a reference point of O here, measuring the length of axis 60 here. This is O2. Again measuring from this length. This is 1. So this is the first axis length, and the second axis length we have to measure. Okay, for beta angle. Okay, now you have to join it. and find out the angle. Here we get it around 33 degree. Okay, now I'm going to extend this line. Okay, the same line we have O1 to A1. Okay, so this point we have is E. So this all written in E. Okay, so next thing it is cutting the arc. So we have this is F and this H, this is G, this is E. G, this is C. So okay, so it is done. So it is first one is O dash. O dash is O dash. C dash. We have E dash, F dash, G dash, H dash. Okay, finally we have O1 dash. Okay, okay, finally we have an axis. So this completes the problem. So like the video, share it, subscribe and press on the bell icon for the new upcoming videos. Do next problem. It is problem number 44 from Caed solution book. So this problem on a tetrahedron. We have to construct a tetrahedron of dimension 55, rest with one of its corners. Okay, such that an edge containing that corner is inclined to HP at 650 degree and VP at 30 degree. You can see that the same edge has been inclined with respect to both HP and VP. as it is same as that of your beta angle, wherein we find the axis has been inclined to both HP and VP. Here the same edge has been inclined to HP and VP, so that's why this is also an beta angle problem. Okay, beta angle problem, because the same edge has been inclined for both HP and VP. Okay, now we will construct. So dimension 55 you have to take. So dimension 55, taking from compass. Okay, so now we have to draw the medians here. So now we are going to erase these edges. Okay. So we constructed a tetrahedron of dimension 55. Okay. Given ABC, O1. Okay. Projection line. Now here in the question they have not mentioned the axis line, just we draw a straight line. So the procedure here, we have to consider 55 mm length. Okay, 55 length from this side. This is the end OC, it is parallel. From the parallel end side we have to cut an arc here. Okay, from this end parallel end we have to cut the arc, then join it. So here naming C dash in bracket, B dash, C dash, O1 dash, O dash. Now second angle of inclination, it is there with the edge containing. This is the edge which is containing the corner. That means we have to incline this at an angle of 50 degree. So I'll be taking the reference of here A dash, and here I'll be marking at an angle of 50 degree.
ये मंथ का जो एग्ज़ाम ड्यूटी है वो आपके पास लिस्ट है क्या, फोटो लिए हैं क्या?
बाद में भेज दो वीडियो। So we have to cut an arc here. Okay, so this is C dash from here to here. So this is O dash from here to here. So we have to cut the arcs here. This is O1 dash. This is A dash and B dash. Okay, so here this is having an angle of 50 degree. Now project it downward. Okay, so this point here be A, this is B, this is C, this is O1 and this is O. First we construct an outer boundary line here, B to O, then O to B. Okay, so this forms an outer boundary line. Now AB mode is done. You can see this base of this tetrahedron not visible from the top view, so that's why dashed line. In part of the axis, so we can show here. Okay, now so this length, it is 55, right? This first length, and this is, we have second length. Taking these two, we have to move the beta angle. So angle of inclination, it is 30 degree. The first point we have to take measuring from here O to C. So this is C2. Draw the locus. Then measuring from O to C. So in this problem we have to consider the edge length. You can see that C to O and O to C. These two lengths I am considering. Okay. Join this. And extend. So the angle will be cutting around here. It is 50, 51, 52 degree you get. Okay. So this is what the beta angle. Now we have to transfer the diagram here. Measuring from C to O1. This is O1, this is C. Now using compass, C to A. The next O to A. So this point it is A and this point it is B. Okay, now we can join it. Okay, so now extend it to complete the final diagram. So it is O dash, and here we have C dash, O dash, B dash and this one over here. One dash. So the concept here is we have to construct the base of the tetrahedron. The base of the tetrahedron is a triangle. So first we are going to construct that. Okay. So now the slant edges from C dash to O dash is continuous line. From B to also continuous line, but from A to O it is passing inside. That's why it is dashed line. And then finally we have an axis. Okay, so this completes the problem. So you can like the video, subscribe and press on the bell icon. Problem number 50 from Caed solution book. So in this problem they have given a cone with base diameter 40 and axis length 50, resting on HP and a point on the circumference of its base such that its apex is at a 40 mm above HP. So they have not mentioned angle of inclination to HP. Instead of that, they are telling its apex is at a distance of 40 mm above HP, and the top view of the axis inclined at 60 degree. You can see that they have mentioned here top view. That means no beta angle. So we have to proceed with the solution here. Here we have a circle, diameter 40 means, so we have to consider 20 here. So we have to divide the circle into 8 equal parts. Marking at 40, 43 and here 35 degree. Axis length of 50 here. This is around this and orange. It is 50. Now here 40 mm vertical length we have to take. So first here we have to take B dash, measuring from compass, we have to calculate. Dash. We're going to extend downward. Okay, now we have to write the notations here. This point is B and this point is C. This is D, E, F, this is H, this is O, so I have to draw an ellipse here. Marking at 60 degree. This reference point of 4 and measuring from we have V, O1 and U. What is it is? And positions. So this completes the problem. Okay, today we are going to start problem number 43 from Caed solution book. Okay, it's a cube problem. So the dimension is given 40 mm side, rest one is on an edge. So which is inclined to VP at 30 degree. Draw the projection with the lateral square face containing the edge on which it rests makes an angle of 50 degree. First we have to construct a square of dimension 40. Okay, we will draw thin lines here to connect the center of the axis. Here is the naming A, B, C, D, top face, A1, B1, C1, D1, O, O1. Front view we getting this, front view also 40 mm. B dash, A dash in bracket, C dash, D dash in bracket. Similarly A1 dash, B1 dash, C1 dash and D1 dash, E1 dash, and this is O dash. Lateral square face containing 58 means we have to do base edge inclination here. Base edge inclination is equal to 90 minus 40, that is 40 degree. So here can take a reference point of C1 dash and D1 dash. Here marking at an angle of 50 degree. Measuring the length from here to here. Cut the arc. This is A1 dash, B1 dash. So this is O1 dash. Okay. Now we will be marking at 90 degrees. So we have to draw a line of length 30 here, 540. So we can join here. So B dash, A dash, this is O dash, C dash, and D dash. So if we extend the axis, find out the angle of inclination here exactly 50 degree. Okay. So now projecting downward, so we can write here this is E1, B1, C1, D1, this is O1. Similarly we have this is A, this is B, this is C, this is D, and this is O. So first we construct an outer boundary line here. Outer boundary line we are constructing. This top face, it is visible, ABCD top face. Okay, in the bottom face here it is C1 and D1 not visible from the top view, so that's why D1 and C1 it is in bracket. And finally we have an axis, so we are showing it. Now inclination to VP here 30 degree. So take a reference point here, mark for 30 degree. You have to take this reference point of D1. From D1 to C1, cut the arc. So this is dashed line. We'll be showing with the dashed line. Okay. So now, suppose these points, I will be marking it exactly 90 degrees on either side. So now we are going to cut the arc. So we can join it. So this is A, B, this is A1, B1, so this is D, this is C. this is V. So this remaining thing we are going to rub it. D dash, this is C dash. O dash. Okay, finally the bottom face. This is 1 dash and this is we have B1 dash, B1 dash, this is D1 dash and this is C1 dash. So okay, we take a nearest point. So nearest point equivalent is D here. So D connected with C, D is connected with A, D is connected with D1. So these are the dashed lines. Okay, so understood, right? So from D to C, that is from D dash to C dash dashed line, then D dash to D dash dashed line, then D dash to D1 dash dashed line. So remaining diagram. So this completes the problem, and finally we have an axis. Okay, so this completes the problem. So we can like the video, subscribe, and press on the bell icon. Problem from the Caed solution book. So the problem was, it is on hexahedron. So hexahedron, it is nothing but a cube. Hexa means 6, hedron means faces. So 6 equal faces we can find only in the cube. Okay, so it is a cube of dimension 30 mm resting on one of its corners. So first position starts from the corner, and here you can see one of the solid diagonals. So we have to make use of the solid diagonals, so which is there in the cube. So is perpendicular to VP. Okay, perpendicular to VP. So that means they have mentioned the third position, and in the second position we are going to make it parallel to VP and then perpendicular to VP. Second position parallel to VP, third position perpendicular to VP. So now we will see the problem. So now we have to construct a square of dimension 30 here. So for that, first I will take a reference point here. Reference point of 145-degree marking. Now I'm drawing a line of length 30. Okay, here also. So 30 is in compass. Okay. and we can join here. So this is A1, B, B1, C, C1, D, D1. So inside lines will be thin lines because it is an prism. Okay. Prism 1. So okay. So it is 30 here also. Okay. So dimensions we can show on one side here. So dimension we have 30, and here also it is 30. Okay. We write the notations here. A dash visible, B dash visible, C dash visible, but D dash not visible. Okay. Same case A1 dash, B1 dash, B1 dash not visible, C1 dash in here, O1 dash and O dash. So now I'm drawing in solid diagonal. Okay. So I'm going to check this angle, how much it is. I want to make it parallel, right? So for that I'm going to check this angle. It is exactly 35 degree. Okay. So 35 degree I'm taking here. Reference of here A1 dash. Okay. And here exactly I'm marking at 35 degree and drawing a line of length. With my compass I have to do. Okay, so isometric projection means it is nothing but a projection of solid or combination of solid by inclining at an angle of 30 degree from any one of the reference points. Okay, so wherein we can see in isometric projection, so there will be 30 degree angle lines. So using those lines we are going to project. So it is nothing but a complete 3D picture of the solids or a combination of solids. Okay, by inclining them at an angle of 30 degree from any one of the reference points. So how do we construct the isometric projection? So here we have two methods. One is box method, one is 4 arc by center method. Using these two methods we are going to construct the isometric projection. And here in when any one of the solids given, right, so it will be having two distances. One is vertical height, another one is horizontal distances per given in any one of the solids. Okay, so vertical heights given in solid will be drawn vertically in the isoscale. Okay, vertically in the isoscale. So there is no change if the vertical heights were given. Okay, so that will be drawn vertically in isoscale. But if any of the distances were given horizontally, so the horizontal distance were drawn in the 30 degree inclined lines. So in the isoscale, so there are 30 degree inclined lines for the right. So in those lines we are going to draw the horizontal distances. Now we come to the sphere. Okay, sphere is the only solid which will be drawn with the actual scale here. Okay, because except sphere, all the solids will be drawn with the isoscale. So in sphere, what happens exactly here? If we are going to tilt a sphere at whatever the angle, 30 degree, 40 degree or 50 degree, we will get the same circular weave here, the top weave, front weave. Okay, so by inclining at whatever the angle, 30 degree, 45, 60 degree, we will get the same weave. That's why the sphere will be drawn with the actual scale. Okay, so remember, so sphere will be drawn with the actual scale, except sphere all the solids were drawn with the isoscale in the isometric projection. Okay, today we are going to start about isometric projection. Okay, so isometric projection, it is nothing but a projection of a solid or a combination of solid by projecting at an angle of 30 degree here. Okay, so you can see here we have 30 degree inclined lines. Using these lines we have to do the isometric projection. So in this isometric projection, so we see the first problem. A sphere of diameter 50 mm rests centrally on top of a cube of sides 50. So there are two solids given, one is sphere and one is cube. Cube of sides 50 and sphere of diameter 50. So you can see that sphere of diameter 50 rests centrally on a top of a cube. That means first we have to construct a cube here of dimension 50. Then after that we have to do the sphere. Okay, first I'm going to draw a reference line here. Okay, so reference line I'm drawing here. Okay, I'll take reference point here. So now we are using box method to construct the cube here. So cube of sides 50 mm. So I'm drawing box of 50 here. 5 box. 1, 2, 3, 4, 5. Okay. And similarly 1, 2, 3, 4, 5. And here 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So box of 50 mm it is drawn. Now we know that in a cube we have vertical height also same thing, that is of 50 mm. 50 mm is again 5 box. 1 vertical height 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. Same thing here 1, 2, 3, 4, 5. Okay. So now we have to join with the top face of the cube. Okay. I'm joining with the top face of the cube here. So you can see that we have constructed a cube. It is somewhat similar like a hexagon. Okay, so we have constructed a cube. Above it centrally we have to place a sphere of diameter 50. So centrally means first we are going to find out the center of the top face. Okay, center of the top face. Here it is 50 means exactly at 50 means 2.25. 25 means 2.5. We are going to mark. Okay. Okay, this is our center point. So from this center point, you see we have to construct a sphere of diameter 50. We have to consider a height of 25. Say 5, 10, 20. So 25 here, 15, 5 here, 15, 25. So this is what the center point. And here a sphere will be drawn with the actual scale. Okay, sphere is the only solid which will be drawn with the actual solid. Except a sphere, all the solids will be drawn with the isoscale. Only the sphere which will be drawn with the actual scale. Okay, remember it. So sphere will be drawn with the actual scale. So always remember it, because if you are going to incline sphere at whatever the angle, it is 30 degree, 40 degree or 50 degree, you will get the same circular shape only. So there is no change in the shape in case of your sphere. Okay, so remember it, sphere will be drawn with the actual scale. So this is our sphere and this is our cube. So you can show the angle. Here it is 30 degree and here also 30 degree. Okay, sphere will be drawn with the actual scale. So remember it. So this completes the problem. You see the second problem in isometric projection. So you can see the question here in two solids given. One is hemisphere. Okay, hemisphere of 40 mm diameter. Hemisphere means it is nothing but the half part of the sphere, supported coaxially on the vertex of a cone. So the second solid given, it is cone. So for that cone they have given base diameter 60 and axis length 50. So that means we have to construct the cone first, then after that we have to construct the hemisphere. Hemisphere means half part of the sphere. Okay, now flat circular face of the hemisphere facing upside. Okay, so first we are going to construct the cone here. So for the cone the base diameter given 60. Okay, so first we are going to take the reference line here. Okay, reference line. So here you can see that base diameter 60 means we have to do the 6 boxes here. 1, 2, 3, 4, 5, 6. Again here 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. So we have to construct the 6 boxes on either side. The 6 box it is constructed. Now you see that the base part of the cone it is which is given with the diameter 60 means it is in circle. Okay, so when the circle it is constructed in ISO, it will become ellipse. Okay, it will become ellipse. So how to construct the ellipse I will show. So herein to construct an ellipse we have to go for 4 arc by center method. Okay, first I am going to mark the middle point of all the edges. If it is 60 means exactly you can mark at 30 here. Okay, 30. Now I am drawing the lines here like this, arrow lines you can draw here. Okay, so like this 4 lines you have to draw. Then after that we have to use compass here. Okay, using compass by measuring this length. Okay, I have to draw first arc. Okay, then again from this point, so measuring this length, so measuring this length like this. Then third point we have to measure this from this point using compass. Third arc, next fourth, measuring again this distance. Okay, so we have constructed an ellipse. Okay, so this is what the base diameter, when it is constructed in ellipse, it becomes a it is a base part of the cone 60 mm diameter circle converted into ellipse in the ISO. Now we have to find out the center. We have an axis length, right? So center of the box here, like this. This is the center of the box. From this we have to consider a axis length of 50, that is 5 boxes. 1, 2, 3, 4, 5. So draw an vertical height of here 60. Now we have to draw an connecting tangentially. You have to connect like this tangentially to make sure the surface of the cone has to touch like this. So this completes the cone problem. Now we have to place the hemisphere, which is having a diameter of 40. So 40 means again we have to construct a 4 box here. 1, 2, 3. That is 40 mm box means 4 box. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it is done. Okay, 4 boxes. Again you can see that hemisphere means it is a half part of the sphere, so it is in circular. So when it is constructed, it is circular means when it is constructed in ISO, it will become ellipse. Okay, so again I am marking the middle points here, the point of the box. Now using compass we have to cut the arcs here. this length. Okay, again from this point, so measuring this length. Okay, so it is done. So now again we find out the center of the box here. Okay, from this center point, so how to construct the lower part here from this point to here, exactly here we are going to take and then join it like this. Okay, so this completes the problem. Here you can see this is our 30 degree, so this it is cone and this is hemisphere. You can see that this flat circular face, it is facing upside. So this completes the problem. So you can like the video. So herein we will be encountering frustum in isometric projection. Frustum means it is nothing but a cutted portion of the solid. Okay, cutted portion of the solid. So we encounter two types of frustum here: frustum of pyramid and frustum of cone. Okay, so what happens in the frustum of pyramid? It is, if it is given frustum of square pyramid, means so both the top face and bottom face will be in square here. Okay, will be a square with the height, that is axis height is given. Okay, so that's what the frustum of square pyramid. You can see frustum of pentagonal pyramid or hexagonal pyramid means say the top face and bottom face will be same here. In the same case we can find in the frustum of cone also. In frustum of cone, the top face and the bottom face will be in circle here. So with the height or axis it is given. Okay, frustum means understood, it is nothing but a cutted portion of a solid. Okay, that's what the frustum is. Okay, we see another problem in isometric. So here in this problem they have given the frustum of a square pyramid. Frustum means it is a cutted portion of a square pyramid, of sides 40 mm and height 60 mm and top face 20 mm. Okay, so frustum means understood it is a cutted portion of the square pyramid, wherein the top face and the bottom face will be a square. The top face it is 20, bottom face it is 40 and height given 60. So rest on the center of a top of a square block. So okay, square block of side 60 and height 20. So first we need to construct a square block of 60 and height 20. Above it we have to place a frustum of the square pyramid. Okay, so first I am going to construct a square block. Okay, so square block I am constructing here, just taking reference point here at this point. Square block of base side it is 60, that means 6 block. 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. So we need to construct a box of 6 here for the 60 mm. Okay, okay, now you can see that vertical height of 20. So height of 20 means from all these corners we have to consider a height of 2 boxes. So now we are going to join it. So square block it is constructed. Now you see that we have to construct a frustum of square pyramid of sides 40, base side it is, and height 60 and top face 20. So we need to get a square of 40 here, but here in we have 60. So how to get the 40 means herein we go for the subtraction of the box method, that is say 60 minus 40. The base we have, that is 60, we require 40, so it means 20. 20 by 2 means it is 10. So we need to subtract by 10 mm on each side. Okay, so 10 mm means one box distance. Okay, understood. So 60 minus 40, 20. 20 on either side has been divided by 2. So it is 10. 10 means one box. So we need to subtract by one box on either sides. You can see that. So either side we have to subtract. Okay, so it is nothing but subtraction of the box method. Okay, subtraction of the box method. So it is done. Now we see that, so this is our box. Okay, this is our square box. Okay, so you can see that square box it is constructed. Height also we can give 6 box, and then top face of 20. So in order to do that, another box of 20 required at a height of 60. So how to do that? Say from this 40 mm box I will be considering 6 box distance here. 1, 2, 3, 4, 5, 6 here. Okay, similarly from this end 1, 2, 3, 4, 5, 6. Again from here 1, 2, 3, 4, 5, 6. Again from this end 1, 2, 3, 4, 5, 6. So another box you can construct here, that is 40 by 40. Don't draw vertical line here. So we have to construct a frustum here. Okay, you construct here box of another 40, but we here the top face we require a box of 20. It's again subtraction of box method. So 40 minus 20 is 20. On either side means divided by 2. So we get 10. So subtract by 10 on either side. Okay, subtract by 10 on either side. So this inside box, okay, this inside box is our 20 by 20. So it is 20 mm box it is. Okay, here we have this box, which is this one. I'm going to dark it, 50 by 40. So this from here to here we have to join. Again from here to here, from here to here, from here to here we have to join. Okay, so because it's a square pyramid and we have slant edges, right? So we can show like this. So we have to construct. So this completes the problem. This 30 degree. And this is 30 degree. This is square block. This is frustum of square pyramid. Okay, so this completes the problem. Okay, we do another problem in isometric. So you can see in this problem, so there are two solids given. One is cone of base diameter 30 and height 40 mm, rest centrally over a cube of side 50. So first we have to construct a cube. Okay, cube of dimension 50. So over it, so we have to construct a cone here. So cube of dimension 50 here, 5 sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. Okay. Okay, vertical height of 50 here. There's 5 boxes. 3, 4, 5. Okay. 1, 2, 3, 4. So it is also 5. So cube of dimension 50, it is done. Now centrally over it we have to place a cone of diameter 30. Okay, cone of diameter 30 means say subtraction of box meter is 40 minus 30. So 40 minus, sorry, it is 50, right? 50. So this is 50. We need to get a cone of base diameter 30. So 30 means 20 divided by 2 means 10. So 10 on either side. So we subtract by 10 on either side diagonally like this. So here we get a square of 30 here. Okay. So base diameter means it is in circle. So that means so we have to go for 4 arc by center method, marking the middle points. So using compass. Okay, we can set for a cone. So a cone of height 40 here. Axis in exactly center. Center point. So 1, 2, 3, 4. So axis height 40 here. Connect tangentially here. Okay. So this completes the problem. See this problem number 10 in isometric. A pentagonal pyramid of base side 30 and axis length 60 is resting on HP on one of its base side, base with the side perpendicular to VP. So first we have to construct a pentagon with respect to 30 mm dimension. With the actual scale we have to do it. Then after that we have to construct the box here. Okay, we need a box to construct the pentagonal pyramid. So we have to construct the box here initially. Okay. So like this we have to construct the box here, and now we have to find out the dimensions here. Okay, so this is around 28 we are getting 28 something, 28.5 something. So these dimensions we require. How much we have? 28 point something. And these dimensions also we require here. So it is how much is around 25. Okay, and then this dimension also required. This is around 9 mm. We get it. Okay, 9 mm. Okay, so here in what I will do, I am going to give this is A, B, C, D, E, and for this box I will give 1, 2, 3 and 4. So now using this box dimension we can easily construct the pyramid here. So I will be taking this as a reference. Okay, now so first I'm going to measure this box dimension. This is around 49 we have. It is around 49. Okay, it is around 49 and this is around 45. Okay, so 45. So that means if I am starting from 1 here, okay, if I am starting from 1 here, so 1 to 2 we have 49. Okay, 1 to 2 we have 49. 1 2 3 4 5. So less than 5 I'm going to mark approximately 49 here. Then similarly here 45. So 2 to 3. So this is 2. 2 to 3 we have 45. 1 2 3 4 5. So exactly here I'm going to end here. So this is point 3. And again 3 to 4 I have 49. So 49 means 1 2 3 4. So 5. So around I'll be getting 1 2 3 4 4. So somewhere here I have to get, so this point we have 4. So now we can join it. So now 1 to 2 it is 49, 2 to 3 it is 45, again 3 to 4 is 49, again it is 45. So we have to construct the box first. Box of box it is done. Now you can see that from 1 to A, 1 to A it is 9. 1 to A it is 9, around 9 I mark. 1 to A 9. Again from 2 to B is also around 9 mm, so it is 2 to B. Okay. Then 2 to 3 it is 28. So 10 20 20 28 means here we will get, this is C. Again 3 to the D is 25. Okay, approximately I'm going to mark 10 20 25. I'm going to mark here, this is D. And again from 1 to E it is 28. 1 to E it is 28. So now we are going to join. So this completes the pentagon. Okay, now we have to take center of this pentagon. Approximately I'm going to draw 3 lines here, perpendicular bisectors. Okay, 3 lines if I draw with the center. Okay, center point I'm getting. So the axis length it is 60. From this point you have to consider your axis length of, say, vertically here. We need to count the box. So just I'm keeping the scale for reference. We need to count the box. Okay, from this end 1. So 1 we have this 1. 1 2 3 4 5 6. Okay, here. So vertical it is axis we have to draw for 6 boxes. Okay, we have to count the boxes here. 1 2 3 4 5 6. Okay, now we are going to join with the slant edges. So this completes the pentagonal pyramid. Okay, so this completes the pentagonal pyramid. we do another problem on isometric. You can see here we have to construct a sphere of diameter 45 centrally over a frustum of cone base diameter 60, top face 40 and height 60. So that means first we have to construct a frustum of cone. So 60 means 6 boxes here. 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay, 60 by 60 box. So middle points we have to mark. So top face center, so height of how much? 60. That is 1, 2, 3, 4, 5, 6. So here also 1, 2, 3, 4, 5, 6. Another box. Okay, 60. So within this box we have to take 40 means 10 mm on either side. We'll get a box here by subtraction of box method. So subtraction of box method, getting can construct another ellipse here. Okay. So another ellipse it is done. So above it we have to construct 2.5, that is here exactly the center, to take 22.5. So 22.5 will take, and here I'm going to draw a circle. Okay, so this is nothing but a sphere. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism, okay, of base side 60. So base side 60 it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1, 2, 3. Typical height of 30. cube is constructed, cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. See that box of 50 here. You can count to 1, 2, 3, 4, 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50, center resting atop a square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get it here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So the height of 25 we have to construct another box here. 1, 2, 2.5 here. Similarly 1 here, 2.5 here, 1, 2.5. So here 2.5, another box of 50. Here we get at a height of 25, another box here to construct. Okay. So after constructing it, again 4 arc by center method, marking the middle points. So 5 means 20, 1, 2, 3, 4, 5. So 25 means here. Exactly 25, 25, 25. So construct ellipse here. Okay, so now we can draw here diagonal. Okay, so from exactly the center, so measuring this length, so I can construct the curved face of the, you can see that here, curved surface. So we are going to find out the center first, okay, then we'll take the length. Okay, so to find out the center, it's exactly the center points we have to take. Center point here I'm getting. So this completes the problem. Okay, we solve another problem on isometric. So it is problem number 15. So we have to construct a hemisphere of diameter 50 is centrally resting on a top of a square prism of base side 60 and height 30. So on the square prism we have to construct a hemisphere. So first we have to construct a square prism. Okay, the base side 60. So base side 60 it is 1 2 3 4 5 6 1 2 3 4 5 6 1 2 4 5 6. Okay, so you have to construct a box of 6 here. So height how much given? 30. 30 means 3 boxes. 1 2 3. Typical height of 30. Cube it is constructed. Cube of 30. Now we have to construct a hemisphere. Okay, hemisphere of diameter 50. Okay, for that I'm going for a box subtraction of box method. So here it is 60. Okay, 60 minus 50 means it is 10. 10 divided by 2 means it is 5. So on either side we have to get a box of 50 means, so on either side diagonally exactly the midpoint. So we get it here. See that box of 50 here. You can count to 1 2 3 4 5. Okay, box of 50. But we need to construct a hemisphere of diameter 50, center resting top a square prism, but such that it curved surface of the hemisphere touching the top face. That means curved surface we have to get it here. That means we have to go construct a hemisphere at a height of 25 here. So diameter 50 means height of 25. So the height of 25 we have to construct another box here. 1 2 2.5 here. Similarly 1 here, 2.5 here, 1 2.5. So here 2.5, another box of 50. Here we get at a height of 25. Another box here to construct. Okay. So after constructing it, again 4 arc center method, marking the middle points. So 5 means 20, 1 2 3 4 5. So 25 means here exactly 25, 25, 25. So construct ellipse here. Okay, so now we can draw here diagonal. Okay, so from exactly the center, so measuring this length, so I can construct the curved face of the can see that here chord surface. So we are going to find out the center first, okay, then we'll take the length. Okay, so to find out the center, it's exactly the center points we have to take. Center point here I'm getting. So this completes the problem. Okay, today we are going to do another problem in from Caed solution book, that is problem number 41. So you can see in this problem we have to construct a cube of set 25 rest centrally on a rectangular slab of 100 into 40, thickness 30. So first we have to construct this rectangular slab. Above it we have to place the cube. Okay, so for that, so take a reference line from this. This is 100 into 40 rectangle. So 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4. Okay. Again 1, 2, 3, 4, 6, 7, 8, 9, 10. So thickness we have to consider, that is 30. 30 means 3 blocks. 1, 2, 3. The rectangular block done. Now we have to construct a cube of side 25. So here one side is having 100, another side is having 40. So 100 minus 25 is equal to 75. It is 37.5. Another it is 40. 37.5 here. Okay, now in the 40 mm box you have to construct by 7.5, 7.5, 7.5, 7.5. So here cube of height 2.5, 1, 2, 2.5. One, 2, 2.5, 1, 2, 2.5. So this is what the rectangular block with respect to the cube. We do another problem in ISO. So in this problem, given hemisphere of diameter 70 placed on the ground on its curved surface. So the cone of base diameter 70 and height 70. First we need to consider a cone, and above it we have to construct the hemisphere. Okay. So hemisphere, cone of base and height placed centrally on it. That means first we need to construct a hemisphere. Sorry. So this is hemisphere first. We have to second we have to construct the cone. So you can see that first is the hemisphere we have to do. Second is the cone we have to do. Okay. So how we do that? Here hemisphere 70. So 1, 2, 3, 4, 5, 6, 7. 7. This one. So we need to get the curved surface at a height of diameter 70 means 3.5. 1, 2, 3, 3.5. 1, 2, 3, 3.5. 1, 2, 3, 3.5. 1, 2, 3, 3.5. So here also another box we have to construct. Okay. Now mark the middle points here. So marking the middle point of the box. Okay, so it is done. Now from this end we have to measure this length and we have to draw like this. Okay. So it is done. So hemisphere it is done. Now we have to draw the cone. So for the cone having a height of 70. So 1, 2, 3, 4, 5, 6, 7. You can see that. So box of 70. Okay, now we have to connect this. So tangentially. Okay. So this completes the problem. Okay, so we do this problem number 34. So in this we have to construct a sphere of diameter 60 placed central in a top face of a hexagonal prism, side 35 and height 50. So for that hexagon we have drawn an orthographic it and then we have drawn the box for it. Okay, so box dimension is very important. One side 70, second side is 30 and the other sides we have been marked. Okay, so first we need to construct a box of 70 by 60. Okay, so from this end 70 means 7. 1, 2, 3, 4, 5, 6, 7. 70 here. And then 60. 1, 2, 3, 4, 5, 6. So 70 by 60. So this is 70, this is 60. So here in this is 1, 2, 3, 4. So now done 1, 2, 3, 4 box done. It is A, B, C, D, E, F. Now 1 to A. So 1 to A, you can see that 1 to 8 is 17.5. So here it is A. Again from 2 to B. 2 to B also 17.5. Next to 2 to C we have 30. Next 3 to D again 17.5. Again 4 to E also 17.5. Next 1 to 4 F is 30. Okay. So now we will join it to construct the hexagon here. Okay, so it is done. Now we have to consider a height of 5 boxes. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, here and again 17.5, 17.5, also 17.5, 17.5, 30, so 30, so we can join to here. Okay, these again you can give 1, A1, B1, C1, D1, E1, so F1 to F, so we can join A2, A1, B2, B1, C2, C1, next we have D2, D1, and E2, E1. Okay, so it is joined. So we draw another hexagon here. So hexagon it is done. Now I have to construct the sphere. So from the center of the box, okay, so from the center of the box, so 3.5 means here and 3.5 here. From the center height we have to consider, that is 30, height 30. So 1, 2, 3 here from this point, keeping compass measuring 30 mm actual. So we know that sphere will be drawn with the actual dimension. So take 30. So from this end we have to draw a circle here. So draw a circle. So it is nothing but a sphere. Okay, so this completes the problem. Problem number 7 from isometric projection. can see in this square pyramid of base height 40 mm and heights 70 rests symmetrically on a cube of edge 50, which itself is placed on a cylinder of diameter 80 and thickness 30. So here it is a combination of three solids. First one you have to do, that is cylinder. Second, cube. Above it we have to place the square pyramid. So for this I will take the reference line here. So here it is 18 mm there. So 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 6, 7, 8. Okay, 8 by 8 cylinder it is. So if it is an cylinder means we have to go for 4 arc by center method. So ellipse it is done. Now thickness it is 30. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Another ellipse. Marking middle points here. So draw the diagonals here. So you have to connect this point with this point with this. Okay. So cylinder is done. Above it we have to place the cube of its 50. So cube having 50. So we do subtraction by what process. 80 minus 50 it is 30. Divided by 2 means it is 15. So above it 15 mm we have to subtract. So now here we are getting this cube of 50 from this end, side of 50. 1, 2, 3, 4, 5. One, two, three, four, five. and from this one 1 2 3 4 5. So now square pyramid of 40. So 50 minus 40. So it is 10. 10 will go to 0.5. So 0.5 into r. This point. So from this point height of 70. 1 2 3 1 2 3 4 5 6 7 4. Okay. So then we have to join height of 70 and then join. Okay, so this completes the problem. We are going to do this problem. So similar to using side view. Okay, so just see how I'm going to do this problem. First, I will be drawing reference line here. Okay, now from this end I will be leaving a high, because you can see that this is a cylinder extruded from the center of it, so we have to leave the 60 mm distance, that is 6 boxes. 1 2 3 4 5 6. So after leaving here we have to construct a box here. Okay, so from this end 1 2 3 4. Okay, so 1 2 2 we have 1 2 2 we have 3, that is 30 mm. So 30 means 3 box, then vertically upward by 60. 1 2 3 4 5 6. And again 30. Okay, then to join this, now we have to give the thickness for this. Okay, so thickness of how much? 30 again. So 1 2 3, thickness of 30 we have to keep. Again height of 60. So we can join it here. Okay. So this is the rectangular block. Now we have to construct this cylinder. Okay, cylinder of diameter 30, length 60. You can see the diameter 30 and length 60. So diameter 30 means here we have 60. So 60 means 1.5 box we have to subtract. Okay, 1.5 box on either side and subtract. So we get a box here now. Now we have to construct an ellipse here. So we have to go for 4.5 centimeter. Take the ellipse here, compass measure in this length, so one arc, same way here, take from this end, we have done the ellipse again. So we have to extrude here. So from this reference point, we need to consider 6 boxes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is our point. Similarly from this end, 1, 2, 3, 4, 5, 6. And from this end, 1, 2, 3, 4, 5, 6. And from this end, 1, 2, 3, 4, 5, 6. Okay, here we have to join. Now we can mark the middle point with the box. Again another ellipse you have to draw here. Okay. Now we will draw the diagonals here. Okay, so diagonals. So now we are going to join from this end to here, and then from here to here. So this completes the problem. Okay, we solve another problem in isometric. That is problem number 18 in CAD solution book. Here the rectangular pyramid of dimension 40 into 25. Okay, 40 into 25 we have to construct. The height of 50 is placed centrally on a cylindrical slab of diameter 100. Okay, first we have to construct a cylindrical slab of diameter 100. Above it we have to place a rectangular pyramid. Okay, so first we have to construct a boxes here, box of 100. Okay, thickness also given 30. From this reference point 100 means 10 bucks 1. So from this point 1, 2, 3, 4, 5, 6, 9, 10. 1, 2, 3, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 9, 10. Okay. So first we have to construct a box of 10 here. So cylindrical slab means it is a circular, and here we have the diameter given. So that means, so mark the middle point, we have to go by 4 RP center method. So taking the compass. So ellipse done. Now we have to consider a vertical height thickness of 30. 1 2 3. Just mark the point, don't draw vertical line. Just you have to mark the point 1 2 3. 1 2 3. Here again you construct another box. The box of 100 by 100, it is 10 by 10. Again mark the middle points. Exactly, middle point means 5 boxes here. Measuring the correct length here, it is very important. Okay, so it is done. Now see here, so diagonal lines, because it is in cylinder, so we have to draw the diagonals here. So now we carefully see it, we have to connect these points. Okay, vertically we have to join. So this completes the cylinder. So above it we have to construct a rectangle or a pyramid of dimension 40 into 25. So 40 into 25, so you can place 40 here or here. So we have to do, so say 100 minus 40 means it is 60, divided by two sides means 30. So on this top side I'm going to mark 30 here, 30, and from this side also 30 and 30. Okay, so 30 is marked. So you can draw line here. Okay, again now 100 minus 25, so 100 it is 75 divided by 2 means it is how much, 37.5. so we have to mark here this side 37.5, 35, 37.5 approximately. You can mark 37.5 from this end also. 37.5, so from this end 37.5. Okay, so now here you can see this is our rectangle. I'm going to make it dark. Okay, you can see that we have to have here this is a rectangle. This is 40, by 25, this one. By 25. So this is our rectangle. Okay, so I'm making it as dark. Okay, 40 by see that's what 10, 20, 30, 40. This is 25, 20, 20, 2 here 25. So here now by taking the center, so we're taking the center, so it will draw an axis length here. So from this center point we have to consider a height of 50 here from this end. 1, 2, 3, 4, 5. So height of 50 you have to do. Now we have to join it. Okay, so you can see that this rectangular prism it is done, so it's completed. The next problem we are going to do, that is using these side views, okay, and the thickness, we are going to do the isometric projection. So herein, so first I am going to take draw an a reference line here. Okay, so from this reference line you can see that I am going to do like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so from this 1 to 2 we have 60. So remember, here horizontal lines will be drawn with the 30-degree inclined lines, and the vertical lines either vertically downward or upward, it is drawn vertically only. Okay, vertically straight. Okay, horizontal lines drawn in the 30-degree inclination. From 1 to 2 it is 60. That is 6 boxes. 1, 2, 3, 4, 5, 6. So now vertically downward 2 to 3 we have, we see that this is 60, this is 30, that means this is 15, that is 50. So vertically downward by 15. Okay, now again 30. So from this end 1, 2, 3. So 30. And then again thickness 60. 1, 2, 3, 4, 5, 6. Okay. 6 here, and then again 30. So from this end, okay, 1, 2, 3. Again vertically downward. This is 2, this is 3, this is 4, this is 5, 5 to 6, again 30, 6 to 7, again 1.5, that is 1.5 box downward. Okay, and then again 60. And now we can connect it. Okay, so we can give a thickness of 30. You can see that thickness 30. So I'm going to give the thickness 30 here on all the sides. 30 means 3 box. Okay. So 31 thickness we have to give. So here I'm going to join. Okay, now we're going to join this. So like this. So this is going to complete the problem. See that thickness given. So T shape we have been achieved. Okay. So like the video, subscribe and click on the bell icon. Okay. Okay, we do another problem. That is problem number 32 in solution book. Here you can see they have given front end side view of it. Using this we have to do the isometric. Okay, so first I'm going to draw reference line. So from this reference line, so we have to give a length of 60. 60 means 6 box. So this one I'm going to do first, then after that I will do this one. 2, 3, 4, 5, 6. Then thickness of 1.5. 1.5 means 1.5 box. Okay. And here it is having a width of 25. You see that 25. 25 means 2.5 box. 1, 2, 2.5. Okay, 2.5 thickness we have to give everywhere. Okay, so it is 2.5 is here. Okay, so now we can give. Okay, this is joined. Now we have to draw this one. So it is having a width of 10 the both side. Okay, so draw this one also here for a dimension of 60. So here we have to give a dimension of 10 here. Okay, and from here also it is 10. So I'm marking for 10 here. Here also 10. Okay. Now vertical height of 60. So 1, 2, 3, 4, 5, 6. 60. And it is having a thickness of 15. You see it, 15. So thickness of 15 means 1.5 here. Okay. So from this end also it is 1, 2, 3, 4, 5, 6. So here okay. So this completes the problem. Here you can see that. So we can erase this part and this part. Okay. So this completes the problem. So we are going to do this problem. So you can see in this problem a triangular prism base at 30 and length 60, length 70 resting on a rectangular face. So triangular prism which is having a rectangular face. So resting on a square slab of side 70 and 25 mm thickness. So first we are going to do this square slab, and second on it we have to place a triangular prism here. Okay, first I am constructing the square slab now. Okay, so from this end 70 box 1, 2, 3, 4, 7. Okay. 4, 5, 6, 7. So thickness 25 means 2.5 box. Okay. So join. Okay. So square block is done. Now we have to construct a triangular prism. Base side 30 and length 70. So the base it is having 30, so it is 70 means 70 is triangle subtraction based method. So it is 70 divided by 2. This is 20 on either side. So 1, 2, 1, 2, and here also 1, 2, 1, 2. Okay. So 70 means
sketch book sikete sir early is sketch book.
So here 10, 20, 10, 20, 30. So we left with 30. So here we need to, from the center, we need to consider a height of 25. Okay, from the center here height distance we have to consider this 25. Okay, so from this end 10, 20, 25. So I'm drawing an axis here. So now we are going to join this. Same thing here from the center of it. Consider height 1, 2, 2.5, 25. Okay. Join here also. Now we join it from this top end. Okay. So this completes the problem. Okay. So this completes the problem. Okay, we do another problem in it. Okay, it is problem number 42 from the CAD solution book. Herein we have to construct two rectangle plates placed centrally over it. One will having dimension L into B into length into breadth into height. So one rectangle of 100 into 60 into 20, another of 100 into 40 into 25. So first I'm going to construct here. So from this end 100, 1, 2, 3, 4, 5, 6, 10. Okay, 60, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, 8, 9, 10. So the thickness we have to give 20. 1, 2, 2, 2. So here join this. So done. Now another rectangle of 140 into 20. So only difference you can see here 60 and 40. So 60 minus 40 means it is 20 divided by 2 means it is 10. So on the 60 mm side, subtracting by 10. Okay. Here. Okay, and vertical height from this end it is 20. 1, 2. So this completes the problem. So welcome. So it is a problem number 4 from Caed solution book in the isometric projection. You can see here the following figure shows the top view of a cylinder. So here cylinder which is centrally mounted on a frustum of a pentagonal pyramid 60 mm height. Okay, so you can see in this problem, so this is our question. So this is our question. Okay, you can see in this they will be giving this top view of it. You can see that one pentagon of dimension 50, another pentagon of dimension 20, and this is our cylinder which is having a diameter of 40 and length 100. Okay, so they will give this one. So for this one we know, as we have discussed, so if the polygons given like triangle, pentagon and hexagon, we have to draw the orthographic of it. So herein I have drawn a pentagon of dimension 50, another pentagon of dimension 20. Okay, so in this above it I have placed a cylinder here of diameter 40. You can see it. So first I am constructing this pentagon. Okay, here because it is in frustum, so herein I will take draw an reference line here. Okay, so say this is our reference point. Say here first I will construct this from 1. You can see that from 1 to 2 we have 80. 80 means 8 boxes. 2, 3, 4, 5, 6, 7, 8. Okay, then so this point it is 2. 2 to 3 we have 75. 75 means 7.5 box. 1, 2, 3, 4, 5, 6, 7, 7.5. Then this point is 3. Again from 3 to 4 it is 80. 80 means again 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this point it is 4. So now we are going to join. After that you can see 1A and 2B. With 2 to B it is 15. That is 1.5 box. These two lines were same. Okay, so first I am marking 1 to A. 1 to A it is 15. 15 means 1.5 box. This is A. Then 2 to B. See 2 to B it is also 15. 15 means 1.5 box. Okay. Now from 2 to C. Okay. So 2 to C we have. So we have to measure. It is 2 to C we have, it is around 48 mm. Okay, so here I am going to mention it. It is 48 mm. Okay, so 2 to C. 2 to C it is 48. So 1, 2, 3, 4, 48 means it is around approximately here. It is C. Now from 3 to D it is 40. 40 means 4 boxes. 1, 2, 3, 4. It is D. Now again from 4 to E, so I can take 1E. 1E it is exactly equal to 2C, that is 48. 1, 2, 3, 4, 48 means in here. That will be E. Now we are going to join these points to construct the pentagon. So it is done. Now so they have mentioned a height here, okay, height of 60. So from this corner point we will be moving a height of 60, then we'll construct this pentagon of 32. Okay, so from these corner points 1 2 3 4 5 6, okay, this point, then again from this point 1 2 3 4 5 6, okay. From this point 1 2 3 4 5 6, and this 1 2 3 4 5 6, okay. So here we get another box, so we will construct. So remember, you should consider this only height, not the, don't draw vertical line. If you draw a vertical line, it will become prism. Okay, so remember it. So after getting the box here, so you can see this is our box of 32 by 19. So we have to subtract. So either here we have to get inside box of 32 by this 32, and we have this one we have to measure, and this is 32 by 30 box we have to get, okay. By 30. So how to do it? We will subtract with the, say, this 80 mm with the 32, this 75 with the 30. So that's how we do it. Subtract 80 minus 32 means it is how much? It is 48. Okay, so 48 divided by 2 means it is 24. So on the 80 mm side, so on the 1 2 and 3 4 we have to subtract by 24. Say here in this 24 means 20 24 here 1 point, and from this end also 20 24, here also 20 24 20 24. Okay, now again this end 75, this is 75, this is 30. 75 minus 30 means it is 45. So 45 divided by 2 means it is 22.5 on the 60 mm side. Okay, this is 60 mm, this is 75 mm, so in this 22.5. So 22.5 means here in here 15 25, 22.5 means here, and the same thing here also. So 22.5, so we have to mark, right? This 15, this is 20, 22.5, and here also it is 22.5, and here also it is 15, 20, 22.5. Now we are going to draw the lines. Okay, so now we are getting a box of here 32 and 30. Okay, so this is our box of 32. So I'm going to mark this. This is 1 2 2 32 3 and 4. So this is our box. Okay, getting a box. Now 1 to A. So 1 to we have A, it is 6. Okay, 6 means here I'll mark this is A. Again from 2 to B it is also 6, this point. Then from 2 to C it is 19. So 19 means 19 6. Again 3 to 4 3 to D it is 16. So 16 means exactly here at the point, this is D. Again from 1 to E, can see that 1 to E and 2 to C it is same 19. So 1 to E it is 19, and that means it is E. So now we are going to join. So approximately we have to mark it. Okay. So here also we get the pentagons. Now we have to draw the slant edges. So we have to connect A with the A, B with the B, and C with the C. Okay, slant edges. So it is frustum of pentagonal pyramid, it is done. Now we see in this diagram from the center point, so it is at a distance of 20 because it is 40, right? So what we do, so this is our box. We will draw the perpendicular bisector. Okay, so this is our center point. This is from this center point. From this center point, we have to consider a box of 2. Okay. So from here, this point, box of 2, 1, 2. Okay. Here also 1, 2. We have to consider. And here, at the distance of 20 and 20, we have to draw. Consider a from this end to from this end 5 boxes. Okay. Because total length is 100. You can see that the total length we have here. It is 100. So from these marked points we have to consider 5 boxes. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. This end also. 1, 2, 3, 4, 5. Okay. From this end 1, 2, 3, 4, 5. Okay. So we're getting here the 100 mm length. Now from here we have to construct a box of 40. You can see that it is of diameter 40. So from this end 1, 2, 3, 4. In this end also 1, 2, 3, 4. So what we do? So we have to draw a cone here. So this is 40. From here we will be moving vertically 1, 2, 3 and 4. In this end also 1, 2, 3, 4. Okay. So we have to join it. So after this, so from these corner points we'll be marking middle points. Okay, exactly the middle points. It is to draw ellipse, we are going for 4 by center method. ellipse is done. So here in this point also, these two are the endpoints. Again here 4 boxes we have to consider. 1, 2, 3 and 4. In this point also it is 1, 2, 3, 4. Again marking the middle points. Drawing in 4 by centimeter. Again we have to construct the cone here. Ellipse is constructed. Now we have to join these two ellipse to draw the cylinder. So we'll be joining these corner points. Okay, remember these corner points will be joined. So this completes the problem. Okay. Problem number 23 from isometric projection from Caed solution book. So in this problem they have given frustum of cone base diameter 50 and top diameter 25 and height 50. So frustum means it is a cutted portion of the cone. Okay. So frustum means it is a cutted portion of the cone. So base diameter 50, top diameter 25 and height 50 is placed centrally on a square slab of side 100 and thickness 30. So first we have to construct a square slab. Above it we have to place the frustum of cone. Square slab of side 80. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. So thickness 30 means 3 box. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So square slab is constructed. Now frustum of cone diameter 50. So this is 80. So base diameter 50. So 80 minus 50. So it is 30 divided by 2 means it is 15. So 15, 1, 5, 15, 15, 15, 15, 15, 15, 15. Okay, so this is our square of 50. So here we have to construct a ellipse here, so marking the middle point. So on top diameter 25, so we should consider a height of 50 from this 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. So we have to subtract in this, but you can see that top face diameter 25. So we have, this is 50, again we have to subtract 50 minus 25, 25 divided by 2, it is 12.5. So 12.5, this is 5, this is 10, 12.5, 10, 12.5, 10, 12.5, 12.5, 12.5, 12.5, 12.5, sorry, 12.5, 12.5. So here now this is our square. So midpoint we have to mark. So now two ellipses are constructed. Now we have to join tangentially. Okay. So this completes the problem. Okay. Welcome to Engineering Visualization channel. Problem number 23 from Caed solution book. A frustum of cone diameter 50, top diameter 25 and height 50 mm is placed centrally on a square slab. So first we are going to know what do you mean by frustum. Frustum means it is nothing but cut portion of the solid. Okay, cut portion of the solid to a particular height. So here you can see, here it is a frustum of cone. I am going to write that how it is look in front view. So here in the frustum, it consists of frustum of cone. It consists of two circle here. One is 25 mm top circle, and the base circle here it is 50 mm diameter. Okay, so and it is having a there are two circles which are at a height of 50 mm given in the question. That means both the top and the bottom part will be the circles which is of diameter given in the question. Place centrally on a square slab of 80 mm side and thickness 30. So first diagram we have to construct, that is a square slab. Square slab dimension given, side of 80 mm and height, that is thickness given, that is 30 mm. Okay. So above it we have to construct the second diagram, that is our frustum of cone. Okay, in order to construct the frustum of cone, they have given the dimensions here. So base diameter given, it is 50 mm. Okay, base diameter 50 and top diameter 25 mm. Okay, and height also given, height it is 50 mm. Okay, so first we need to construct in isometric, that is our square slab. Okay, square slab. First I will be drawing one horizontal reference line. Okay. Okay, to construct the square slab, they have given the dimension 80 mm side, that is 80 mm box we have to construct. So here square slab will be constructed using box method. Okay, first I will be drawing one horizontal line. Okay. Horizontal line. Okay, mark one reference point here. So here 80 mm means 8 boxes we have to count. So 8 boxes. Okay, so join all these points to get a box here. Okay, try to join a straight line. Okay, so again count 8 boxes and mark a point and then connect now. Okay, now we have to give the thickness here for this box. Okay, and it is, you can see all these lines were at an angle of 30 degree. We can show this 30 degree angle. Okay, and here given it is thickness 30, 30 means 3 boxes. Vertical height we have to consider. Thickness means it is nothing but height. Okay, 3 boxes you can mark here. 1, 2, 3, 1, 2, 3. Here also 1, 2, 3. Okay, draw the vertical lines here. Now connect this top end points with the box here. Okay, so here square block it is completed. Okay, now we have to complete this frustum of cone. For this they have given base diameter, top diameter and height. Okay, on the top of this square slab we have to place the base of 50 mm. For this we will be using subtraction method. Okay, subtraction of box method, we can say that. Say subtracting the boxes. Here we have top box of 80. So we need to subtract with the 50. 80 minus 50 means it is 30 mm. So it is on either side means 15 mm. So we need to subtract the 80 mm box. Okay. So at a distance of 15 mm. Okay. We can write 15 mm easily on the top box of 80. 15 here. 15 here. Okay. Again 15 here. 15 here. 15. 15. You can mark easily. Okay. Now we need to draw the where we have marked these points, right? We will be drawing with the thin lines here. Okay. Now we will get another box here, another box inside. What we get, that is of dimension 50 mm. Okay, 50 mm. Now here we have to construct a circle. When it is constructed in the isometric, okay, it will be constructed as a ellipse here. Okay, ellipse. So we will be using 4 arc by center method. So draw the ellipse. So here, as we know, the circle will be converted as an ellipse here. So ellipse will be constructed using 4 arc by center method. 4 arc by center method, you can say that. Okay. First I will be marking the midpoint of this 50 mm. Okay. So mark the midpoint here of the inside box, exactly midpoint at 2.5 you can mark. Now draw the lines here. 4 lines you need to draw. Okay. Okay, so we have drawn the 4 lines here. Now measure this line and draw an arc here. We have to draw an arc. Okay, now taking that as a reference point. Okay, you can subscribe to the channel and hit on the like button and share to maximum students so that they can be benefited. Okay, these are all the problems in the Caed solution book. It is very helpful for the first year engineering students. So they are studying this engineering graphics or computer aided engineering drawing subject. Now we have completed the base diameter 50, that is we have drawn an ellipse here. Now by taking 50 mm the inside box, so we have to consider the height here now. The height of 50, so count the boxes. So here the box count, it is coming from exactly the center of it. So count 5 boxes, and again here we need to construct another box of 50. Okay, from there we will again subtract, so that we will get another box of 25. Okay, now I will be drawing another box here, box of 50 by 50 at a height of 50 mm. Okay, just we need to count here, don't draw vertical lines. If you draw the vertical line, it will become prism. Okay, so it will become prism. So connect it with the thin lines here. So box of 50 by 50, you got it. Now here the top diameter, it is 25. So but we have drawn a 50 again. Now subtraction of box method. 50 minus 25 means it is 25. So you have to subtract on either side, means it is 12.5. 12.5 mm we have to mark. You can see on this the top box. So this is 10 here. So 10 means it is 12.5 here we have to mark. In the same way here also 12.5 we have to mark. Okay, on this side also we have to mark 12.5. Okay, here also on the top box we have to mark 12.5. Here also 12.5. Okay, 12.5 we have to mark. Now draw the lines where we have cut it exactly at 12.5. Try to connect with these lines so that we get another box of 25 mm. Now you can see the inside we getting a box of 25 mm. Okay, the inside box, we will consider that as a reference. Yeah, those are the corner points of that particular box. So mark the midpoints now. Again we use the 4 arc by circle method, 4 arc by center method to construct the another ellipse, because that is the frustum of the cone. Okay, in a frustum of cone we have both top and bottom will be the circle. So when it is constructed in the isometric, it is becoming as a ellipse. Okay, so subscribe to my channel and hit on the like button and share it to maximum students so that they can be benefited. Okay, draw an arc here to construct the same way how we have constructed the bottom ellipse, right? Same method we have to do it. Now draw horizontal lines connecting the corner points here. So now join here. Tangentially we can draw here. Okay, so that completes the problem. So here you can see we have completed both. This is nothing but your square slab. This is your frustum of cone. Thank you all. Thank you for watching the video. Subscribe to my channel and share it to maximum students so that they can be benefited. Thank you guys. Problem number 25 from Caed solution book. So it is a problem from isometric projection. A hemisphere of diameter 50 mm resting on its curved surface centrally on the top face of a frustum of a rectangular pyramid of base side 80 into 60 and top of 60 into 40. So with the height given 55. So first we have to construct a frustum of a rectangular pyramid. Okay. So first we construct this 80 into 60. 1, 2, 3, 4, 5, 6. Now, so we need to consider a height of 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. So we need to get a top of 60 into 40. So that is 80 minus 60. 20 by 2 is 10. 60 minus 40, 20 divided by 2, 10. So on the either side we have to subtract by 10 here. So now we are getting so first term of a rectangular pyramid, it is done. Now we have to keep the hemisphere of diameter 55. So for that we need to consider a height of 25. So 1, 2, 2.5, 1, 2, 2.5, 1, 2, 2.5, 1, 2, 2.5 here. Another box. But here we need a box of 50. So here we have 1, 2, 3, 4, 5. So this is 50. But this one is it. 1, 2, 3, 4. Here. So this become 50. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. This is 50. Okay. This is 58. But here we get 1, 2, 3, 4. Now you see it, and this is our box of 50. So marking the middle points. from this point measuring this length into okay, so this completes the problem. A regular pentagonal prism of base side 30 mm and axis 60 mm is mounting centrally over a cylindrical block of 80 mm diameter and 25 mm thick. So draw the isometric projection of the combination of solids. So here I will be drawing a top view, the orthographic view of this pentagon and then a circle. First I will be constructing a pentagon of dimension 30 mm. So draw a vertical line of 30 mm. So take protractor and mark for 72 degree. You all know how to construct the pentagon with the angle of 72 degree. Okay, draw a line of length 30 mm passing through that angle point. Okay, so here also you need to mark for 72 degree and draw a line of length passing through that angle point, a length of 30 mm. Okay, so now you take compass, measure 30 mm and cut the arc. Okay, so now you join with the help of a scale, straight line you draw connecting it. So this completes the pentagon dimension 30. Okay, so now to find out the center of this, I'll be drawing first I'll be drawing middle points to draw the perpendicular bisectors. Okay, at least I will draw 3 perpendicular bisectors, marking the middle points. Okay, so this is how you have to draw the perpendicular bisector to find out the center of the pentagon. So here I have drawn 2, so I need one more. Okay, one more. So mark the middle point. Okay, so 30 means exactly you need to mark for 15 mm here. Okay, so okay, after constructing it, so show the dimensions. So it is having a dimension of 30 mm. Okay, now we should construct a box for this, because we will be constructing using box method in the isometric. Okay, that's why we need to construct the boxes here, or the extremities of this pentagon we will be drawing horizontal and vertical lines. Okay, so that we can able to construct a box for the extremities of this pentagon, so that within this we will get a rectangular box here for this pentagon. Okay, we should construct it. Okay, you can measure the dimension and show it. Okay, it is around 49 mm we get here. Okay, the middle point of that will be 24.5. and this is vacating around 45 mm. Okay, and this one also we should measure. This is we are getting around 28 mm we get here. Okay, the total length we get it is 45. We should measure this length because so it will be helpful when we construct this pentagon. So because it is in polygon, so that's why we should have all these lengths. If we measured these lengths, okay, box dimensions and this end points length, so it will be easy for us to construct it. Okay, so it is having a length of 45 mm. We will show it. Okay, now from the center of that we will be constructing a here it is a cylinder block, means it will be in circle. So the diameter given 80 mm, so we will be considering a radius of 40 mm here. Okay, then we construct a circle here. So that means it is having a box dimension of 80. We no need to see, but we can show only the dimension. So we will show the dimension on one side. So the box dimension of this cylindrical block, it will be 80 mm. Okay, now we need to construct the isometric of it. So you can see we have the first we need to construct a box of 80 by 80, that is 8 by 8 box. First I will draw a reference line. Okay, then we'll take a reference point. From that reference point, okay, I'll be counting 8 boxes. Okay, 2, 3, 4, 5, 6, 7, 8. This side also I'll construct the same thing. 4, 5, 7, 8. Okay, so construct the box first. So here it is a cylinder, means we should construct the ellipse here. We should construct the ellipse here, 2 ellipse at a height of 25 mm, because it is having a thickness of 25. So the height we should consider, that is 2.5 box. 1, 2, 2.5. Okay, again same thing we should do it for all these extremities, 2.5. Again 1, 2, 2.5. 1, 2, 2.5. Okay, so here also we should construct another box of 80, that is 8 by 8 box, 80 mm, 80 by 80 mm. So we should join these points which we have taken. Okay, so now we got the box again here. So now we should mark the middle point of this box. So it is 80, means exactly at 4 boxes. Count it perfectly. 1, 2, 3, 4. Again 1, 2, 3 and 4. 1, 2, 3, 4. Same thing here also, 1, 2, 3, 4. Okay, count again, 1, 2, 3, 4. So mark it properly. Now you draw the line from the corner of the point to the opposite middle point. Here we are following 4 arc by center method to construct the ellipse. You all know how to construct it. Okay, 4 arc by center method. Okay, then in the top box also we should do the same thing. Okay, now use compass to measure these lengths and cut the arc. Okay, measure the length, any one length. You can construct these arcs same way from the other end. Okay, join it properly. And then from that reference point we construct part of the ellipse. Okay, the same way we should do it for the top box also. Okay, from that reference point. Okay, measure the length and cut the arcs to construct the ellipse here. Okay, now you draw the diagonals for the bottom box and the top box. The straight line you can join, connect. Okay, for this point also you can do it. Okay, now we can join these extremities with the vertical line here and here also. Okay, so now we have to use the subtraction of box method. Okay, so one side we have 80, one side we have 45. 80 minus 45, it is 35. 35 divided by 2 means 17.5. And the other side we have 80 minus 49. 80 minus 49 means 31. 31 divided by 2, we have 15.5. So that means on the one side we should mark 17.5 on the other side of the line, and the other box side we should mark 15.5. It is almost around 15 only. So that's what the thing I'm going to do it on the top box. So on the top box I should mention, okay, you can see here the top box we should mention one is 15, one is 17.5. You can mention it. So first I'll be mentioning 17.5, from this side also 17.5, there also I should mention 17.5, and here also 17.5. Now on the other side we should mention 15, 1.5 we should mention, 1.5, 1.5, 1.5 and 1.5. Okay, so now we'll draw the lines connecting these points. Okay, and join these reference points also with the straight thin lines, because we will get a box here for, we'll get a rectangular box for this pentagonal prism. Okay, okay, now we need to find out that, and we should dark it so that it will be easy for us to construct the pentagon within that rectangular box. Okay, box of 45 by 49 we get it here. Okay, okay, now You can see we should we have already measured the box in the pentagon. We should use those point lengths such as 9, 28 and all. I'll be marking 9 here. You can see on the either side, and then I'll be marking the middle point, that is 24.5. okay, and then I'll try to join. Still I need to mark 28 here, so 28 I'll be marking. So this is where I'll get 20, 28 here, okay, here and here, okay, and then I'll join these points to get the pentagon here. Okay, so by joining all these points we get a pentagon here, okay. So from these pentagon extremities exactly vertically upward we should move at a height of 60 mm, that is 6 boxes. Therein also we need to construct another pentagon, okay, another pentagon. So from these extremities point, so using scale we can count the boxes here, okay. I can count it. Just I'll be using the help of the scale here, that's it. But I'll be counting the boxes only here, okay. 1, 2, 3, 4, 5, 6, okay. That is your reference point, okay. Draw vertical line because it is a prism. Same way for this. 1, 2, 3, 4, 5, 6. Draw a line, okay. Same way here also. Why I'm using scale means it will be helping to draw a straight line. 1, 2, 3, 4, 5, 6. Can join, okay. The same way here also you can do it. You can count 1, 2, 3, 4, 5, 6. You can join here, okay. And then here also you can do it. 1, 2, 3, 4, 5, 6. You can join, okay. Now we get a pentagon above it, so you can see that at a height of 60. So we should connect it, okay. We should connect it. To get the pentagon here. So you can see, so that completes the problem. You can see that the subtraction of the things we have done here. Problem number 39 from CAD solution book. It is a frustum of square pyramid, base height 40 mm, top face height 20 mm and height 40 mm is placed centrally on a frustum of a cone base diameter 80 mm, top diameter 60 mm and height 20 mm. Draw the isometric projection. So in this first we have to construct the frustum of cone, okay. For that they have given base diameter 80. So for that we have to construct the box for it. First I am taking a reference line here. So count 8 boxes. So it is a cone means it is a circle. Circle means we have to construct the ellipse here, okay. We have to construct the ellipse here. Using 4 arc by center method. So taking the compass, we can construct the ellipse here. Taking the lens, measuring the lens. Now on the top circle it is at a height of 20 mm, so we consider a height here of 2 boxes. Don't draw vertical line here, you have to just count the 2 boxes and draw again a box of 80. So here we need to get a box of 60, so we are subtracting 80 minus 60 means it is 20, so neither side means divide by 2, so 10 we get, so we have to subtract by 1 box here on either side. Now we are getting a box of 60. Just I am marking the corner points of the box. Again for arc by centimeter, mark the middle point of the box. So here it is 60 means mark exactly the 3 box. So again for arc by center method to construct the ellipse here. Here we have to draw a tangential line for the 2 ellipses with the curved surfaces. Okay, so like this you have to draw in this. So here also same thing. So above it we have to construct the frustum of a square pyramid. So it is having a base of 40. So but we have a top face of 60. So we are subtracting 60 minus 40. It is 20. Either side means it is 10. So height they have given it is 44 boxes we have to count. Again we have to substitute, because top face it is 20, 40 minus 20 it is 20, divided by 2 means 10. So on other side you have to subtract by 10 means one box. Now on the top face we get a box of 20 by 20. We see problem number 50 from Caed solution book in isometric. You see in this problem they have given rectangular slab of side 100 into 80 and height 30 as a full depth coaxial squares whole of side 40. So first we are going to construct rectangular slab here. From this 100, 1, 2, 3, 4, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 100 by 80. That means 10 into 8. Height we have to give 30. 30 means 3 blocks. Now we have to have square root of side 40. So we have 100 into, so 100 minus 40 it is 60 divided by 2 means 30. Then 80 minus 40 means it is 40. 40 divided by 2 means 20. So on the 100 mm side, so we have to mark up 30. So on the 80 mm side we have to mark up 20. So now we got the square of 40 here. I'm going to mark it. So this is 40. So we have to give a height of 30. This is thickness having 30. That means you have to give a depth of 30 here. So thickness 30. So vertically so 33 box. So 30. So you can see that so this completes the problem. Square prism of base side 40 mm and height 50 mm is placed centrally on a cylindrical slab of diameter 100 mm and thickness 30 mm. So here first we should construct a cylindrical slab. That's why given number 1, cylindrical slab. First we have to construct. Okay. Second thing, we should construct above of it, that is a square prism. So the dimensions we can write down. So 100 into 30, this is 40 into 50. Okay. Okay, in the isometric sheet, you take the reference line. Okay. Okay, from this reference we should mark 110 boxes, that is 100 mm, right? We should mark 10 boxes on either side. Okay, so construct the square box here. Square box for 10 by 10. So we should draw here thin line for the square box because it is a cylinder. Okay, that's why we should construct this 110 by 10 box, that is 100 mm, with a thin line. Okay. Okay, now we should consider a height of 30 mm. Okay, thickness given 30 means 3 boxes we should consider, and we mark a reference point 1 2 3 1 2 3 1 2 3. Now here we should construct another box of 100 by 100, that is 10 by 10 box. Okay, 100 mm box you have to construct. Okay. Okay, after constructing this box of 10 by 10, we should construct the ellipse here. Okay, 2 ellipses you have to construct, and then we have to join to construct the cylinder here, cylindrical slab. Okay, so use the compass. So first we should mark the middle point of all these boxes. So mark the middle points for the both the top box and the you should mark exactly at the 5. Okay, midpoint we should mark. Okay, so after that we should draw a lines here from the corner point. Okay, either you can draw first, you can draw for the bottom face. See, from the corner point, so to the middle point what we have marked, we draw a line here. We know how to construct the ellipse, so we are following the same concept. From that middle point we are joining with the corner point here with the line. The same thing we do it for all the middle points. With the corner points we are trying to join here. Okay, and the same thing we will be doing on the top box also. So here I can use this length to construct the ellipse here. Okay, okay, then take this as the reference point. So measure this length carefully, you can cut the arc. Okay, so that is also having the same length, so you can cut here also by considering that as the reference point. Okay, now the same way we do it for the top box also. So we try to connect with this corner point with the middle point of the box with a straight line. Okay, Okay, now we construct the ellipse here by measuring the lengths here. So measuring these lengths, you can construct the arc here. So measure it properly and construct it. Same way we should do it for the other side also. Measuring this straight line's length using compass, and we construct the arcs here. Okay, the same way do it here also. Okay, so now we got two ellipse here using these two boxes. Now I'll be drawing a straight line connecting these opposite corners. Okay, now we are going to join these points, okay, vertically with the straight line. Okay, that completes the cylindrical slab. Now above it we have to place the square prism, which is having dimension of base side 40 and axis length 50. So we have to go for the subtraction of box method here. So we have the box of 100. 100 minus 40 means it is 60. So we have to divide on two side means it is 30. That is 3 box dimension we should mark on the top box here. On the top box we should consider 3 box. On all either sides we should mark 3 box here to go for the subtraction of box method. It's because we should get a box of 40, right? Because square prism having a dimension of 40. So we can subtract by 30 mm on all the either sides. We can subtract it easily. Okay, now we get a square here of dimension 40. Okay, so for the square we should consider a height of 5 boxes, that is 50 mm from all these corner points. Consider a 5 box height from all those corner points. Okay, now draw the top face of dimension 40 by considering a height of 5 boxes here. Okay, just draw connecting these two square faces by the vertical edges. Connect these corners with the vertical line here. Okay, so we can mention the angle 30 degree for the base where we have taken a reference. Okay, you can see this is our second right cylindrical slab, dimension 100 into 100 and height 30. This is a square prism, dimension base side 40, height 50 mm. So that completes the problem. Problem number 49 from Caed solution book in the isometric. You see in this problem a square prism side 40 mm and height 50 has a full depth coaxial square hole. Okay, full depth coaxial square hole, side 20. So it is one of the type of problem. Okay, it is a different type. So just see it how to do it. Just taking the reference line from here. So it is of side 40 and height 70. 40 square, there is 4. 1, 2, 3, 4. 1, 2, 3, 4. And height 70. So height 70 means 7 boxes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it is a square prism, then we have to draw these vertical edges. Now it is having a square hole size 20. So this is having 40. So we are going to subtract 40 minus 20 is 20. Either side means divided by 2. It is 10. So subtracting by 10. Either side. So here we have the square hole. So this is our square. So I'm going to draw it vertically downward. So this completes the problem. Draw the isometric projection of a rectangular prism, dimension 60, 80 into 20 mm thick, surmounting a tetrahedron of sides 45 mm, such that axes of the solids are collinear and at least one of the edges of both the sides are parallel to VP. So you can see here in this I have drawn the orthographic of the tetrahedron, both the top and front view of it I have drawn. You see that, that's what I am writing. Orthographic view of tetrahedron we required to construct here. Okay, you can see initially I have constructed a 45 mm triangle. Okay, then after that I have taken a mark the points, and then I have marked the middle point of all the edges to draw the medians here, and then you get the exact point. You need to draw the medians here, remember. And then I have projected the lines, and we don't know the axis length here, just projecting the line, and you can see the edge OBT is parallel, so we should measure 45 mm and cut the axis. So we should cut with respect to the 45 mm. We need to find out the axis. Here the axis length what we get, that is 36 mm. Okay. Now after that we have to construct the box for it. Okay, we need a box. One side we have 45, another 40, and exactly half of that, that is 22.5. Okay, now we need to construct the isometric of this. Okay, first we will be constructing a rectangular prism, then above of that we will be constructing this tetrahedron. Okay, I'll be using the isometric sheet because it is an isometric problem. So first take a reference line. You can see that. So first we have to construct a rectangular prism, so which is having a dimension of 60, 80 into 20 mm thickness. Okay, I'll be constructing a first I will take a reference line, then I'll be constructing a rectangular box which is of dimension 60 into 80. Okay, then after that I'll give the height of 20. So first you draw a reference line. Okay, you take one reference point. So from this reference point you consider the boxes here. Okay, 60 means 6 boxes. Okay, and 80 means 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we can construct it. Okay, 1, 2, 3, 4. Can again recheck. So now we have to construct the box here, rectangular box, rectangle. Then after that we will be giving a height of 20. Okay, here exactly at all these points we need to give a height of 20 mm. Okay, you can see in the problem. So the thickness we should give, that is 20. Okay, that is 2 boxes height we have to consider vertically. Okay, thickness we consider in vertical height. And then rejoin to construct a rectangular prism. Okay, so join all these extremities to construct the rectangular prism here. Okay, you can mention the angle 30 degree on either sides. Okay, so now we can see we have this rectangle of dimension 60 into 18, but we need to place this tetrahedron, which is I need to place this 45 on this 80 and this 40 on the 60. So we will be going to the subtraction of box method here. 80 minus 45, so that will be 35. So 35 divided by 2, because we should consider on both the sides, that is 17.5. In same way, the another side we have 60 minus 40, so it will be 20 by 2 means 10 mm. So we need to mark on the longer side, that is 80 mm, that is 17.5. okay, 17.5, that is more than 15. Okay, in between 15 and 20 we should mark, okay, approximately, and then 10, so we can count exactly one box here. Okay, you can construct the thin line here. Okay, okay, so now we get the internal box dimension 45 and 40. Okay, that's what it is, the box dimension of the tetrahedron, right? So you can mark the middle point and you join to construct the base of the tetrahedron. So base of the tetrahedron, it is a triangle. Okay, now we can find out the center of the box here. Okay, center of the box we find out. So for that we will drawing to take middle points here, and then we draw middle point of the box we consider, and we have to take the center point here. Okay, so we can consider the middle point of this by drawing median also we can do, that is also we can do it, or either we can consider the middle point of the box. So both the things are we can able to do it. Okay, whichever you find feasible you can follow that. So I will be considering here middle point of the box. Okay, from that center point we will be considering a height of 36. So that's what we have been find out from the orthographic height. We have been find out, that is 36 mm. Okay, that's what we have been find out. So we'll be considering a height of 36 means 3.5 box, more than a half box, a little more than the 35. Okay, so we'll be drawing an axis line here. Okay, and then joining with the base of the triangle. So we should connect it. Okay, okay, so that completes the problem. Okay, so development of pentagonal prism of side 30 mm and length 60 mm using parallel line method. Okay, so how we project, you can see here I have constructed the top and front view of a pentagonal prism. And now we have to construct the development of this. So how we do it means, so we will be extending the lines here just like this little bit. Okay, so we'll be extending the lines. Okay, so here the line, it is same parallel. So I'll be starting from this end, say here, from here a vertical line, that is true length 60. Okay, and here you can see this pentagonal prism having 5 sides. Okay, so what we do, we'll measure 30. So 30 means you can measure from the compass, or you can directly cut it for each 3 boxes. Okay, so total 5 faces we have to get. Okay, so now draw vertical lines. So 5 faces, you can see 1, 2, 3, 4, 5. Each of the faces having the same edge length of the pentagonal prism. So we will be giving the naming as in capital letters, that is A1, B1, C1, D1, A1 and A1. Again it is joining with the same face. Okay, same way. So we'll be writing for this top also capital A, B, C, D, E and E. So this is nothing but the development of this pentagonal prism using parallel line method. Square prism of base side 35 given. So rest on the base on HP. So with the faces equally inclined to VP. So you can see, so with respect to the diagram given here, we need to draw the development of the lateral surface. So it has been cut with respect to the diagram here. So you can see we have a base edge of 35 and it is a square prism. So 4 sides means, so it is around 140 mm. So the total length we get, it is 140 mm. So first we will take initial edge here. Okay, initial reference point. Okay, from there, okay, so you can see it is having 4 sides and each of the sides are having 35 mm. You can measure from the scale, or you can measure the same length from the top view of the first diagram. Okay, 35 you need to measure and cut 4 arcs. Okay, 4 arcs you have to cut here. Okay, 4 arcs you need to cut. Okay, so we will extend the line here till the cutted arc. So the top side also we do the same thing. Okay, now wherever the cutted arc is there, so we will be drawing vertical lines. Okay, these are the true lengths. Okay, so we need to draw the vertical lines where we have cutted the arc. Okay, so now we have to mention the namings here. Okay, so capital A, capital B, capital C, capital D and capital A. So at the A, so it exactly cutting at here 1, and at B it is 2 here, and at the 3, so it is cutting exactly here at the C point, and again at D it is 4, it is cutting at D here. Okay, so now we will join all these points 1 2 3 4 with a straight line here. Okay, so the cutted portion, so the remained cutted portion we need to show in the dark line, so that's why I'm using the pen here. So you need to dark this. This is what the development of the cutted portion of the prism. Okay, we need to join the base heads also here. Okay, okay, so this completes the problem. A rectangular prism of base side 25 into 40 mm given, axis length 65. It is resting on HP on its base with the longer side of the base inclined at 30 degree to VP. So it is cut by a plane inclined at 40 degree to HP and perpendicular to VP, and exactly passing at extreme left corner of the base. Okay, so first I will be drawing an XY line. Okay, XY line I will draw now. Okay, I will take a reference point on this. Okay, take reference point. So keep the protractor at this point. Mark for angle 30 degree. Okay, so it is exactly inclined at an angle of 30 degree. Okay, so draw a line of length passing through this angle point. So the angle it is 30 degree. Okay, and here it is placed with the longer side it is 40 mm. So measure the length of 40 mm on this angle line. Okay, angle line 40 mm. So now you take the protractor, mark exactly at 90 degree using these reference points. Okay, again we keep the protractor at the another reference point, mark for 90 degree. Okay, now we draw a line of length passing through this point at a height of 25 mm. It is a rectangular prism. Okay, so draw a line of length passing through this 90 degree point at a height of 25 mm. So 25, so you can mark 25 mm here. Okay, then join. So that completes a rectangle of dimension 40 into 25. So we will show the dimension. So you can show on the upper side or the lower side, no problem. So 40 and 25. 40 by 25 and inclined at 30 degree. Okay, now we have to draw the front view of this. So it is an prism, so it is having top face and bottom face. Top face A, B, C, D, bottom face A1, B1, C1 and T1 not visible. That's why it is in bracket. Now we draw the diagonals to find out the center of the axis. Draw the diagonals. Mention O1, center of the axis. Now draw the projection lines from all these endpoints. Okay, so draw the projection line here. Okay, you can see here the axis length they have mentioned, it is 65. So from the axis, first I will draw an axis length for 65 mm, and then the remaining edges also will draw for 65. Okay, From all this, we need to draw the vertical edges for dimension 65. Then join. We get the rectangular face in the front view for a prism, right? This is an rectangular prism, height of 65. Okay, so we can show the dimension for the front view. So it is 65. Okay, so now we can see there is an cut plane, there is sectional plane cutting at an angle of 40 degree to HP, and it is perpendicular to VP, passing extreme corner, left corner of the base. You can see extreme left corner we need to consider here. So this is whatever the extreme left corner. Okay, keep at this exact point. Okay, and mark for angle 40 degree. Okay, mark for angle 40 degree. Draw a line. Okay, cut plane here, passing through this angle point. Okay, section plane you need to draw here. Okay, and it is exactly at an angle of 40 degree. Okay, now we need to dark the remaining portion, that is retained cut portion. We need to dark this. Okay, so we need to dark this. Okay, now we need to mark the points here. 1 exactly at A, and B exactly at 2 exactly at B, and 3 exactly at C, and 4 exactly at D. So, and again 5 we get it, and 1 here. So now we draw the development of this cutted remaining portion of the prism. Okay, so first I will extend these lines, because these things are drawn with the true lengths of line. Okay, true lengths of line, these things were drawn. So first I will take a reference vertical edge. Okay, from this vertical edge we need to proceed from A to B. You can see from A to B it is having a length of 25. It is having a length of 25. You can cut the arc. So that is your AB, 25. Next from, so we'll draw vertical line here, and I will show the dimension for this. So the dimension it is at 25 mm. Okay, 25. Next from B to C we have 40 mm. B to C we have 40. So we'll cut the arc, that is BC. BC it is having 40 mm. Okay, BC we have 40 mm. Again from C to D we have 25. Okay, C to D we have again 25, because this is an rectangular prism. So based on the edge we need to consider the length. Again from D to A, again it is 40. So we can mark the points here, D, and this is A. And we draw the vertical edges exactly at these BC and D and A points. So drawing the vertical edges. Okay, so now we have to mark this point number 1 at A, and at B we have, so we can measure it from the compass, from the top face or from the bottom face we can measure it, no problem. Okay, you can measure that and cut the arc. Again you can measure that point number 3 on the point D, again the point number 4 on the vertical edge D. Okay, so now we can mark the namings here. So it is 2, 3, 4. So now I have to join all these 1, 2, 3, 4, 5 with the straight line. With the help of scale we'll join this. So we need to join this. So we need to dark this the entire retained remaining portion of the rectangular prism. We need to dark this. Okay, so we have to dark it, because this is what the cutted remained portion. Okay, remained portion, we know that we need to dark it. Okay, so this completes the problem. A square prism of base height 30 mm and axis length 60 is resting on HP on its base with all vertical faces being equal to inclined to VP. That means it is here also we need to construct a square prism of dimension 30 with respect to corner position. Okay, and here in the cutting plane it is inclined at 60 degree perpendicular to VP, and it is passing at a distance of 50 mm from the base. So we need to draw the development of the lower portion of the prism here. So first I have taken a reference point, then I have put the protractor and mark for 45 degree. Now I am drawing a line of length 30 mm passing through that point. Okay, so draw a line of length 30 mm passing through that particular point. So from this end also you can draw. Take the compass and cut the arc for 30 mm. You can measure it any one of the edge. And the reference point, from the reference point you can cut it. Okay, and then join it to get the square with respect to corner position. You can show the dimension on one side, that is 30 mm. Okay, then it is a prism, that means it is having two faces, top face and the bottom face. Okay, here in the thin lines I am trying to get the center of the axis. Okay, show the dimension 30. You can write A1, B1, C1 and D1 and O1. Okay, then draw XY line. Draw the projection lines from all these ends. Okay, draw the projection lines. You can draw the axis line of length 60 mm. 60 mm. So you can draw measure exactly 60 mm, that is 6 centimeter from the scale. You can draw vertical line, that is axis line here. So using the axis line we can draw the front view of this square prism. You can easily draw. Okay, so that completes the front view of the square prism. You get a rectangular face here. Okay, now here you can see, so inclined plane, that is a cutting plane. So we will show the dimension here. The dimension it is 60 mm. So axis length we show that. Okay, now you can see that the vertical plane, that is inclined plane, cutting at an angle of 60 degree, and it is at a height of 50 mm from the base. So from the base we need to consider 50. So mark a point for a 50 mm, that is 5 centimeter. Okay, then take the protractor mark for angle 60 degree here. Okay, mark for angle 60 degree, and then draw a line of line passing through that angle point. So mark the reference point. Till there we can draw a cutting plane here. Okay, exactly at that point you can mark. Okay, so here, so that is our 1.1, and exactly where it is meeting. 2 point, it is exactly at the B, and 3 point. So we need to draw vertically downward line. We don't know exactly where it is cutting, so we need to draw vertically downward line. So it is cutting here exactly at 3, and here we get the 4, and 5 point we are getting exactly at the D point here. So we need to draw the development of this. Okay, I'll show where it is exactly cutting. So it is exactly cutting at 50 mm from the base. You can show that dimension. So now you can extend it. So because it is drawn with the parallel line method, just you draw 2 lines extending from here. Okay, so here it is a 30 mm base length. It is having 4 sides, means we need to extend by till 120 mm. Okay, so first I'll take a reference end here. From this point I'll be marking exactly at 120 mm, that is 12 centimeter. On the both side I'll be marking it. Okay, so now we'll join this. Till here we need to extend. Okay, exactly here till here, so you can join it. So now you can take the compass and cut exactly, measure 30, any one of the edge you can measure, and cut 4 arcs here. Okay, it is having 4 sides, right? You can cut 4 arcs. Okay, so you can cut it exactly 4 arcs. Okay, then draw vertical lines joining at these points. Okay, so these are the two lines you can draw. Okay, so you can mark A, B, C, D, capital A, B, C, D here. Okay, then so we need to extend this one point. So we extend, so we get it on the point A here. On the line A we getting this here. So we're drawing thin lines. So on the A line we marking 1, 1. Same way we will be extending this 2 and 5 point. So if we extend this, so 2 we are getting on the line, that is the edge B, and the 5 point we getting on the edge D. Now for that 3 and 4 we need to measure exactly how much it is. So it is around 1.1 something it is getting. This is 11 mm are getting. So what we do, so we can take the compass and measure the same length, and we can cut the arc. Okay, from 2 to 3 and 5 to 4, like that we can do. So we can measure any one from here to here or from this point. Okay, so here from here also you can measure. It is around 12-13 mm we are getting it. So we can measure this. So we can measure this, and we can cut the arc by measuring the using compass. So you can measure that particular length, and we can cut the arc here. Okay, from 2 to 3, again from that 5 to 4. Okay, it's the same length it is. You can cut it, and we can mark that is 3 and that is 4. Okay, now we can join all these points. So again I will draw here one other vertical line here. Okay, so I'll be joining all these things with the straight line. So you need to dark this where we are getting the points, right? Exactly at these points we need to dark this. Okay, we need to dark this. So we need to join with the straight line using scale. Okay, I have to dark these particular points. Okay, need to darken all the edges. Okay, so that is what the development of the lower portion of the prism. Okay, cutted portion. So I'll be darkening this again, these vertical edges. Okay, vertical edges I am darkening here. Okay, here also this cutted portion. So in the front view also I am going to dark it. Okay, that is what the retained portion, cutted portion, retained, and this is what the lower portion of the prism. So that's why we are darking it. Okay, so that completes the development of the square prism. Okay, thank you. A regular pentagonal prism of height 60 mm and base head 30 mm given, rest 1 HP. A vertical face close to VP inclined at 30 degree to VP. So draw the development of truncated prism with its truncated surface inclined at 60 degree to its axis, and bisecting it. Bisecting means exactly middle point we need to consider. Okay, so first I am going to draw an XY line, writing VP, HP and Y. So here we need to construct a pentagon by considering a 30 degree angle line. With respect to that 30 degree angle line, so we need to place that our pentagonal prism. So take a reference point and mark for 30 degree and draw an angle line. Okay, so mention angle 30 degree. Okay, so here with respect to VP, close to VP and inclined at 30 degree. So now edge 30 mm we have to consider. So take 30 mm from the reference point. So take protractor and mark for 72 degree. We know that as external angle of pentagon it is 72 degree it is. So draw a line of length 30 mm passing through that angle point. Same way we have to do it for this side also. Keep the protractor in such a way that and mark for 72 degree and draw a line of length 30 mm passing through that point, because here pentagonal prism having a dimension of 30. Okay, so now take the protractor and cut the arc of 30 mm. So cut the arc. So we have constructed a pentagon here. So you can show the dimension on one side, dimension of 30 mm. So you can mention the naming because it is in prism having both faces, top face and the bottom face. So we can mention the naming here. Okay. So A1, top face A, B, C, D, top face, bottom face E1, B1, C1, D1 and E1. So that is not visible from the top face. So now we have to find out the center of the axis. So to find out the center of the axis in the prism, so we need to draw the perpendicular bisectors here. Perpendicular bisectors. So exactly passing the middle point. So from all these corners, so we need to draw perpendicular bisectors. So perpendicular bisectors will be drawn exactly from corner to the opposite middle point, opposite edge middle point we need to draw. Okay, we get center of the axis of this pentagonal prism. So now we will project it upward. Okay, to complete the front view of this. So draw the projection lines. Okay, from all the ends you can draw the projection lines. Okay, here line of length that is 65 mm. So we can 60 mm it is, sorry. So draw an axis for 60 mm. So all the edges will be having the same length of 60. Okay. So you can mention the namings for the top face and bottom face. You can see here exactly in axis point I think missed. So axis line we get it here. Okay, that is your edge point E1 dash. So we will dark that. Okay, now we are getting exactly O1 dash and O dash. Okay, now now we can show the dimension of 60 mm. You can show here. Now we have to consider the angle of inclination 60 degree. Exactly bisecting means exactly half, middle point of the axis we have to consider, middle of the axis. Middle point means if it is 60 means we should consider 30 mm. We should consider exactly 30 mm. Okay, so you can show the dimension here. So now here in this question, the axis will be having inclination of 60 degree, that is truncated surface. That is, from that axis we need to consider an angle of 60 degree. Okay, so this here it is a tricky question. Okay, from that axis point, truncated surface, we need to consider an angle of 60. Okay, so little bit different. So we can show the angle, you can show from the axis to the truncated surface. That's what the angle here. So you can mention the naming now. So where the section plane is cutting it. Okay, 1, 2, 3, 4, you can mark it. So with respect to these points, we need to draw the development of the truncated prism here. Okay, so you can just measure the length from the top surface. So 1, 1 we can cut it on A, then 1, 2. So from that is the length 2 from the B we need to cut, and the length of 3 we need to cut it on C. Okay, length of 4 we need to cut it on D. And length of 5 we need to cut it on E. So with the help of a compass we can measure the length and cutting the reference points. We can mention the naming 1, 2, 3, 4, 5 and 1. So now you can join all these points with the help of a scale using straight line. Okay, dark the truncated cut portion, the remain cut portion, we should dark it. Okay, so that completes the problem. We have a rectangular prism which is having a base of 14 to 25 and height 65 mm. So rest on HP on its base with the longer side, and it is inclined at 30 degree to VP. So first we draw an XY line and have taken a reference point. So keeping the protractor at that reference point, okay, marking at 30 degree. So you can see 30 degree to VP. So it is an rectangular prism we need to construct, and it is placing with the longer side. Longer side we have it, that is 40. So mark for 30 degree, okay, angle, and draw a line of length passing through this 30 degree angle point. Okay, and show the angle 30 degree. Okay, now on this longer side we need to consider 40 mm. To take reference point of 40, okay, measure 40 using scale 40 mm. Okay, so take a protractor and mark at this at this reference point, mark for 90 degree, exactly perpendicular, mark for 90 degree. Okay, again the another reference point also you keep the protractor and mark for 90 degree. Okay, draw two perpendicular lines here passing through that point, but it has to be have a length of 40 mm. Okay, 40 mm is 4 centimeter from the scale, and sorry, it is 25. So 25 mm you have to draw. Okay, so now join it. So it is 40 by 25 rectangle. Okay, show the dimensions. So dimension 40 mm. Okay, here we have 25. Okay, length of 25 it is. Okay, now we'll be marking the namings for top face and bottom face. A, B, C, D it is for the top face. E1, B1, C1, D1 for the bottom face. Bottom face not visible, that's why it is in bracket. Now we draw the diagonals to find out the center of the axis of this rectangular prism. Okay, that is O01. Okay, now we'll project the projection lines to draw the front view. So draw the projection lines here. From all these points we need to draw the projection lines here. Okay, so now on the axis we have to show the length of 65 from the axis. So that is height of 60. So draw an axis line here. Okay, and the remaining edges also we will construct it for 65. Okay, then join it. So you can show the dimension. So dimension of 65, that is axis height. So you can say it is cut by a section plane at an angle of 40 degree to HP, and it is exactly occurring at the midpoint of the axis height. So we have the axis height of 65. So exactly middle point means 32.5. So we need to mark on the axis line here. We need to mark for 32.5 here. Exactly, we need to mark for 32.5 at the midpoint of the axis. Midpoint it is exactly 32.5, half of the axis. Okay, so we'll show the dimension. Okay, so that is 32.5. Okay, now we have to take the protractor and mark for an angle 40 degree at this reference point. Okay, mark for angle 40 degree and draw an angle line passing through this point. So here we will be constructing a section plane. Okay, we'll extend the same thing. So we can show the angle here first. So angle it is 40 degree. So we'll extend this section plane for the downward side. Okay. Okay, now we need to dark the cutted remaining portion, which is cut by the section plane. The remaining portion of the rectangular prism, we need to dark this. Okay. Okay, now we need to mark the numbers here for the cutted plane. 1 it is occurring at A, and 2 it is occurring at again B. So C it is occurring at again at 3 it is occurring at, sorry, that's not correct. So it is occurring at point C, 3 point, cutting at C, and D it is occurring at 4 it is occurring at D, and then 5 we have. So now we will draw the development of this by extending the line. Okay, so here it is, we have 40 into 25, correct? 40 into 25. So first we will extend these lines, then using the compass we will cut each of these lengths. Okay, first I'll be cutting for 25, then I'll be cutting for 40, again 25, then again 40. So that's how we will cut the arc on that extended lines. So first I'm going to extend the lines here. So this is what our rectangle prism dimension. Okay, I'm extending the lines here. Okay. So first I will take the reference line. From here we will consider that is A. Okay, from A to B it is 25. We'll take compass, measure 25 mm from A to B. Okay, we'll measure this length from A to B. AB 25 it is. Again from B to C it is 40 mm. From B to C it is 40. Again C to D it is again 25. So you can measure either from the diagram or from that development surface. Again it is 40. D to A. So D to A again 40 it is. You can measure it from B to C only. That is also 40. Okay. So that is our A point. So now we will draw vertical lines connecting at this B point, B, C, D, A. Okay. We extend the lines here. Okay. We need to draw here. Exactly. Okay, after this, so we need to mark the naming here. 1, where it is the 1 it is occurring. Again, either you can measure from the top face or the bottom face. I am measuring from the top face. So the point number 1 here on A, and similarly point number 2 on the B. Okay, and point number 3 on vertical edge C. Okay, and point number 4 on the vertical edge D. Okay, again you can measure that point 1. So point 1 we have again it is on the 1, so it is nothing but 5 or 1 you can mention, no problem in that. So that is our 5. So now we have to join these points with a straight line with the help of the scale. So we have to join it. So join it all these points with a straight line with the help of the scale. To join all these points. And we need to dark this remaining portion of the prism. We need to dark this. So we have to dark it. Okay. So the remaining portion it has to be darker one. Okay, that completes the problem. In this problem they have given cube of side 40, and it is resting on the HP plane with its base such that it is placed such that its vertical face is inclined at 30 degree to VP. Okay, and it is cut by a section plane perpendicular to VP, inclined to HP at an angle of 45 degree, and it is exactly passing at middle point of the axis. Okay, so first we'll draw an XY line here. Okay, then from that XY line I will take a reference point. Okay, and draw 30 degree angle line with respect to VP. So take a reference point, keep the protractor and mark for angle 30 degree. Okay, mark for angle 30 degree and draw a line passing through that angle point. Okay, so mention angle 30 degree here. Okay, so we need to draw a cube of side 40. So cube of side 40 we have to draw here. So exactly at 40 mm we need to draw here. So 40 you have to mark. Okay, so when it is so these edges were exactly vertical. So I'll be keeping the protractor at these reference points and marking at 90 degree. Okay, marking at 90 degree because we need to draw a square. Okay, all the edges were exactly perpendicular. Again I am keeping the protractor at another reference point and marking at 90 degree. Okay, now you draw a line of length. Okay, draw a line of length Okay, after marking 90 degree, draw a line of length 40 mm passing through this 90 degree point. Okay, so vertical line you have to draw. Just draw a line of length 40 mm. Okay, here also, so you can draw a line of length 40 mm here. Okay, now we can join to complete the sketch. Okay, so you can show the angle. So the angle here we have taken 30 degree, right? So 30 degree we have taken, and you can show the dimension on one side. So the one side dimension will be 40 here. Okay, so we need to find out the center of the axis. So draw the lines passing through like diagonals we need to draw to find out the center of the axis. Okay, mention the naming. So cube is also one of the prism, so it is having both top face and bottom face. Top face notations are A, B, C, D. Bottom face notations are A1, B1, D1 within brackets. Okay, so now we have to project it to complete the front view. So draw the projection lines. Okay, so from the axis also we need to draw exactly vertical line from all the edges. We need to draw the projection lines here. Okay, here the axis length also 40 because it is in cube. Okay, it is in cube. Okay, it is also 40 mm. So first we will draw axis line 40, then remaining edges also we draw it for 40 mm. Okay, okay, that completes the front view. Okay, so we can show the dimension. So dimension here it is 40 mm, 40. Okay, now we have to show an section plane, cut section plane. So it is exactly 45 degree and it is occurring exactly middle point of the axis. So the total axis is 40. So half exactly middle point means we need to mark at 20 on the axis and then show the dimension 20 mm. Okay, show the dimension 20 mm. Okay, then take the protractor, marking at the reference point, mark for an angle 45 degree. Okay, now draw a straight line, that is cut plane, to that marked angle point. Okay, section plane we need to show where it is cutting exactly. Okay, so angle it is 45 degree. Okay, so now the cutted portion, the remaining cutted portion we will dark it. Okay, we will dark it. Okay, this is what the retained portion after cut by the section plane. So that's why we need to dark this one. Okay, show the axis line here or the section line which is cutting that, dark that one also. And now we will write the naming here. So one exactly cutting, we need to draw vertical line. So on the AB line it is touching it, where it is touching on the AB line. Okay, we need to extend this on the AB line. Okay, AB edge it is touching. Okay, same way. Okay, so we mark for 1 on the top view, same way. So we need to mark for 0.2. So 0.2 here we getting, again we extend it, we write 2. Same way we need to write for 3 here. So 3 here cutting on the BC. Okay, so that is the point 3, and then we have the point 4. Point 4 we getting here, and then point 5 we getting on the D only. Okay, so we write here also D. Okay, so marking of the points, so we have done. So now we have to draw the development of this. So extend the lines. So 40 mm into 4 sides means it is 160 mm total length we have to consider. First I will take a reference edge. Okay, from here exactly 160 mm we need to extend. Okay, the scale we have for 150 mm, so I will be extending by another 10 mm. Okay, so another 10 mm it will be extended. Okay, the same way we do it for the top face also, top edge. Extend for total length we need to consider exactly 160. So again I will mark for 150, extend by 10. Okay, now we have to cut the arcs for 40 mm. 4 arcs we have to cut. You can see, so total length of 40 we have to consider 4 arcs. 160 means 4 times you need to cut arc. First arc, second arc, third arc, and fourth one. Okay, now we have to draw the vertical lines where these arcs were cutted. Okay, now we need to mark A, B, C, D, A. Okay, now we have to mark this point 1 here. So 1 it is there exactly at a distance. We need to measure from the top view. You can see there from A to 1 we need to measure from the compass. A to 1 can measure and cut the arc. This is point 1. Okay, and now you can see that, so 2 it is there, so 2 we can measure it from the front view itself. So 1 to 2, so 1 to 2 on exactly on the B. So this is okay, and then point C we need point 3 we need to mention. So from C to 3 we need to measure. Okay, C to 3 you can measure that. This is point 3. Again we need to measure point number 4. Again I will measure from C to 4. Okay, C to 4 I will measure. C to 4. Okay, point 5 will be there exactly on the D. So I will measure from the top, from the front view, that length, and I am going to cut the arc, that is 0.5. Again 1 we need to measure, so 1 again I will be measuring from again A to here it is measured. Okay, whatever the length it is, mention again 1. Okay, now we need to join using scale with the help of straight line. So we can join it from 1 to 2 straight line, again from 2 to 3. Okay, actually that 3 and 4 point I need to mark on the top line. Okay, top line I am going to mark it. Okay, the point number 3 and 4 I need to mark it at the top end. Okay, so I'll be marking that. So because it is exactly cutting at the top face, it is cutting. So you can see that we need to just draw a vertical line at the point 3. So that is 3, and this is point number 4. So now we'll join it with the straight line. Okay. So then complete that whole diagram, that cutted remaining portion we need to dark it. Okay, we need to dark the vertical edges also, that is retained cutted portion, we need to dark it. Okay, so that's completes the problem. You can see in this regular triangular prism of dimension resting with respect to face parallel to VP near to it cut as shown in figure. Draw the development of the retained portion of the prism which are shown in figure. So this is what it is given in the question. Triangular prism of dimension 40, axis length 60. So it is cut as it is shown in figure. You can see the numbers here, how it is cutted and marked here. Okay, now we need to draw the development of this. This is the problem number 1 in the solution book. Okay, that point is A. Okay, so here it is a triangular prism, so it is having a dimension of 40. Okay, so it is having 3 sides, means 40 into 3 means 120. So 3 arcs I need to cut. So I can mention B, C and D and A. Okay. So it is done with the parallel line method. That is 1, and 2 we are getting at a height at a length of 18 mm. So we can measure from the top view. Okay, so you can see that the 2 we should get it above here. You can see on the front view we should mention that 2 exactly where it is there in the front view, 2 dash. So there we need to mention. Okay, this is where we need to mention this point number 2. Then 3 we get it here. Again 4 you can see that we need to measure that 3 to 4 length from the top view. So we should measure that and cut the arc here. Okay, and then so here 5 will be having here, and then again 6, 5 to 6 we need to measure from the top view. Okay, that is 6, and 7 we have it here downward. First I'll mark on the upside. The same thing I'll copy downside. Okay. First I'll be drawing the vertical lines here where we have marked 2, 4 and 6. We draw vertical lines, parallel edges. Okay. Now from here 6 to 7 we can mark. Okay, so next we have 7 to 8. So 7 to 8 also we can measure, but 8 it is there on the above. Yes, there it is. So you can measure it, 7 to 8. Okay, now we draw the vertical lines here. That is your 1. Now we'll join all these things with the straight line with the help of scale. Okay. So now I can join all this with the straight line from 1 to 2. Okay, I'll be drawing thick line using pen. Okay, 1 to 2 and 2 to 3. Okay, 3 to 4 and 4 to 5, 5 to 6, 6 to 7, 7 to 8 and 8 to 1. Okay, and we need to dark this wherever the numbers we have written, right? So from there we will be darkening it. So that's what the retained portion of this triangular prism. Okay, so we should dark those vertical lines where we have mentioned these numbers. Okay. This is what the retained portion. So we can mention the overall length here. So the overall length it is 120 mm. Okay. Okay, from A to B it is 40 mm. Okay. Okay, so this completes the problem here. Hexagonal prism of base side 20 mm and height 50 mm. So resting on HP on its base such that one of its edges parallel to VP. Okay, the prism is cut in this position as shown in the following front view. So we have drawn and it is given in the question. So it has been cutted like this. Now we need to draw the development of this lateral surface of the prism. Okay, so I will extend these lines. Okay, we'll draw in a reference vertical edge. Okay, so here the hexagonal prism of dimension 20. So 20 into 6 sides means in total 120 mm. So that means if we cut the arc by considering 20 mm means total 6 arcs we have to cut here. Okay, measure 20 mm, and cut 6 arc. Okay. Now you draw vertical lines for these all cutted arc points. Okay. Cutted the vertical lines. where we have cutted the arc points, right? We need to draw the vertical lines here. Okay. So now we can mention capital A, B, C, D, E, F, E, A. Okay. For the top face also we write A1, B1, C1, D1, E1, F1 and A1. Okay. So I'll mention it. So that is F1 and A1. We just correct it. Now here you can see already we have marked the point 1, 2, 3, 4, 5. For the top face it is 1. We need to measure from top face 1. We need to mark. Then again for 2 we cut it on the vertical edge B, and for the point C, point number 3, we need to cut it on the point C here, vertical edge C. Now on the point 4 it is here exactly at the end point of D1. So you can mention 1, 2, 3, 4. For the 5 again we need to measure, so that is exactly equal to 3. We already measured, that's why we cutting the same length. Then for the point 6, for F1, okay, and then exactly 1 we need to cut at the vertical edge A here. Okay, that is 1. Sorry, that is 1. Now again we need measure for the bottom face. Okay, on the vertical edge B it is 7. Now we need to measure for 8 on the vertical edge C. Okay, measure length from C1 to 8, and it has to be cut on the C. Okay, we need to cut it on the vertical edge C here. We need to cut it on the vertical edge C here, that is point number 8. Then 9 we need to cut it on the vertical edge D. Okay, and then 10. Okay, and then again 11. Okay, so that is 8, 9, 10, 11. So now we have to join all these points with the straight line with the help of the scale here. We have to join it. That is after 6, that is 1. You can correct that. Okay, that is 1. So now I have to join it from A here. Okay, A to 7, A to 7, 7 to 8, like that we need to join. Nine to 10, then 10 to 11, and then 11 to A we need to join. Now to dark these vertical edges. This is what the retained cut portion, okay, of that hexagonal prism. So we have to dark this. Okay, so that completes the problem. Okay, now we will develop a pentagonal pyramid of side 30 mm and axis length 50. So using radial line method. Okay, so we are going to develop that. So how we are going to develop, you can see in this problem I have already drawn the top and front view of a pentagonal pyramid. Okay, you can see here, so this is the true length, that is this length, that is O dash D dash. Because why it is true length means, you can see the end OD, it is parallel to this XY line. Okay, so parallel to this OD XY line, that's why this O dash D dash is the true length. So what we have to do in this problem is, first I will take one reference point here. Okay, here. Then after that I will be measuring this length, that is O dash true length I will consider, because we know the development of any of the solids we have to do with the true length. Okay, so I'm going to construct this, cut the arc. Okay, this is what the length, right? So that is from here to here. This is the length, true length. Now after that, what we have to do, so using compass, we'll be measuring this length, okay, and then we'll be drawing a small thin line, okay, like this. Then after that, as we know that, so this each of these edges were 30 mm, so we'll be measuring 30. So any one of the edge you can measure, so that is 30. From here you can cut it for 5 points. So we can extend this, no problem. Okay, so 1 2 3 4, another line, so total 5 faces. We can extend it. Okay, so 1 2 3 4 5, so totally 5 faces we get it here. So now after this, what we have to do is we have to join these points. Okay, so you can see we have 5 faces because it is in pentagonal pyramid, 1 2 3 4 5. So after this, what you have to do is we have to connect these end points with the straight line, okay, like this, because it is a pyramid. Okay, and then rub this curve, okay, which we have drawn in the beginning. So we have to rub it. Okay, now we can give the naming. This is A, this is B, this is C, this is D, this is E, and again E. So this completes the pentagonal pyramid, that is development of pentagonal pyramid using radial line method. Square pyramid of base 40 mm side and axis 60 mm line. Length has its base on HP, and all the edges of the base are equally inclined to VP, means we need to construct with the corner position here. So it is cut by an inclined section plane, so that the truncated surface at 45 degree to the axis. By bisecting it, draw the development of the truncated pyramid. So bisecting it means exactly middle of the axis it is cutting, that is 45 degree section plane on the axis. So first we draw an XY line here. Okay, so we will be constructing a square with respect to corner position here. So for that I will be taking a protractor. First I will take a reference point. Okay, so from that reference point I will be marking at 45 degree on both sides. I will be marking 45 degree on both sides. Okay, then I will be drawing a line of length 40 mm here, passing through that angle point on the both side. Then after that I will be drawing a line of length 40 mm, so passing through that 45 degree angle point. Okay, then I will take a compass, measure 40 mm, any one of the length we can measure it, and we can cut the arc. So 2 arcs we can easily cut here. and then join using scale here. And you can show the dimension on one side. Okay, the dimension here it is 40 mm. Okay, you can mention the naming ABCD. It is having only one base ABCD. So connected with the vertex by means of slant edges here. So I'll be drawing slant edges. So these inside lines has to be thick lines. Okay, thick lines O1. Okay, now you project it upward to complete the front view. So here the axis length we should consider, that is 65 mm. Okay, 65 mm long. Okay, so exactly from that corner point we need to join here. So exactly to that axis end point we need to join. Okay, so it is of length, axis length 65. We can show that. Okay, now we have to show the inclined section plane, that is exactly cutting, bisecting it means exactly cutting at the middle point here. So you can see that. So it is making as a truncated surface. Bisecting it means exactly middle, it is cutting the axis. So 65 means 32.5 we have to mark. 32.5 we can mark, and we can show the dimension here. Okay, .5. Okay, and we can show the angle. So the angle here we consider 45 degree. So draw a line passing through that point. Okay, here we are drawing that section plane. So cutting. So I can mention the angle. Angle it is 45 degree. Okay. So we need to dark the retained cut portion of the pyramid. So it is forming like a truncated surface. Truncated means cutted portion. So here we have left out with the cutted portion. The truncated surface we need to dark. Okay, which is cut by that section plane. Okay, now we have to mark the numbers here by cutting the section plane. So 180 is when we project downward, it is cutting on the slant edge OA. So that is our point number 1. Okay, so it is a slant edge surface, that's why we need to do like this only. And then for the point number 2 we getting here. Okay, on the slant edge B. And then we have next point 3 and point 4. So point 3 we can get it easily just by projecting downward. We get it on the slant edge OC. Okay, that is our point C. Okay, but for point 2 and 4 we are not getting on the exact slant edges. So for that we will be drawing a line from this 2 and 4 to this slant edge. Okay, slant edge we are drawing it, and then projecting downward from that point. Vertically downward we need to project it downward. Okay, so this is the distance we got. So after getting this distance we have to take compass, measure the distance and draw an arc or a circle, you can say that. Okay, draw an arc on the slant edges of OD and OB. So I will be drawing like an half circle. So that particular arc is cutting OD and OB slant edge. So here we get the point number 2 and point number 4. This is where it is cutting. Now from the top view, so we can show how it has been cutted with that section plane. So now we are getting the truncated portion. You can see that clearly from the top view. So we need to join this 1, 2, 3, 4 with the straight line using scale. Okay, so that's what the top and front view. Now we need to draw the development of this truncated pyramid. Okay, first we need to identify the true length. So here the true length, it is, you can see from the top view OC it is parallel to XY. That's why O dash C dash is our true length of line. Okay, we need to measure how much it is length. We'll show the dimension here. So if you just measure the length, it is around 70 mm. So you can measure that and write down there. Okay. Okay, now for this 70 mm true length, we need to construct. So take a reference point, anywhere you can take. So first, so this is nothing but our true length. So we need to draw for the true length. Okay. So that's why we consider O dash C dash here, not the axis length. So we'll be drawing for 70 mm now. That's what the true length. One line I will draw. Okay, then I will take the compass. So measuring for 70 mm, measuring for 70 mm. So that particular, and then I will be drawing an arc here, or a semicircle, you can say that. Okay. So here after drawing this semicircle, so we need to cut it. So we need to cut it for exactly 40 mm because the base edge it is 40, and we need to cut, it is a square pyramid, so we need to cut off 40 length for 4 arcs here, 1, 2, 3 and 4. So totally 4 arcs we have to cut it here. Okay, so now we can join using scale, we can join it. So these are nothing but your slant edges and the true lengths. Okay, OB, OA, OC and OD. These are nothing but your slant edges. There are totally 4 slant edges we are getting here. Okay, so you can join this with the straight line here also, because it is a square pyramid. All the edges were straight here. Okay. Okay, after completing it, so we will erase this semicircle which we have been drawn, okay, as a reference to construct this truncated pyramid. So we will erase it. Okay. So now we can mark the naming now. So this is A, B, C, D and A. Okay, that is O. So we need to mark the length. Okay, this is what our true length, we have been drawn for the true length here. Okay, now we have to consider that O1, that is O to 1, O dash and 1. So I will consider all this 1, 2, 3, 4 on that true length, O dash, C dash. Okay, I will consider that length, but just drawing that 1, a horizontal line from that 1 to till it touches the C dash, O dash, C dash. Now we'll measure the length using compass from O dash to 1. Okay, cut the arc, and then O1 on OA will get 1 only. So that's why I've cut 2 arcs. Then O2, that also we need to consider on the true length only. Okay, not on the axis. Just see that already we have drawn a straight line from the point number 2 and 4 on the true length. So that length I am considering, not on the axis. So this is very important. And then again you can consider it from O to 3, that is already there on that true length. Now we can write 1, 2, 3, 4 and again 1. Okay, so So you can join using straight line with the scale. You can join this. Okay, so now you can dark that truncated remaining portion. So we have to dark this. So dark the truncated pyramid, so the left out portion. Okay, we need to dark this. Okay, those slant edges also we need to dark in the truncated portion. Okay, so that completes the problem. Welcome to engineering visualization channel. So now today problem number 18. The square pyramid of base height 45, altitude 70 mm is resting with its base on HP with the two sides of the base parallel to VP. So first we are going to construct the square pyramid of base height 45 mm and altitude. Altitude means it is nothing but height, height of the axis. Okay, it is 70 mm, height of the axis 70 mm, resting on HP with two sides of the base parallel to the VP here. Okay, first I am going to construct an XY line. Drawing XY line. And write VPHP, that is your first quadrant, and construct a square here. So the base parallel to the VP. So dimension here it is 45 mm, exactly at 90 degree we can do it. Construct the square and give the naming ABCD and show the dimension of it. Okay, so the dimension of the square pyramid it is 45 mm. So here it is parallel to VP, that's how we have drawn. You can see that edge DC and AB are parallel. AD and BC are parallel to VP. You can see all the edges here are parallel only, that is AB and DC. Now draw the slant edges. Since it is a pyramid, we should draw the darker line here, that is thick lines we should draw since it is a pyramid. So in pyramid we should draw the thick lines. Okay, inside lines should be darker lines here, thick lines should be drawn. So connect from B to D and A to C and mention O1. Okay, now project it upward to draw the front view. So in the front view we have to consider the altitude. Altitude are nothing but the height. So here it is height of 70 mm. So draw the front view. So front view of a pyramid, it is a triangle. Okay. So here the height, it is 70 mm. You can show the dimension. Okay, now we have to show the cut plane. The pyramid, it is cut by a section plane which is perpendicular to VP and inclined at 40 degree to the HP. Okay, and this cutting plane is bisect the axis. Bisect the axis means exactly you have to consider the midpoint. So bisect means it is nothing but midpoint. So midpoint of the axis here, the axis length is 70. So exactly half midpoint means it is 35 mm. So mark at the midpoint. Okay. Show the dimension here. The midpoint height, it is 35 mm. And we have to draw an angle line for 40 degree. And we need to extend that because it is exactly cutting at 40 degree angle. Okay, I'll be showing the angle there. Hit on the like button, subscribe to my channel, share it to maximum students so that they can be benefited. Can write the cut points now. 1, 2, 3, 4. One cut point is cutting at a slant edge of EO, 2 it as BO, 3 at CO, and 4 at DO. Okay. Now you see here, none of the slant edges here are not parallel to the XY line. So we have to make parallel here. Okay. None of the edges, either you can see AO or BO or CO or DO, none of the slant edges here are not parallel to the XY line or parallel to the VP plane. So what we have to make, we have to take any one of the slant edges and we have to make it parallel to this XY line. So take the compass. First I will draw one horizontal line and measure the length of BO, that is slant edge BO. I am making that BO slant edge parallel to XY. Measure the length and cut an arc. Okay. So now making it parallel to the XY line. Okay. Parallel to the VPR, you can say that. Now project upward till the XY line. Now from that XY point of intersection, join to the apex here. So this is what your slant edge length. Okay. Now measure the length. How much you are getting it? Measure it. It is 77 mm. So that is what your slant edge length. Okay, first I will be drawing that slant edge length. Okay. That is 77 mm. Show the dimension. That is OA. Now measure this length using compass and draw an arc here. Now we have to cut the arc points with the dimension of 45 mm. Here it is a square pyramid, that means total 4 arcs we have to cut from the reference point of A. One arc, second arc, third and fourth. Okay, and you can write down this as B, C, D and A. Now join all these cut points, join to the reference point A, O here. Draw a straight line from where you have cutted and marked. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. Now draw the base edge. So base edge it is 40. So connect all this with a straight line. So you can show the dimension for one base edge, that is 45 mm. Okay. Now I am transferring all this point number 1 and 1, 2, 3 and 4 on the slant edge length. Okay. So from the exactly cut point, draw the line. The cut point, that is 2, 3, this is 1 and 4. Okay. Now take the compass, measure the length. 1 and 4 having the same length, so that's why I'll measure only one length here and cut arc on OA, OD and again OA. Okay. That is your 1 and that is 1 and 4. Now 2 and 3. 2 and 3 are on the same point. We'll measure the one length here and cut it on OB and OC. That is 2 and 3. Now we have to connect all this 1, 2, 3, 4 with a straight line. Okay, now we have to dark this lower cut portion. Okay, I'm going to dark it. Hit on the like button and subscribe to my channel and hit on the bell icon for the latest notifications, and share it to maximum students, your classmates, so that they can be benefited from this channel. Thank you all. Thank you for watching the video. Square pyramid of dimension 25 and height 50 mm we have to construct. So rest with its base on HP with all of its edges equally inclined to VP. That means we need to construct with respect to corner here. It is cut by a plane perpendicular to VP, inclined at 60 degree, passing through extreme right corner of the base. Okay, so that's what we have to do. First we need to construct a square with respect to corner, because they have mentioned with all of its edges, base edges equally inclined to VP. That means we need to construct with the corner here. First we draw XY line, VP, HP, first quadrant. So now with the help of the protractor, so I'll be marking a reference point. So from this reference point we can mark for angle 45 degree on both sides. Okay. Now I'll be drawing a line of length at 25 mm. So from that reference point to that angle point. So draw a straight line of length at 25 mm. Okay, so in this side also we need to draw line of length at 25 mm. Okay. So again you take compass, measure 25 mm and cut the respective arc from this reference edges. Okay, then join it with the help of scale, this straight line. Okay, so that completes the square. So it is a square pyramid. So we will be drawing thick lines, inside thick lines as a slant edges. Okay, so mention the dimension on one side. So dimension will be 25 mm. Okay, so 25. So mention the naming A, B, C, D. Only it has having bottom face, O1, center of the axis. So project upward to complete the front view. So here axis length it is of 50 mm. So draw a vertical line or axis for 50 mm. Okay, now we can join with the slant edges. Okay, show the dimension having 50 mm. Mention the naming A dash, B dash, D dash in bracket and C dash, O1 dash and O dash. Okay, so now we have to mention that cut plane or the section plane. So it is extreme right corner, that is C point is the reference, extreme right corner, and from this point we need to mark for an angle of 60 degree. Okay, 60 degree. Take protractor and mark for 60 degree from C dash and draw an section plane passing through this point. Okay, so here the angle it is 60 degree. Okay. Now dark the retained portion. Okay, the cut portion, the remaining cut portion we need to dark this. Okay, now we will be mentioning the cut plane namings 1, and if we project it downward it is cutting with respect to the OC edge, slant edge 1. Now the point number 2 and point number 3 it is exactly at the C dash only, that is point 3, cutting the extreme edge 3, and point 4 exactly it is at 2 only. So now we have to mention 2 and 4 exactly where it is occurring on the slant edge. So we will be drawing a straight line, that is slant edge for that true length O dash C dash slant length. Then from the 2 and 4 we will be drawing vertically straight line. We don't know exactly where it is cutting. Okay, so we can measure the length from that, then draw an arc or a semicircle to the OD and OB. So you can cut the arc. Okay, so that is our point 2 and 4, and this is point 3. Okay, you can join these points 1, 2, 3, 4. So that indicates that cutted portion, how it is cutting with that okay, section plane. Okay, so now so the true length we having OC it is exactly parallel to XY line. So O dash C dash is our true length. So we need to measure this length. So it is, so you can see OC is parallel to XY, and O dash C dash length, it is around 52 or 53 mm. It is, I think it is around 52 mm. So dimension, so we can mention that 53 mm. So this is true length. Okay, this is what the length we have to consider to draw the development. So take a reference point and draw a line of length 53 mm. Okay, that's what the true length. And that is O and A. Okay, so this is true length. Now we take compass and measure this length, true length, and we will draw an arc array. Okay, so now we measure the edge here, 25. So 25 is the base edge, and we need to cut 4 arcs here. Okay, 25, 25, 25 and 25. Okay, now we can join with the slant edges. So that is B, C, D and A. Okay, so I can show the dimension. So dimension here we have 53, and that is true length. Okay, so we should not consider the axis for this, we should consider the true length here. Okay, so now you can see, so we have to mark these cutted points 1, 2, 3 and 4. Okay, so we'll be measuring. So taking on the O dash C dash point 1. Okay, O1, so O dash 1. So cut the arc. So we have O, we can cut on the 2 points. Again O2 now. So we have considered this length on the true length. Okay, 2 and 5 having the same length. Okay, 2 and 5. And then O dash and 3. And it is cutting exactly at the 3 point here, at a C point. Okay, that is 1, 2, 3, 4, and this is 1 again. Okay, now we have to join all these, connect this point with the straight line. So now we have to join this. So now we have to dark this retained cut portion. Okay, so we have to join this ABCD also with the straight lines. Okay, now we can dark that retained cut portion. So we need to dark this. Can dark this cutted portion. Okay, the retained portion we need to dark it. Okay, which has been cutted, and then you can erase that arc which have been drawn. Okay, so that completes the problem. Welcome to Engineering Visualization channel. So the next problem, it is a rectangular pyramid of base side 25 into 40 and height 50 mm, has one of its base edges is inclined at 30 degree to VP. Draw the development. So here you can see they will be giving the front view. Using this top and front view, we have to draw the development of it. So in this problem they will be giving everything. So looking at the top and front view, so we have to construct the development here. So first I will be constructing the slant edge length here. So slant edge length of length 55 mm. Okay, after drawing the slant edge length, okay, you measure the same length using compass and draw an arc. Okay, now we have to show the dimensions for this length. So it is having a length of 55, slant edge length. Okay, now we have to cut according to this rectangular pyramid. So AB length it is 25. I am measuring from the top view and cut the arc. So this is B. Now from B to C, okay, or B to E, it is there from the diagram. B to E it is 12.8. So measuring the same length and marking E here. Now measuring the length of B to C. So B to C measured from the top view, it is 40. Mark C here. Now measure the length CD. Measure the length of CD. CD length it is 25 and cut the arc. Okay. Again measure the length of DA here. So DA length of 40 mm and cut the arc. Okay. Now the another point we have left, that is D to F. Okay, D to F 12.8 again. So cut it. Okay, now we have to join all these points with the reference point here. Use the scale to join all these points. With the help of the scale you can join, connect with the straight line. These are nothing but your slant edge lengths. Connect it. You can see point number 1, 2, 3. So that is on the A line and the B and the E slant edge. It is of same length. Okay. So measuring the same length, so and we can cut it. And point number 2, it is then on our slant edge of B. So it is also of the same length. So measure and cut. In same way, point number 3, it is there on the E here. So measure the same. It is also of the same length. That is 1, 2, 3. Okay. Measure and cut it. Now point number 4. Okay, point number 4, it is lying on the slant edge of C here. Measure that length and cut the arc. Okay, that is your point number 4. And now point number 5. Point number 5, it is falling on a vertical edge of D here. Measure the length and cut the arc. That is your point number 5. And now point number 6. Point number 6 are also having the same length and it is falling on the slant edge of F. Okay. Measure the same length on the slant edge and cut the arc. Okay. And then again point number 1 having the same length. We cut with the same arc length. Okay. Now we have to connect all these 1, 2, 3, 4 with the help of scale. Join all these points here, connect it, connect all these points with the help of the scale. Okay, connect it. Okay. So since it is the development of the lower cut portion, we are going to dark the lower part here. So dark all the slant edges with a thick line. Okay, connect all this lower portion. So join the base heads here. Okay, so now we can mention the dimension here. So from A to B it is 25 mm. Okay, mention the dimension. And from B to C it is 40 mm because it is the development of a rectangular pyramid. 40 mm. Okay, that's complete the problem. You can subscribe to my channel and hit on the bell icon for the latest notification and share it to maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Okay, hexagonal pyramid, dimension 35 and altitude 65 mm, resting on HP on its base, with the two of the base sides perpendicular to VP. And pyramid is cut by a plane inclined at 30 degree to HP and perpendicular to VP, and it is intersecting the axis at a height of 30 mm above the base. So draw the development of the remaining portion of the pyramid. So first we need to construct a hexagon here. So for that I will be constructing first XY line. Okay, XY line, and using circle method I will be constructing a hexagon. So dimension I need to measure, that is 35 mm, that is 3.5 centimeter. Using scale with the help of a compass I will be constructing a circle. Okay. So you can draw a vertical line from that center point. It's like radius. So after that already we have measured 35 mm from the compass. So we need to cut 6 arcs here. Okay, now connect all these arc points with the help of a scale. With straight line you can connect all these arc points. Okay, and show the dimension. So dimension here it is 35 mm. So you can mention the naming A, B, C, D, E, F. Okay, and you can erase that circle, so which we have been used to construct the hexagon. Okay, so since it is a pyramid, so we will be drawing diagonals to show the slant edges. Right, one. So now you draw the front view of this. So the altitude height is 65 mm. So we should consider a length axis height, it is 65 here. Okay. So connect it. Okay, you can mention the naming here. Okay, so show the dimension. So dimension, it is 65 mm. Okay. So, and it is cut by a plane inclined at 30 degree to HP and perpendicular to VP, intersecting the axis at a height of 30 mm from the base. So from the base we should consider a length of 30 mm. So take a reference point. So keep the you can show the dimension for this. Dimension of 30. You can keep the protractor here and mark for angle 30 degree. Okay, so now you can draw an section plane passing through this angle point. Okay, so now we have to give the so naming for it angle 30 degree we can show here. So dark that cutted portion, so which is cut by the section plane, so dark this. Okay, now we can mention the namings here. So mention with the section plane 1, 2, 3, 4, 5, 6. You can see that none of these slant edges are parallel to the XY line. So we need to rotate this OD length. You can see that OD length is not parallel to XY line. So first I will draw an horizontal line. Now I will take a compass OD, measure the length OD and draw an arc. Okay, because none of the edges were parallel here, so we don't get a exact true length, so that's why we have to do like this. So project it upward. Okay, here we get the true length of this hexagonal pyramid. So now join it and show the dimension, measure the dimension, show it how much it is. That is what your true length of this hexagonal pyramid, because none of the edges were not parallel here. So dimension we getting here for true length, it is 73 mm. So that is what true length. So here first you take a reference point. Okay. So now you project all these 1, 2, 3, 4, 5, 6 points on this true length which we have been generated now. So just project the horizontal lines touching the true length. So this is what the length we need to consider when we cutting the arc points. Okay, take a reference point O, measure the length of 73 mm. So draw a straight line 73. Okay. Okay, OA. So take a compass, measure this OA length and draw an arc. Okay, so now we have to cut an arc from that A point 35. Total 6 arcs we have to cut. You can measure any one of the length from the hexagon. So 35, you can cut 6 arcs here. Okay. Okay, now we can join it, this arc point with the straight line. So you can extend a little bit this. Now you join all these cut points with the straight line. Can mention the namings now: B, C, D, E, F and A. So now we have to measure the length using compass. So you can join this ABCD point with the straight line with the help of scale, because this is a hexagonal pyramid. Okay, we need to join this with the straight lines. Okay, now we can cut the arc. So you need to measure from the true lengths. Okay, that should remember, from O to 1, O to 1 and O to 6, these two lengths are same. That's why I am cutting two arcs. Then again you measure O to 2 and O to 5, these two lengths are same. You can cut the arc on B and F. Okay, then you can cut the arc length, that is 3 and 5. Okay, 3 and 5, sorry, 3 and 4 you can cut. Actually this 6 and 1 are same length, so I think there is mistake. So on the F line, so we need to cut an arc of from O dash to 6. Okay, O dash to 6 we need to measure again, so we need to correct it. So that is the 6, so that is the 5. Okay, now we can mention the namings here, 1 1, and this is 6. Okay, and that is 5, that is 4 3 2. So now we have to join all these 1 2 3 4 with the straight line with the help of scale. You can join it. Okay, so connect all these points, the straight line. Okay, dark all these vertical edges and the cutted portion of the pyramid, we need to dark it. Okay, so that completes the problem. So in the problem, pentagonal pyramid given 30 mm and 50 mm height, rests vertically with one of its edges parallel to VP. So we have constructed it is parallel to VP and near to it. You can see it is parallel. It is cut as shown in the following figure. You can see that it has been cutted here. You can see here edge OC, it's not parallel, so we have to rotate and make it parallel here, and then it projected it will get the true length here. We don't have any true length here, so none of the edges in the top view, that is OC, OB, OD, are not parallel here. So we have to make it parallel by rotating OC. Okay, rotating OC, making it parallel, and then project it upward, rotating OC to make it parallel here. In this problem we have made it parallel, and then projecting it, we are getting the new true length here. Okay, new true length. On the true length we have been projected 1 2 3 4 5. Okay, first take a reference point and construct the true length here. Okay, so here the true length, it is 56 mm. Okay, take compass and draw an curve or the arc. Okay, so measure 30 mm, measure any one of the 30 mm edge and cut 5 arcs here, because it is a pentagonal pyramid, so you can cut 5 arcs. So you can extend that curve. Okay, so total 5 arcs you have to cut, because it is in pentagonal pyramid. Okay, now connect with this with the vertical edge. Okay, Join these all these arc points, the straight line, because it is a pyramid. Okay. Now here is that curve. Okay, so you can mention B, C, D, E and again E. So we need to measure the arc length, the new true length which have been drawn. Okay, new true length 1, 0, 1. So you can cut two arcs here, 0, 1 on OA and 0, 2. Okay, you can measure it exactly on the true length and the new true length which we have been drawn by rotating the OC line. Okay, that is 1, that is 2. Okay, and 3 we get it on exactly on C point here. Okay, exactly on the C point, extreme corner point. So you can mention that. So that is C, that is 3. Okay, on D we have point number 4. We can measure it using compass. Cut the arc, that is 4. And then on 5, so we've been projected this 1, 2, 3, 4 on the new true length which we have been drawn. From there we are measuring the length. Okay, so that's not the slanted, we have drawn the new slanted, that's what your true length. Then you can connect all these points with the straight and with the help of the scale. So join all this. So now we can dark. So this is what the retained upper portion. Okay, you can see that particular portion I am darkening it, so we have to dark it. Okay, development of a cylinder of diameter 50 mm and height 50 mm. So this one will be drawn using parallel line method. Okay, so initially, so we are going to consider here line as a reference. Then I will take a reference point here. So the length of this we should consider, that is pi d, that is circumference of this cone we have to consider, that is we will open up, so it will be a sheet. So pi d, so pi we have diameter is 50, so it is 157. So from this end if I consider, so this is 150, 157 means here extra 7 mm. Okay, so till here, so we can mark. So we need to draw a line till here. Okay, okay, so this total length it is pi d, that is circumference. So this completes the problem. Draw the lateral surface of the cylinder of diameter 40 mm and height 60, which is cut as shown in the figure. So we need to draw the development of this. Okay, we'll extend these lines. So it will be drawn with the using parallel line method. So first I will draw an vertical line as a reference from where we will start. Okay, that is our A. Now I will take a compass, measure this length. Any one of the length you can measure from A, B, or A from B to C. Measure any one of the length and you can cut the arcs. You can mention the namings here. And from H to A also we need to mention. Okay. Now draw vertical lines. Okay, so now you can see that we should mention these namings. Okay, actually the namings will be starting from that C point, not from that E point. Okay, I think that is the mistake there. Okay, so actually the cutting actually occurs from this C point. Okay, 1, 2, and it is occurring only with respect to that C edge. Then 3 on the D, and we have 4 on E, and again 5 on the 6, and then 7. So the 7 we exist on that G point only, so not on H. So you can mention that point number 7 also on that G line only. Okay, so now you can join these things with the vertical line or with the curve. Okay, you can join a vertical cylinder of base diameter 50 and axis length 60 mm is cut by two planes which are perpendicular to VP and inclined at 45 degree to HP, passing through either side of the center point of the top face. Draw the development of the lateral surface of the cylinder. So first we will draw XY line. Here in this problem we need to construct a cylinder here of diameter 50, axis length 60. Okay, so take a compass, measure 25 mm from the scale. Okay, Measure 25 mm from the scale and draw a circle. Okay, now we need to cut this circle into equal parts. Okay, first I'll be drawing a diameter horizontally, then vertically. Okay, now I will take a protractor and mark for angle 30 degree, 30, 60, 90 like that. I will mark 30, 60, 90, 120, 150. Okay, so now with the help of a scale I will be drawing a straight line passing through this angle point on both sides. Okay, so it is totally cut into 12 equal parts, so that means 30 degree. 360 divided by 12 means 30 degree. Okay, here also I will draw a line passing through this angle point. The same way here also I will do. Here also for 150 degree. So I will be drawing a line, angle line. Okay, so now I can give the naming. A, B, C, D, E, F, G, H. So mention the namings. Okay, so you can show the dimension of this circle on one side. So diameter 50. Okay, now we have to project it upward to complete the front view. So front view will be a rectangular face. Front view of a cylinder, it will be a rectangular face. Okay, consider a axis length of 60 here. Can mention the naming in the front view, which are the face visible, that will be written within bracket. So which are the faces not visible, that is written within bracket. Okay, here now we have to draw two planes, so which are perpendicular to VP and inclined at 45 degree to HP. So there are two section planes we have to do. So it is exactly from the center point of the top face. On either side we have to mark at an angle of 45 degree. On either side we have to do it. Okay. So draw now the section planes. Okay, so mention the angle 45 degree. Here also you do the same thing. Okay, and give the naming for the section plane where it is cutting with respect to the vertical edges. We will mention with the numbers here. Okay, so we'll start from 1 2 3 4 5 6 7 8 9 10 11 12. So we will extend this. So this is also drawn with the true length of line. So parallel edges. parallel line method it is. So we'll extend from the bottom also. Okay. So we can take a first vertical edge from A. We can measure that what we have cut it with respect to 30°, right? So we should cut it. So that is A point. So one length you measure and cut the number of arcs, because each of these arc lengths were same. Okay, from AB to BC, BC to CD, all lengths were same here. So you can mention the namings here. At the end also you mention A. Okay, now we draw vertical lines here. Okay, now we have to measure from the compass that points 1, 2, 3, 4 is there, right? We should measure that. So measure all that 1, 2, 3, 4 arc points, okay, from the compass and cut on the respective vertical edges. So again, so 8, 9, 10 points also, and you should measure that and cut the arc on the respective vertical edge. You can mention the naming. So now connect these all these 1, 2, 3, 4 points with a curve here. We need to use curve here to join it. So that completes the problem. A vertical cylinder of base diameter 45 and axis length 60 is cut by a plane perpendicular to VP, inclined at 50 degree to HP, passing through the center point of the top face. So draw the development of the lateral surface of the cylinder. So draw XY line. We need to construct a circle. The diameter given 45. So we need to take radius of 22.5 from the compass and draw a circle. Okay, from the center point, I'll be drawing a radius. Then we can extend this as a diameter. So we will be dividing this circle into 12 equal parts. Okay. So initially I am going to divide into 4 equal parts. Okay, now we use the protractor, keep at the reference point and marking for an angle of 30 degree, 30 degree, 60 degree and 90 degree like that. Okay, 120 degree and 150. We can draw the lines passing through these points. So we can extend it. And we can mention the naming for this. Project the lines from all these points. Now use the axis length of 60 mm, 60. So now draw a rectangular face here in the front view. It is a cylinder, so that's why we get a rectangular face here. So you can mention the namings. Okay, you can mention the naming here. Okay, you can see here exactly at the top face center we need to So you can show the dimension. So dimension of 60. So here axis, we need to draw an section plane of 50 degree exactly from the top face. From the center of the top face, we give the protractor and mark for angle 50 degree. Okay. Draw a section plane passing through that angle point. Okay. You can extend where it is cutting. You can show that angle here. It is 50 degree. So you can mention the numbers here where it is cutting exactly. Okay. So draw vertical edge. So from here we will mention E. So take the compass again. So measure the length from AB. Any one length you can measure. So we need to cut total 12 arcs here. Now draw vertical lines where we have cutted the arc. So you can extend the line from these 1, 2, 3, 4. That is also one of the way for mentioning. So draw the thin horizontal lines and extend. So 1 we are getting on this vertical line AA. Same way we can do it for the point 2. Okay. Or we can use the compass here for measuring these lengths, so we can cut it easily. Same, we can cut it all the arc lengths here. So mention the naming of these notations. join all these numbers with the help of the scale in straight line. So wherever there is a straight line, we can join it with the help of a scale. Actually it has to be joined with the curve here, so we can join with the straight line here, no problem. And dark this cutted portion, and we need to dark this. Okay, so that completes the problem. Welcome to engineering visualization. Today we see a funnel problem. So here in the question, funnel is made up of sheet metal. The funnel tapers from 60 to 30 mm diameter to a height of 25 mm and then forms to a cylinder with a height of 50 mm. Bottom of the funnel is beveled off completely at an angle of 45 degree to axis. Beveled off means we need to cut it with an angle of 45 degree from one of its corner. So draw the development of the funnel. Okay. So step by step we are going to do. First we are going to construct the top part of it, that is funnel made up of top diameter 60 and the bottom one 30. So tapered section I'm going to do it first. Okay. So mark a length of 60 mm using scale. Okay, now vertically downward, the height we should consider that will be 25 mm. Okay, from the center of the line, I will be drawing vertically straight line downward at a length of 25 mm. That is 2.5 centimeter from the scale. Okay. Okay, now from this midpoint, so the bottom part we required that should be 30 mm. So this is exactly 60. From the center we have drawn a line. Okay, from this center we will be drawing 30 means here from the center I will be considering 15 on both sides. Okay. Okay, now we join it. So this is a tapered section of the funnel. Now you can show the dimensions. So the top part having 60 mm diameter. Okay guys, this is my 700 video. So I'm very much thankful for my viewers for their continuous support. Okay, so personal dimensions. So the height also I'll show. The height is 25 mm. Now the lower part it is a cylinder. Okay, cylinder with a height of 50 mm. So funnel it is done. Cylinder of height 50 mm. Okay. Can show the dimension for it. It is 50 mm length. Now we need to cut this lower part of the cylinder at an angle of 45 degree. You can see the question. So bottom of the funnel is beveled off completely at an angle of 45 degree two axes. Okay, that is from one end. So we need to draw an angle line, and that should be at an angle of 45 degree. So take the protractor. Okay, mark to the one of its corner end. Yes, we should be marking one of corner end. So mark an angle of 45 degree. Okay, now draw a section line, cutting it. To show it section line, I'll be using different sketch pen. Line dot line. Okay, so it is exactly cutting at an angle of 45 degree. Okay, now we need to construct the top view of this cylinder. Okay, in order to show the cutting, it will become very easy. Okay, so the upper part of the funnel, right? So when we construct, it will not possible, so we will extend it to make it look like a cone. Okay, so construction of the cone, using the formula small r by capital R into 360 degree, we can do that. So just I'll extending that. Okay, tapered part, so it will be easy for us when we do the development of it. Okay, so I can measure this dimension, how much it is. So it is around 60 or 62 mm. 62 mm. How much you are getting it? You need to draw for the same length. So in order to understand this problem completely, guys, you need to watch it till the end. Okay, so you can understand all the steps. So now we will be constructing the top view of the cylinder. Okay, because in this problem the cylinder has been beveled. Beveled means cutted, so that means we will be constructing only the top view of the cylinder. Okay, so here the cylinder having a diameter of 30, so I'll be taking compass. The radius will be 15 mm. 15 mm means 1.5 centimeter from the scale. We need to measure. Okay, draw a circle. So we need to project that axis downward, and then we should consider the center. Here I am taking directly the center point of it. So you need to project downward that axis and then take the center point and draw a circle. Okay, so after drawing the circle, so show the dimension. So here we will be cutting this, dividing this circle into 8 equal parts. Okay, diameter 30. So in order to divide into 8 equal parts, we will be using an angle of 45 degree. So using the protractor, we can do it. Okay, so mark angle 45 degree, 90 and 135. Okay, I think the points you are not able to see it properly, so I'll be using the sketch pen so that you can get the exact points. 45 degree here, guys, 45 degree, 90, 135 and 180. After marking it, you can extend, right? Using the scale, we can extend from the center point, merging it and draw the line. Okay, okay, now it is divided, so you can give the naming for these cut parts: A, B, C, D, E, F, G. Okay, now we'll just project it upward so that we can write the top and front view notations. Okay, here I'll differentiate this top and front view. Okay, with XY line, so that we can able to clearly understand it. So top and front view. In this problem, guys, we are starting from the front view and then finishing up the top view. Okay, the problem is like that only. Usually we start from the top view, but in this problem we started from the front view. So draw the projection lines. Now write the namings. So here A dash, B dash, C dash, D dash and E dash visible. H dash, G dash and F dash are not visible. Those are written within brackets. Okay, now we need to write the cut points. Okay, so here so cutting exactly 1, 2, 3, 4. You can see wherever the section plane is cutting, right? So we are writing again here 6 it is, this is 7 and this is 8. Okay, so part by part we are going to do the development of it. Now we have done the cutting also. Okay, step by step we are going to follow it. Okay, this is the funnel and this lower part is the cylinder. So step by step we are going to do it, guys. So watch it till the end, you can understand all the steps. Okay, this is one of the, I can say, the application problem. The first we are doing it is cylinder. Okay, the cut portion cylinder. So here for the cylinder we have the formula pi d. Okay, pi into diameter. Diameter here it is 30. Okay, diameter of the cylinder is 30. So the length what we get, that is 94.24. So this cylinder will be done using parallel method. So I'll be using here 2 parallel lines, here x from this end and also from this end. Okay, so we'll be considering one vertical line. So the total length we should be considering, that is 94.24. So mark 9.4 here. 9.4. Okay, now we need to divide this 94.24 into 8 equal parts. Okay, the thing can be done by using measuring the compass. You can measure the length from this top view circle. Okay, measure this length and cut the arc. So it will be equally divided. Okay, this is A, B, C, D, E, F, G, H and E again. Okay, use the scale properly, guys. You need to draw straight vertical lines. Okay, okay, now the marking the cut points on this development, it is easy. Just draw horizontal lines from those cutted points. From one, just place the scale like this and just draw horizontal line. Okay, from the point 2 also you do the same thing, and from 3 also the same thing. So this cylinder and prism will be constructed in the same manner, guys, because all the cut points are occurring at these vertical edges. So no need to measure, just draw the projection lines and then now we mark. This is the point number 1 here, and even here on the vertical edge of A, now it is 2. Okay, 2 on the vertical edge B and 8 on the vertical edge H. Same way 3 on C and 7 on G, and then 4 on D and 6 on F, and then 5. Okay, now we need to connect it using the curved line because this is a cylinder. Okay, with the help of color sketch. This is what we need to connect. So using the curve you need to join. Okay, don't use the scale here. Okay, okay, so guys, this completes the cylinder. So I'll be showing the dimension. So this is the development part. Okay, development of this beveled cylinder, that is a cutted portion of the cylinder. Now we need to construct the funnel. Okay, funnel, we will be constructing a funnel using this cone method. So for this we have the formula. Okay, funnel, it is resembling the cone. We have the formula small r by capital R into 360 degree to find out the angle of inclination here. Okay, first I will be finding this slant edge length. So slant edge length, it is 62, and that upper part, okay, upper part which is visible to us, that will be around 22 mm. I think 29 mm it is, sorry. Okay, so capital R, it is 62, that is slant edge length, and diameter D is 60 mm. So that means R means radius will be 30. Okay, because we need to use this formula in the construction of the funnel, that is small r by capital R into 360. So capital R is your slant edge length, small r is your radius length. Okay, substituting the values. So and then the angle we need to calculate using the calculator. Here the angle we are getting, it is 174 degree. Okay, so capital R we know it is slant edge length. So I'll be drawing one horizontal line for a length of using compass, or you can draw a straight line also. So take 62 mm and draw an arc here, curve here. Okay, some semicircle type we need to draw, because here the angle it is 174 degree, right? So I can join this. This is having an angle length of 62 mm. You can mark. Okay, so that is your slant edge length. Capital R. Okay, so the angle we need to mark here, it is 174 degree. Okay, that is our angle. Guys, so subscribe to my channel and hit on the like button, and for notifications related to engineering drawing you can click on the bell icon. You'll get all the notifications related to the video engineering graphics, or you can say the computer aided engineering drawing. Okay, now complete the arc. Okay, now here the length we should be drawing, that is the visible part of that funnel, that is 29 mm we need to mark. Okay, guys, this is my 700th video, so thank you for your support, so that I can grow my channel. I wish my channel may reach 1 lakh subscriber by another 2 or within 2 to 3 years. I hope so. Can cut the length, that is 29 mm. Okay, so okay, this length we should be darkening it. So I'll be using different color chalk here, sketch pen, so that you can make out the difference. Okay, this is the upper part of the funnel, right? That's why we need to show the lower part here in this development. Okay, guys, when you are going through my channel, if you are finding any difficulty in understanding, you can ask me your queries, doubts through comments, or you can mail me. I have given my email ID in the YouTube channel and my WhatsApp number also. So any doubts related to any of the videos, you can WhatsApp me or you can email me, so that I can help you. Okay, share these videos to your classmates and friends, so that they can be benefited. So guys, thank you all. Thank you for watching my video. So this is the development of the upper part of the funnel. Okay, so now you can see in this video both the things are done. So lower part of the cylinder also done and upper part of the funnel also done. Thank you guys. Thank you all. Thank you for watching my video.